Hi everyone, we are starting
Hello.
PG Day Russia, the international English-speaking track. It was a long time since we had our last conference. First problem, the football championships in St. Petersburg. Another year in a row it was the coronavirus. We still have the second problem, luckily not the first one. And I hope this not very common for us yet format, which is like widespread in the world now, will work today. Yesterday we already had the Russian-speaking part. Today we have a beautiful lineup of great speakers from our community. And hopefully next year we can welcome everyone in St. Petersburg again and have some fun there.
Yeah, thank you.
A couple of
Ilya.
technical moments,
Yeah. So we'll just reiterate the some of the organizational moments as Ilya mentioned. For those who hasn't joined us yesterday or maybe have just forgotten. So basically, you can view the stream on YouTube. There's a chat where can you leave your questions for the speaker or just general comments, something you might want to share with everyone. And you can also do the questions in the special Q&A chat in our Slack channel. So feel free to use that as well. If there are many questions or if you just want to speak with our speakers after their talks, there will be still available a Q&A rooms which you can join after the talk and just ask anything you want on the topic from our speakers.
And
Yeah.
small comment, if you for our Russian-speaking audience, if you're feeling not well to ask directly in English, just write it in Russia. Me and Roman will translate it and ask the speaker. So no problem.
Absolutely. We will communicate your questions nonetheless. And I guess we can start to introduce our first speaker for the day. Ilya, would you do the honors?
Oh yeah, sure. It would be an honor for me. So our first speaker today is Stefan Fercot, and this is one of the person behind the pgBackRest, one of the person who actively developed it, and it would be a great technical talk with lots of interesting details. And welcome, Stefan. So nice to see you.
Hi, everyone.
PGD Russia.
Yeah, thanks for having me there.
Yeah, you are very welcome. And it's almost the time to start with. And well, okay, let's have a fun with pgBackRest.
Yeah, thanks. Yeah. Okay, so welcome everyone to this presentation. I'm Stefan Fercot. I'm living in Belgium, and I'm also known as pgStef. You can find me under that nickname on Twitter, on GitHub, and so on. I've been using Postgres since more than 10 years now, and I have always been interested in all the backups and high availability field. As Ilya said, I'm a big pgBackRest fan, and I'm currently working at EDB as database backup architect. So the talk today, I would be glad to share you about some insights about pgBackRest. I would like to go a little bit deeper as some just basic knowledge, but I first have to give back some basic functionalities reminder so everyone is at the same stage. And then we'll go through various advanced topics like where do I store my backups, how do I interact with the standby server, what is asynchronous archiving, and then what are the catch-ups and tips and tricks about diagnostic and monitoring. So pgBackRest, it aims to be a very simple and reliable backup and restore tool. It has been written in C, and the latest release in June was a 2.34. You can use it all locally or remotely, so you can operate two ways. And the the protocol of communication between the local and the remote process is a custom protocol and is using SSH. So let's start with the basics. The basics, well, the first thing to do is to install pgBackRest. Thanks to our great pgDG community, we get all the packages in the repos. So use the repos and use yum or apt-get to install pgBackRest. That's the easiest way. Then you usually have to configure your backrest. There is a configuration file, that's an ini style, and you have basically two parts there. The first part is the global part. The global part is where you will define all the settings that are related to your complete environment, meaning what are the log levels that you want, where do you store your backups, what are the retention settings, the compression settings, encryption settings, and so on. So everything that is global to your complete installation. And then we have something that we call stanza part. The stanza part is where you define your Postgres cluster. Postgres cluster can be one host or multiple hosts if you have primary and standbys. So typically, your PG data path. The stanza is just a name, but the name of the section, the name of the stanza that you will use should be something meaningful for you and not simply localhost or production or so on, because if you move your data to somewhere else to test or restore or so on, you will lose the meaning of where it comes from. So use a meaningful name for you. Here in my example, I just named it my stanza. pgBackRest relies on the point-in-time recovery of Postgres. So you first need to configure the point-in-time recovery, the continuous archiving in Postgres. To do so, you have to enable the archive mode and change the archive setting, the archive command setting in Postgres. Then you're ready to go. First, you have to initialize your repo with the stanza create subcommand. Stanza create will only create subdirectories inside your repo and build some manifests just to make sure all the information comes from the good Postgres cluster. And then we can check that everything is working with the sub check command. The check command will only ask Postgres to trigger a new archive, and we'll check that the archive is coming to the repo. So just checking that the archiving system is working. Our continuous archiving is working, we can take our backup. Backup is pretty easy. It's the backup subcommand with the type of backup you want. After a successful backup, the expire command will automatically be triggered to remove your old backups. So expiration is done based on backups. Which types of backup do we have? The first one is the full backup. It will copy all your database cluster files, and there will not be any dependencies on previous backups. So everything stored in there. And then you also have the possibility to have incremental backups. Incremental meaning we will only copy the database files that has been modified since the last successful backup. A successful backup, it could be a full backup or it could be an incremental backup. So you could have a chain of multiple incremental backups. To avoid any problems in the chain of backups, you could also have differential backups. Differential backups will only copy the database file that has been modified since the last full backup. So it's not relied on the incremental backups or the intermediate backups. It will only rely on the full backups. So that's the three types of backup we have. Once you have taken your backups, your system is running with archives and so on, you might want to know what's inside your repo. To do so, use the info subcommand. The info command will give you an overview of what's inside your repo. An overview of your backups, when it was taken, what WAL files are related to it, And also, the repo is split in two parts, the backups and the archives. So you will know what's the oldest archive in your repo and what's the latest one. You won't know anything in between because the info command is designed to answer fast. So you only have the information based on backup manifest or just the oldest and the latest WAL files there. So it's pretty fast and pretty helpful. Now that we have reminded the basics, we get the answer to the question, where do I store my backups? The first recommendation is do not keep your backup storage with your Postgres host, because if you lose your server, you lose your Postgres data, you would lose your backups too. So don't do that. We have two ways of communication with pgBackRest. We could push directly our backups to any repository types that is directly attached to our Postgres host, or use a dedicated backup server. What kind of storage do we support? We support multiple types of storages like cloud, Azure, Google Cloud, or S3, or even a network storage inside your infrastructure like CFS or NFS mount points. So it's various storage types. In case of the storage is directly attached to your Postgres host, you can take your backups from your Postgres host and it will be pushed to your repo. But you could also ask a dedicated backup server to take the backups. To do so, it's pretty easy. You first install pgBackRest, then you create specific system user for that, and you set up passwordless SSH connection between your backup server and your Postgres host. And the communication has to be both ways, because the backups will be taken from the dedicated remote host, but the archives that are pushed by Postgres are pushed from the database host to the backup server. So communication must be working in the two ways. Then comes the configuration part. Here you get the same thing as we mentioned earlier, the global part and the stanza section. On your Postgres server, the global part will define where is stored your backups. Where it's stored on your repo host, named backup server, for example, and which system user do you define. The stanza section is where does your Postgres data live? Here it's locally. On your dedicated backup server, same thing. Global part is where do I store my backups? Here I just simply defined a local moonpoint named backup space. But it could be on an S3 storage. It could be any storage you want, any storage type that we've just seen. And then the stanza section. To be able to communicate with Postgres, we need to know where it is located. So what's our Postgres host? Here I named it pgSQL server. And which host user do we use to connection to SSH? So that's always the same thing. First, global section is where do we store our backups, and stanza section where our Postgres lives. So what's the difference between pushing directly every command from your Postgres host and using a dedicated backup server? In any case, archive command is triggered by Postgres itself, so it will always happen from the Postgres server. The backup command is triggered on your repo. I mean, if your Postgres server has a directly attached storage, then the backup command can be run on the Postgres host. But if you have a dedicated backup server, the backup command will run there. And finally, the restore command. The restore command only restore data locally. So you will use the subcommand restore where you want to restore your data. So not on the backup server, but on the Postgres host. So that's for the configuration. of one repository. But last April, we introduced multiple repositories. Why? Because we can have redundancy, or we can have various retention settings. Here, the example is pretty simple. We get two local repositories with various retention settings. More full backups in one, less in the other. What's the impact of that feature? We'll have to look at each subcommand that we've just used and see how they react. First thing to know is that there is now a new repo option, a new command line option. It is backward compatible because it's not required when you only have one repo configured. And just a recommendation, but when you have a single repository configured, it's recommended to use repo 1 in the configuration. No, not repo 2 or repo 3, use repo 1 if you only have one. We'll see why in a moment. So have a look at various subcommands that we mentioned. Stanza create command. Stanza create will only create subdirectories inside a repo and so on. So if you use it, it will automatically operate on all configured repos. Meaning, if there is already a repo 1 and you had a repo 2, you can rerun the stanza create. It will only check that everything is fine with the repo 1 and initiate the repo 2. Check command. Check command is just triggering a new WAL segment from Postgres and tries to push it to all defined repos. So we will wait that the same WAL segment is archived to both repos to make sure the archiving system is working fine. Archiving system. Archiving system is using archive push command. The archive push will try to push the WAL archive to all reachable repos. What happens if one repo fails? If one repo fails, the archive command will fail, so Postgres will not remove or recycle the current WAL file. To bring some fault tolerances, we can use archiving asynchronously. We'll see a little bit later what's asynchronous archiving, but you just need to know that the idea behind asynchronous is to go archiving things before Postgres asks it. So we could archive things in the working repos before Postgres asks it. We'll see that in a moment. But basically, the archive push command will try to push the WAL archive to all reachable storages. And then come the backups. Backups need to be scheduled individually for each repo. If you don't define the repo option, the highest priority repo will be used. Highest priority being repo 1, then repo 2, then repo 3, and so on. Here in the log, you get an example, repo option not specified, defaulting to repo 1. And that's also why we recommend to use repo 1 when you get only one repo. Because let's imagine you use repo 2, take your backup, it will default to repo 2, and everything went fine. And then you add repo 1 because you want redundancy. Suddenly, your command that run usually fine sending things to repo 2 will now send things to repo 1 without you knowing. So it's really better to use repo 1 if you get only one repo. Also, that's important to remember that the expire command is triggered on the backup command. After a successful backup, the expire command will be triggered. And it will remove archived based on what backups are inside your repo. So if you don't have any backup inside a repo, the archives could pile up in that repo and never be expired. So pay attention to it. Now that we took backups, we might need to know what's inside a repo. So basically, if you don't specify the repo option, you will get everything from every repo, and the backups will be sorted by date. So it will be mixing the repos. It can be a little bit confusing to find out which chain of backups you have, because it will be across multiple repos. Here in the example, we see that we get the oldest while archives in both repos is A, and the latest one is C. If we go deeper and just want to know what's inside repo 2, well, repo 2 says that we get full backup in repo 2 needs only the while backup being C. So we get the oldest while in that repo being C. Why? Because I just said expire works on backups. So it expired A and B because it doesn't need it. So usually, and let's hope you will never have to do that, but you might need to restore. In case of restore, the recovery command, the restore command of Postgres is automatically defined and use the archive get command. The archive get command is the other way around as the archive push. It's basically taking archive from the repo, feeding it to Postgres. Archive get will look inside the repos in priority order. So it will first have a look at repo 1 and then repo 2 and so on. The idea is to have repo 1 the closest to your data, actually. Let's imagine you have multiple repos, but you have one inside your network being in NFS storage and one in the cloud, like an S3 bucket. Well, you might want to define repo 1 being locally in your infrastructure because, yeah, the archive get command will pull archives from there first. So it's easier and faster to have it closest to your data. And it also means that it tolerates gaps, because if it doesn't find a while segment inside one repo, it will try to look inside the other one to get it. So it tolerates gaps, and it's a very nice improvement. And that's it for the multi-repo feature. So now we can go a little bit deeper with less common operations. pgBackRest is very handy when you have multiple Postgres hosts inside the same replication cluster. I mean, primary and standbys. Usually when you have a standby server and it's lagging too far behind the primary, you have to refresh it. But you probably don't want to take a new complete copy of your primary. So you could use your point-in-time recovery backups to refresh your streaming replication standby, or even create a new one. To do so, your repository storage needs to be reachable from your standby server, of course. You could add an extra Stanza configuration on the standby. It's recovery option. I'd assume you know how to build the streaming replication yourself, but the most important setting is the primary con info in Postgres. So you could ask pgBackRest, when you do a restore, add this primary con info to my Postgres settings. And then perform a delta restore. Of course, if your primary is more than 1 terabyte, you don't want to copy over 1 terabyte again. You probably only need the last few days. So you could use delta restore to only get back the data files that has been modified, compared to, of course, what you have locally and what you have in the backup storage. If you are creating a new streaming replica, you don't need the delta option because your data directory will be empty, but the delta restore is pretty handy to refresh an old standby. So using the restore command with delta option with the standby type will add accordingly standby mode or standby signal file. So using that command will simply restore point-in-time recovery backup, adds the primary con info, add everything needed for the standby section, and add the restore command. Restore command being, we'll replay all the WAL archives until the end, and then try to connect to the primary using the streaming replication protocol. So it's pretty easy and pretty handy. But what if we have primary standby? We might want to take backups from the standby. Well, it's easy. We get a backup standby option to do so. But then we need in our stanza section to define our locally running standby, so our PG data file, but also define where's our primary, being PG2 host here is called primary and what's its path. Why? Because when you take a backup from standby, first the backup started on the primary using pgstart backup. We will get there what's the WAL location, and we will await that the standby has actually reached and replayed that same location before starting to copy the files from the standby itself. So it's kind of hybrid situation because we have operations going on the primary, but the actual files will be copied from standby. And it's even more handy because pgBackRest is able to detect itself which one is primary and which one is standby. So imagine you have an high availability setup, like using Patroni or something like that, and you get a dedicated backup server defining your Postgres nodes, PG1, PG2, PG3 there, and you want to backup from standby. You won't even have to change your configuration in case of failover, because if the standby is promoted, it will no longer take backups from there, but from another node. And pgBackRest will be able to detect automatically which one is standby, and so from which server to pull the backup. So it's really handy to have a dedicated backup server in case of failovers and so on. So you don't have to reconfigure your backups or your cron tabs in case of manual failover. So that's for handling standby servers. Now comes the archiving system. So the archive push command is triggered by Postgres inside its archive command setting. If you use asynchronous archiving, we will in fact, when Postgres asks to archive one WAL file, an extra processes. If you use multiple processes, an extra process will look at Postgres which WAL files are ready to be archived, but not requested yet, and try to archive it already, so being ahead of Postgres. And when it's done successfully, we will write in a spool path an acknowledgement file, just temporary data saying, okay, I've been archiving this one. So when Postgres will require it, will request to archive that WAL, it will already be done. And BackRest will be able to simply say, okay, so it's speeding up the archiving system by using multi-processes. The more processes you have, the more WAL files you will archive simultaneously. That brings us to the full tolerances of the multi-repo feature, because each time Postgres will ask an archive, even if it's blocked on one repo, the async process will still fetch what is ready to be archived and push it to the repo that is working. So archiving asynchronous is really handy and really fast. So it's really helping in case of big WAL activity. But what if your archiving system is blocked when Postgres will keep its WAL archives? So it could, at some point, block Postgres itself, because if you run out of disk space, Postgres will stop. So there is an option named archive push queue max, which is actually the maximum size of Postgres archive queue you want. Let's say 10 gigabytes, for example. when you will have 10 gigabytes of WAL files ready to be archived, more than 10 gigabytes, well, pgBackRest will in fact tell Postgres the archive command was successful, but it will not push the archive, because probably your archiving system is blocked, your repo is full or not reachable or whatever. So it will unblock the situation from the Postgres point of view, but it will generate missing archives in your repo. So it's handy to prevent any production problem, but it can corrupt your archive chain. So it's very, very important to monitor your archiving system, your disk space, and ensure that everything is working fine, because you could have missing archives. Use that setting with a lot of precaution. I don't really personally like it, but it can be handy in some cases. And then the other part is archiving get, so the restore command of Postgres. If you use multi-processes and asynchronous processes, the idea is to speed up the recovery by already prefetching a certain amount of WAL segments from your repo to the local spool path. So it's usually best to keep the spool path next to your Postgres WAL directory in the same disks. Let's say you will restore and trigger archive gets and so on, but your repo is an S3 bucket, it's pretty slow, it's pretty far. You could have multiple processes already prefetching the WAL segments locally from the S3 buckets before Postgres needs it for the recovery. So it's pretty handy to speed up the recovery. And finally, in this section, a pretty handy trick too is the selective restore. In case you have a big cluster with multiple databases, and sometimes you only need to restore one database to extract some data there and reject it afterwards in your Postgres data, well, you can use a DB include option. DB include option is only restoring the included option, the included databases. The other one will be restored empty. The built-in databases, the system databases like Postgres, will always be restored unless you exclude it specifically. So that's when you need to only extract one database. But if you want to extract all your databases except one, you can use DB exclude. DB exclude will, well, restore the empty database that you excluded. And when you combine DB include with DB exclude, well, DB exclude will only refer to the built-in databases, meaning I want to include my DB and exclude Postgres. Why do we restore it as empty and zero in files? Because you will need those files for the recovery. But once the recovery is complete, the databases won't be reachable. So you don't need it anymore. And if you want to keep running with that cluster, you need to drop database to remove those empty databases. Of course, if don't do that in production, do that for extracting data that you need to re-inject in production, but that's not really intended to do in production. So pretty handy when you have multiple databases inside the same cluster and that they are pretty big. So now comes the diagnostic part. The first interesting thing in Postgres or in BackRest to prevent data corruption is checksums. Fortunately, currently the data checksums are enabled when you create a new cluster at the init time. My recommendation is when you create a new cluster, enable data checksums. We get this nice tool named pgChecksums in Postgres that enable or disable or even check data checksums only when your cluster is offline. If your cluster is pretty big, it can take time to bring it down, check the checksums and so on. That's not pretty handy. But once your checksums are enabled, pgBackRest will be able to automatically enable database checksums validation while it's taking the backup. We are copying data, so why not checking checksums at the same time? If there is a checksum error, you will get that into the backup log. You could also see in the info command, if you specify the option --set and your backup set, you could have a bigger summary than the one I've presently shown. And if there are checksums errors, they will be shown there too. So that's pretty handy if you have checksums enabled. Backrest will be able to check it while it's taking the backup. I often see also a misunderstood feature, a misunderstood command. The check command doesn't check your backups. It checks that your archiving system is working by calling a create restore point inside Postgres and asks it to pg_switch also to generate a new archive and make sure the archive comes up in the repo. So the check command doesn't check your backups. Sometimes when you get archiving system failing and you need more info, well, you get multiple levels of logs. The first one is the console log. When you run the command yourself in the command line, you will see console output. And for some commands like backups and restores, you get a log file. So in the log file, you could have more information. But the archive push command is triggered by Postgres itself. So it doesn't have really a Postgres log file for itself, because the console output will be sent to the Postgres logs. So if you define a log level for your console pretty low, and don't want too much info, you might need to add some extra debug option just for your archive push command. That's pretty easy to do in the configuration. You just simply say in the global section for the archive push command, just apply the setting log level console equal debug. That will send debug logs to the Postgres logs each time the archive push command is used. So it's pretty handy. Archive push has log file for itself when it's using asynchronous. The asynchronous processes will push to the log file because it doesn't have any console, since it's triggered automatically asynchronously. So archive push is a little bit tricky to debug because you have at some places you have the Postgres logs and you have the async logs. So 2 places to check. So how could we check our backups? Well, there is a work in progress with the verify command. It's internal only for the moment because it's work in progress, but the idea is to go through the backup manifests and check on disk if the checksums are correct for the WAL files, for the backup files. So if there is missing pages from the manifest on disk or a checksum that is invalid, they will report. It should also report missing archives, but we'll see in a moment that it's not working yet, and I'll explain why. The best way to know if something is going wrong is monitoring. Don't forget the Schrödinger's law of backup. The condition, the state of any backup is unknown until you attempt a restore. We've seen that we can get more information about what's inside your pgBackRest repo using the info command. You could go a little bit deeper and construct your own summaries by using the JSON output. So using, for example, JQ for getting some more information. Or you could use the Nagios plugin I wrote named Check pgBackRest. Check pgBackRest will help you whatever the backup location, because it will use internal pgBackRest commands like the info output with the JSON output and the repo commands to get to the repo and see what's on disk. Because currently the verify command doesn't go on disk, it's just checking the manifest. has a nice retention service. A retention service, when you define retention settings in BackRest, you ask, let's say you ask for 3 backups and take the first one. You won't have an error saying, oh, I only have 1, I should have 3. It's the first time you take a backup, that's normal, but you don't know. So you might need to have an alert or some kind of warnings to know that you have at least some amount of full backups, or that your latest backup is not older than a certain time, or the latest successful full backup is not too old. So to check that, you can use check pgBackRest. It has by default an aegis output format, but it also have the nice human output to give you a summary. So you can run the tool manually to get more insights of what's inside your repo and check if you have enough full backups. You can mix multiple arguments together. So I want at least 1 full backup, less than 24 hours for my last backup, and the last full backup must be not older than 7 days, for example. You could do that. And then we want to check the archiving system. I've said that the info command only shows the oldest and the latest WAL files on the repo. It won't check anything in between because it has the answers fast, and there could be a lot of archives there. It could take time to check it one after the other. So the info command won't. And currently the verify command is only experimental, so in development status. Check pgBackRest will be able to go to disk using the repo commands internally from pgBackRest itself, check what's in there, and then get you some kind of summary. What's inside the repo? Is there any missing archive or not? If you build your own system, pay attention that you can encrypt your repo, and you need to know what the encryption key is. So using the internal commands like repo ls or repo get can be handy, but you need to know the internal commands of pgBackRest to do so, and check pgBackRest is delivering these commands. Good example. Let's say we will remove a WAL archive from the repo. The info command won't report it. We remove the 5, and it only says we got 3 and 6 inside the repo, but it doesn't detect the 5 is missing. And the verify archive command is not telling that it's missing too. So pgBackRest won't report an error yet. Check pgBackRest will, at least at 2 different levels. You will get a critical alert if the missing archive is after your last successful backup. Why? Because you would be able to restore your last backup, but not reach the now. Not reach now, because there is 1 missing archive. You could restore until your missing archive, but not later. It will raise a warning if the missing archive is before the latest backup. Why? Because, of course, you could restore the last backup and replay all the WAL files until now, so your pointing time is not really broken. But there is some missing pieces between your last archive, at least between the missing archive and the last backup. So there could be gaps, but the pointing time recovery until now is not broken. And so voila, that's basically it. You could have a lot more information on the official website. There is a big list of all the settings, what they are doing, and so on. There are official user guides for Debian and for Red Hat. The code is, of course, open source. Regarding user guides, you can also find useful tricks, useful use cases on my personal blog post. And check pgBackRest is also an open source project on GitHub. And of course, thanks to our great PGG community, the packages for both pgBackRest and check pgBackRest are inside the pgDG repos. So in conclusion, backrest is very powerful. It will help you with a lot of features, meaning multiple repositories, selective restore, asynchronous archiving. Well, it's pretty handy and with a lot of features. But don't ever forget the Schrödinger's law of backup. And the best advice I could give you is monitor your backup, your archiving system. That's really important. Anyway, thank you all for your attention. And voila, I've done for today.
Okay, thank you very much, Stefan, for the extensive overview. And we have plenty of questions, if I'm not mistaken.
Yeah, we do. We do actually. So it was lots of details, and lots of details cause lots of questions. Let's start with YouTube chat.
There's yeah, all right. There's also a very light question available on Slack.
Let's start with that.
To start with it, yeah. One of our listeners asks, it was always interesting, why did you choose the term stanza for the utility? Why was it chosen as the name?
Well, it really depends on what usage you do of your Postgres cluster, in fact. What data do you have there? Is it a website? Is it a specific application that you have developed inside the company? It's just using a meaningful name for you. For my demos or my tests, I usually use demo or my stanza or something like that. It's just for testing purposes. But in production, usually you get something meaningful by your cluster, your Postgres cluster current function, actually.
I think actually the question was why this strange name stanza? What does it mean?
Oh,
yeah.
I don't really know where it's come from. I think it's come from Latin, but yeah, it's just
Yeah, it sounds Italian.
Yeah, that's something like that. I think it means cluster or something like that.
Okay. It was probably some nice name picked up by David.
Yeah,
I think so. And I think actually he explained something like it should be different from common terms, like cluster is reserved for many things in Postgres and always confusing. What does it mean? But I'm not sure.
I think he explained that in your Postgres TV interview.
Yeah, something like this. If I
just to let the audience know, but behind the tool there are multiple persons, but also Crunchy Data, and with David Steele, Stephen Frost, Cynthia Chang, there are multiple contributors behind that tool. I've been recently helping them, so I'm one of the contributors now. But yeah, the original developers are Stephen Frost and David Steele. So yeah, there was a very interesting session by interviews with Ilya some time ago in Postgres TV, and yeah, I remember that was a question too. Why stanza? Because all the names were taken, basically.
Yeah. More technical question. Do we really need to call pgstart backup on the primary for non-exclusive backup that exists since 9.6?
Well, I'm not sure we absolutely have to, but we want to, because we want to make sure that the standby server has catch up with the primary, and that the database files has been synced by the checkpoint locally on the standby server before copying the data to the backup. So we have a backup inside the repo that reflects where the primary was at the start of backup. So that's why that's chosen to take the start backup on the primary and not the standby, because that way we are making sure in sort of that we are at the same stage as the primary is.
Yeah.
But indeed, I'm not sure pgstart backup couldn't be executed on a standby server directly, but yeah, that's not the goal.
Great. That was a small discussion about point-in-time recovery, which probably we can skip now and ask the question from Slack. Is there, because partially that question was already answered by others in the chat. Is there any plan to add table of backups, like a list and database? There is the text one, there is the JSON one, but do you plan to add something which looks like a table because it's more convenient to query?
Table like in Postgres, you mean?
Yeah.
Well, you could do that. I think there is an example inside the user guides by how to load the JSON output from Postgres and handle it like a table. You could do that, but I don't think we will add an extra output format for the info command. Of course, it's an open project, so if someone wants to try it and develop it and suggest it and submit it, it's welcome. But well, since we can actually trigger the info command from inside Postgres and play with that inside locally, not sure it's really important to do that.
Okay. There's another question. Do you have plans to add database information to info output JSON? For example, -- output JSON stanza demo set backup name. Currently, information is only available for output text option.
Well, I'm not sure about the question because the info command is basically using the same information and just parsing it, outputting differently. But I'd had to check. Of course, same thing. If that's something someone needs, just raise an issue or ask it and we can have a look at it.
Yeah. So I think the person who asked this can go to Q&A session and ask that in details.
I know we can add some more information inside the info command. For example, I know that currently a good example is the checksums errors. The checksums errors are only shown at the backup set level. So you have to force the backup set level in the info command to get the checksum reports. We'll plan to, I don't know when, because of course it's an open source project, so we have a lot of going on, but there is a card in the project board to add more information about the checksums directly into the big summary and not inside a specific summary.
Yeah.
So yeah, there will be a lot of improvements on the info command. We can make plenty of improvements, but the question is always choose the best priority.
And probably it is good to give feedback from the users. If you want developers to make something, just explain them why you need this, what's your use case, and so on. They usually listen.
Yeah, the GitHub project is a good place to do that. And for newcomers who would like to have contributions and would like to help, the info command is actually a good starting point because it's not the most complicated command to see how it's working and to get multiple output formats and so on. It's perhaps a good starting point if someone wants to make a first contribution. The contribution guide has been updated lately, so yeah, it should be helping.
The question about point-in-time recovery, which was discussed in chat and not cleared quite. I didn't quite get, that's the question, I didn't quite get the part about point-in-time recovery backups. Can I restore at any time in the past or only at a moment then the backup was created? Which is...
Okay, so that's basically how Postgres works. Postgres works as two parts. The first part is the base backup, so the backup of your data. If you take it while you're database is running, you will need the WAL archives between the start point and the stop point of your backups to reach a consistency point, because currently all the transactions that are happening on your running cluster will be written inside the WAL files and reach the archives. So the first thing to know is when you take a backup, you can restore that backup, and you at least need the archives generated between the start point and the stop point to get a consistent backup. So that's the first thing. And then we have continuous archiving. So that's why we set up the archive command in Postgres. The archive command is running all day long, not only while you're taking a backup. So at any point of the day, you would have WAL archives. Every transaction that happens to your cluster goes to the WAL files. So you could, let's say you take a backup at 11 p.m. and we are now 7 a.m. You restore the backup, you replay the WAL archive. Postgres replays it itself, but Postgres will replay the WAL archive until the consistency point, and then you specify the target you want to reach. So now 7 a.m. So it will replay, or try to replay all the WAL files it needs until the target is reached. So it's pretty up to us to know where to stop. If we want to go before a drop table or something, it's usually pretty hard to find the good target. But if at a specific time, it's pretty easy to reach that time, given you don't have any missing WAL file. Because of course, you have your base backup, you have your archives to bring that consistency. If there is one missing archive there, your backup is not consistent. So that backup is useless. If you have all your WAL archives there, backup is consistent. Then you have the continuous WAL archive for the day. Let's say we are now 10 p.m. here, 10 a.m. here, 10 a.m. Let's say we have a missing archive at 7 a.m. this morning. Well, you won't be able to get to any point between 7 a.m. and now, because there is a missing archive at 7 a.m. But you could go until 6 a.m. That should be fine, because you have all your archives. So that's why it's so important to have a monitoring of your archiving system, because yeah, you have the base backup and its consistency, but you need your WAL archives if you want to restore to any point in time between two backups. Well, I hope that answers the questions.
Yeah, I hope as well.
It's usually better to explain it on a whiteboard and with drawings and so on.
With timelines, yeah.
Yeah.
And another question which we have, is it possible to make some sort of detached restoration of the database as a snapshot without a repository? So basically make some sort of archive and then move it to just another cluster and there restore it? Or you always need entire repository to do this?
You don't really need the entire repository, but you need the manifests that's inside it. That's the most difficult point. Actually, inside the repository, you have manifests. So you have one manifest per bucket, but you also have one global manifest. And you could use some options like archive copy to actually, at the end of backup, copy all the WAL archive the backup needs inside the backup directory itself, which usually is not done because you have two directories, one for archives and one for backup, but you could specifically ask to get your archives there. But using BackRest to restore it, if you don't have the backup manifests, the global manifest is pretty hard. So if it's in the manifest, it should go fine. If not, that could be difficult. So usually we don't tend to copy things from one repo to somewhere else. We try to recommend that the test server or whatever can read the repo on read only. So it can get data from there, but not push any wrong archive there. I know that we are planning some time to to be able to take backup or restore a backup to outside the repository, specifying a specific location for that backup to be taken or to be restored from, but we are not there yet. Currently, we need the repo because of the manifests.
Clear. So
even if it's partial, I mean, even if you only have, let's say you have 3 full backups and you want to copy only the last one, if you have the backup manifest, the global manifest saying you have 3 isn't a problem if you specify it afterwards, but you need those manifests.
Yes. Probably the last question, because we're running out of time, before we move Stefan to the our corridor to ask further questions. So the question is, are you considering a partial backup, not only partial recovery? So it's a slightly strange question from my point of view, but anyway, so can you back up a single database on the cluster?
That's against the Postgres rules, so I don't think so.
Yeah.
Yeah, basically the WAL files are covering all the databases inside the cluster. So yeah, we couldn't take a partial backup from, we could, but it would have any point.
Yeah, it would be like very strange from the security perspective, actually.
Well, it's at some point we have in Postgres wildfire that are only related to any database in the cluster and not the cluster, the entire cluster itself. Perhaps, but we are not there yet in Postgres. So
yeah, so it make actually no sense. Okay, then let me say thank you, Stefan. That was like very, very informative talk, and amount of questions is self-evident. I think some people will have more questions, so we move you to a separate QA zone to answer them if there are some. And thank you again. Thanks for coming.
Thank you for listening.
Stefan.
Yeah.
Okay, guys, we are back live, and I'm ready to present our next speaker. Please let's welcome Vignesh. Vignesh has been involved with the Postgres internals for quite a long time. He's really an expert in many things, one of which is a logical replication feature that we are going to talk about today. Vignesh will tell us all about what is logical replication, when do you use it, what are the features of its architecture, pretty much everything that there is to know about logical replication. Vignesh will help us out with that. So, hello Vignesh, the stage is yours. As I say, please take it away.
Yeah, thank you for the introduction. Hello all, I am Vignesh. I am working with Fujitsu India. I'm basically from India. So I've been working, I have been using Postgres from last 10 years, but have been more active in Postgres from the last 3 years. My area of interest is on logical replication and parallelism. Today, I will be presenting a talk on logical replication. So my agenda for today's talk will be what are the different replication types, and then a brief introduction about them, and what are the different use cases for logical replication. There are few restrictions that are present with logical replication that we need to take care. I'll mention those, and then what's the architecture, a little bit of internals, how it works, and so there are we use the terms publication and subscriptions quite often. So I'll be explaining what do you mean by publication, what do you mean by subscriptions, and we need to handle some configurations before we do the logical replication setup. So what are the configurations, that main configurations, how to set those values, and what are the steps that's involved in creating a logical replication setup. Then we have few catalog tables. So if there is an issue, how to diagnose. So we have some catalog tables and monitoring we can do. So how to do that. And there are a lot of active work that's going on. So I'll just explain one by one about the features, and few restrictions that are present we would like to remove. So I'll just introduce those. So in replication, we have mainly physical replication and logical replication. So in case of physical replication, it's mainly to replicate the complete data from the primary node to the standby node. So all the data will be read from wall and will be shipped to the standby node. So the data will be always intact, and we will have access to the complete data in the standby. So this is mainly useful for the failover situation. So if anything happens to the primary, we can quickly switch to the standby node. So, and the standby we can make the standby node as the primary node. So there are few restrictions in physical replication. So we'll have to replicate the complete database. There is no option where we can replicate a part of the database or just a table. So those kind of option is not available, and we cannot replicate between two different major versions. And so the users cannot do any write operations in the standby server. It will always be in read-only mode, and we cannot replicate between different platforms. So we cannot have the primary in one platform and the subscriber in another platform. So to overcome all these limitations, logical replication was developed. So logical replication is a method in which we replicate data from the publisher to subscriber. So unlike physical replication where we call mainly primary and standby, in logical replication we will be seeing the terms publisher and subscriber. So publisher will be publishing the data to the subscriber node. So here there is a lot of flexibility. So based on the configuration that we have configured, whether to publish all the tables or only few tables, or only certain operations like insert from the publisher table, all that is possible. And you can we can send cascade this replication. So maybe send the data from one publication to the subscriber, and the subscriber can have another publication which will publish data to another node. So that kind of flexibility is present in logical replication. So DB has more options. So what are the main use cases that we should use when we should use logical replication? So it's like if you want to just publish one table or a few tables data, or if you want to just publish just insert operations from a table, or if you want to publish just update delete operations. So those are that at that time we can use the logical replication. And this is also a good feature. So like when we want to consolidate multiple databases from different data nodes into a single node, right? So that is possible when we can consolidate multiple database data into a single node. So this single node can can be used for analytical purposes. So we'll have the huge chunk of data. So all the OLTP data can be consolidated and then later we can do analysis. So replicating between major versions is also possible. So we can have the publisher in one version and subscriber in another version. So we can have the publisher running on different platform and the subscriber on a totally different platform. That's also possible. So this can also be used for security purpose if we just want to provide partial data to some users. So just replicate the data that user needs and the user can access it. So all these use cases it will help us in using logical replication. There are few restrictions that are present that we should take care. So the tables should be fully qualified in both the publisher and the subscriber. So we need to make sure that the tables are configured in such a way. So and the second thing is that bidirectional replication is not supported. So data will be sent from publisher to the subscriber. So any changes in the subscriber will not be sent to the publisher. So another thing is we will not replicate the create statements. So the create statements currently is not supported. We will have to use maybe pgdump and make the table setup in the subscription. Replication of sequences is not supported. Replication of large objects is not supported currently. And so the subscriber table and the publication table can be slightly different, such that the subscriber can have more columns. But one small restriction is that the column names should match and the column type should match with the publisher. And when we create the all publication for all tables, user need to have super user privileges. And currently, publishing to the same host is not supported. So hopefully these things will get handled in the coming versions. So now let's have a look at the architecture. I'll just let you know how things work in the internals. So basically we will have we'll have the publisher and we'll have the subscriber. So we will configure the publication in the publisher node, saying this publisher is responsible for sending all tables or some tables data. So we need to configure it in the publication. And then in the subscriber, we need to create a subscription saying we will be subscribing to this host. So we need to give the connection details and which publication we are interested in. So once we specify this, the subscriber will connect to the publisher. So once he connects, the subscriber will ask for the publication to fetch all the tables that this publication is part of. So once subscriber gets this table list, subscriber will then start synchronizing these tables data. So we will internally use copy command to get the data from publisher. So start a transaction, snapshot will be created at the beginning, and copy all the data from publisher to the subscriber. So this is the table synchronization phase. So once table synchronization phase is done, then we will start reading the wall files. So the publisher will check record by record. So for each record, it will see if it will decode the data and check if this data is applicable for this particular publication. If it is applicable, it will start queuing this transaction data into the reorder buffer queue. So, and it will continue this, it will keep continuing this decode operation till the transaction is committed. So we will have a queue of transaction data present in the publication. So for small transaction, the memory will be sufficient. So if it's a big transaction, so we have been configured, the reorder buffer is configured based on the logical decoding work mem. So that much memory it will be allocated. So once the transaction data exceeds this logical decoding work memory, it will be spilled to disk. So currently this memory is 64 MB. So we should make sure that we have configured based on the correct based on our transactions that we expect. So it shouldn't be that we choose a too low value. So that will result in frequent write to disk and the performance will be bad. So some kind of ideal value need to be chosen for this. And there is also an option wherein if we don't want the complete data to be lying in the publisher, we can have an streaming option enabled in the subscriber. So when streaming option is enabled, these data will be sent to the subscriber. So until commit all these operations, right, based on the configuration will be lying in the publication side. So the publisher will maintain this memory. So only once the transaction is committed, this complete data, the reorder buffer transaction data will be sent to the subscriber, and the subscriber will start applying this changes in the subscriber. So if the transaction gets aborted, on the publisher side itself, we will destroy the transaction data, and this data will not be sent to the subscriber. So I just explained the things, what are the different things that's happening in the internals. So if you see, all these things will be, we have 5 modules that takes care of this work. So in the publisher side, we have wall sender, table sync, and replication slot. And in the subscriber side, we have the logical replication launcher and logical replication worker, which handles all this work. So this, in the publisher side, wall sender will take care of sending the wall records from primary server to the subscriber. This process will be started when subscriber will connect to the publisher and asks and subscribe to the data. Table sync process is responsible for synchronizing the table data from the publisher to subscriber. So based on the number of tables and based on the configuration, this process can happen parallelly. So if we have a number of tables, so based on the configuration, that many tables data can be synchronized parallelly to the subscriber. So replication slot will maintain the wall information. So it will maintain up to which wall the wall archiver can delete. So which is at least from which wall record the information need to be maintained in the system, and wall and replication slot will move the wall location as and when the transaction is committed in the subscriber. And logical replication launcher is present in the subscriber. So this process is responsible for starting the logical replication workers in the subscriber side. So logical replication worker, so this process is responsible for applying the logical changes as and when they come from the publisher. It will be started by the logical replication launcher for the subscriptions. So we use wall sender protocol to communicate data with publisher. So it is based on libpq code that we connect. So apply worker will use libpq APIs to connect with the wall sender and get the data. So we have been talking about publication. So publication is a logical entity in the system. So it is present in the master server. So we can specify what are the changes this publication will be sending to the subscriber. So it can be for a table or a group of tables or some operations in a particular table. So it will be at one database. So we need to have, if you want multiple database data, we need to have multiple publications. So, and single publication can publish multiple tables data. and the same table can be present in multiple publications. So subscription is the downstream side of the logical replication. This node is responsible for getting the data. So we call this node as the subscriber. Subscription defines the connection to the database and what are the publications data that it need to subscribe. So we have different types of publications. So I'll just explain what are the different types. So if we want to publish some selective tables, we need to specify create publication, the publication name for table, and what are the tables. So this can be one table or it can be multiple tables. So that can be specified here. So then we can publish all the tables data. So to publish all the tables data, create the publication name for all tables. So that's the difference here. And we can publish certain operations like insert, update, or delete. So if you want to publish insert operation, create a publication, the publication name for table name with so here I'm publishing insert operation, so we need to specify insert. So similarly, we can specify update or delete also, delete operation also. So one thing that we need to note is that if we publish update or delete operations, we need to make sure that the replica identity is created for the tables. So you would have seen in the alter table has replica identity. So we need to specify that option. That option is only used for this logical replication purpose. So that the replica identity will help us to identify the rows uniquely in the system. So that need to be configured. So once you have created the publication, if you want to change, it is possible. So here, if you want to change the publication to publish, update, and delete operation. So alter publication, the publication name, set publish equal to update and delete. Okay. And if you want to add more tables, so like we have configured the publication for few tables, and now we feel we should add more tables. So alter the publication name, add table. So what are the tables? This can be one or more number of tables here. So once all the operation is finished, if you feel we don't need the logical replication anymore, just drop the publication. It's simple, similar to other operations. Drop publication name. And the subscriber side, if you want to create subscription to multiple publications, so create subscriber name. Up till here it's similar, and then we need to specify the connection. So which host, what is the port, and which user, and the database name that we will subscribe. So, and which publication. So this can be one or more publications in the publisher node. And if we want to create the subscription in disable state, so here subscriber won't be running. So just say create subscription, the subscription name, connection, and which publisher with enable default. So this we use mainly for the network maintenance. It can be enabled later. So once all the network maintenance work is finished. So synchronous commit. So this feature is useful by default. So any transaction that we commit in the publication will publish the data asynchronously to subscriber. So in publication publisher node, we will not wait until the transaction is committed. So it will commit, and maybe after some time it will be committed to the subscriber. So there are a lot of overhead involved. So publisher will publish the data, and once it is applied, it will commit in the subscriber. But if you don't want that, you want to make sure that the publisher data should be committed only once the subscriber data is committed. So we have an option for that, synchronous commit. So syntax is like create the subscription, specify the connection, the publication, and with we need to specify the synchronous commit is true. And so there is an option where we can say whether to copy the data or not when the subscription is created. So similar syntax is similar to others. Create the subscription, provide the connection details, and then in with copy data true or false. So the streaming option is for sending the in progress transactions. So by default, this option is false, and we will not send this data until we receive commit. So until commit, all the data will be present in the publisher node. So, and once we receive commit, publisher will have to send the complete data. So that might cause a slightly delay of the transaction to be committed in the subscriber. So if you don't want this, we can use this option, and it will keep sending the in progress transactions. So after we create the subscription, similar to the publication, we can change the subscription. So if we want to change the publication, so initially if we have configured to a different publication, and now we need to change it. So just say alter subscription name, set the publication name to different one. And if you want to disable a subscription, so if you want to do some maintenance activity, just say alter subscription name disable. So, and we can refresh the publications. So any changes that is happening in the publication site, if so the tables have changed, so table list is changed for the publication, we can do a alter subscription refresh publication. So this, once we do this, it will get the tables from the publisher again. So if any change is done in the publisher, that will be synced up at this time. So once all work is done, just drop the subscription name. So there are a bunch of configuration parameters that we need to keep in mind. So this is one of the important parameters, logical decoding work memory. So this specifies the maximum memory that should be used for logical decoding. So if our changes are more than this, it will either spill to disk or it will send to the subscriber. And so the maximum wall senders, so maximum number of wall senders that should be running simultaneously. And then wall sender timeout. So the replication connections will become inactive after this amount of time. And then maximum replication slot, it will specify the number of replication slots that server can support. So each of the publications will use replication slots. So if we have more number of publications in the system, this value need to be increased. And maximum logical replication workers, it specifies the number of logical replication workers. So it includes both the apply worker and the table sync workers. So this will be taken from max worker process. So if the system runs parallelism heavily, so these values need to be adjusted. And then we have wall receiver timeout. So this will terminate the replication connections if it is inactive for this amount of time. So this is like max sync workers per subscription. So maximum number of table sync that can happen per subscription. So if we have a lot of tables and we need to do a lot of table sync, and we have a lot of huge amount of data, so this can be configured to a higher value. So this will be used only at the initial phase. So based on this value will be taken from max logical replication workers. So what are the steps that we need to do for a logical replication setup? So a bunch of configurations that I explained. So one of the important configurations, so in the publisher node, we need to set the wall level to logical. So we will be writing some extra information that is required for logical decoding. So if logical replication is running, this configuration need to be changed. So then based on the number of logical replications publications we have, this value need to be adjusted, max wall senders. And based on network, we need to configure wall sender timeout. And so, and then next is logical decoding work memory. If we will have large transactions, so we can configure this value and set up the pgHBA conf for the replication user. So then create the publication. So you just create the publication based on the different types that I mentioned. You can choose whether for all tables or selective tables or certain operations in the table. And we need to grant select permissions on the tables. So as I told, that we will be using copy command to copy the data from publisher to subscriber. So publisher will need select permissions on the table list that we have specified in the create publication. So we need to take care of this. So this is on the these are the initial steps. And logical replication has one limitation, when the create tables will not be related to subscriber. So this will need to be created manually in the subscriber. The pgterm is quite a useful command which will help in this. So we can hello.
А в чем проблема? We have a small problem with user's connection. We need to reassign the session for the speaker. Sorry for a small technical problem. So dear friends, we used to have a bit problems with the speaker's connection. Now it looks like we managed that, and we restart partially the talk, so it would be like started a minute earlier soon. Just stay tuned, 30 seconds, and we'll be back.
Okay, sorry for the disconnection. My net connection had some problem. Okay, so I will start from where I left. So these are the steps that we need to take care in the publisher side. So a bunch of configuration that we need to take care. So we need to make sure that the wall level is set to logical. So for logical decoding, we add some extra information in the wall, so that which will be needed during logical decoding. So, and then set the maximum wall senders. This will be based on the number of publications we have in the system with different subscriptions. So, and then we have the wall sender timeout. So this is based on the network. We can set it accordingly. And the logical decoding work mem. So this will be used for storing the decoded transaction data in memory until commit, and then set up the pgHBA conf for the replication user, and then create the publication. So based on the whether it is for all table or for certain tables, so create the publication. And we need to grant select permissions for these tables. So internally we will be using copy command to send the data from public the subscriber. So we need to grant select permission to the replication user. And so the table creation need to be done manually in the subscriber. Currently this is a limitation with logical replication. So pgdump is quite useful for us. So once we identify what are the tables that need to be published, so use this command, the pgdump, the which database, and the only schema alone, and here we need to specify the list of tables, and pipe it to PSQL command. So this here we need to provide the subscriber connection string. So once we execute this command, all the tables will be created in the subscriber. And in the subscriber side, set up the configuration. Wall receiver timeout we need to specify, and create the subscription. So we need to provide the publication connection string here, and what are the publication that we need to be specified. So once we are done with this, we will be getting all the table data, and any changes happening on the publisher, those table data will be present in the subscriber. So there is a bunch of tables, catalog tables, that will be quite useful. So we have PG publication. So here we can see what all publications are present in the system. And this is also quite a useful catalog table, PG publication relation. So here we will maintain the publication and the tables information. So we can see the user has created the publication for which all tables. So this mapping is like between publication and relation. And similarly, we have the catalog table in the subscription, PG subscription, which will list all the logical replication subscriptions. And similarly, we have PG subscription relation. So this catalog contains the subscription and the relation is present in the subscription. We can see which all relations are present. And PG replication slot. So this will give us all the replication slots that are currently created and which are being used for logical replication. And if we were for monitoring purpose, we have PG stat replication slots. So this view contains the logical replication slot statistic usage information, and PG stat replication. This contains the wall center stat information so what is sent to the subscriber. We have a lot of active work that's happening in logical replication. So two-phase transaction, logical replication of tables in a schema, skip tables, row filtering, column filtering, and skipping some particular transaction in subscriber side. So I'll just briefly explain about the work that's happening. So up till now, we were able to send only the transaction data at commit time. So new feature is being developed. This is going to be committed pretty soon. So wherein the two-phase transaction data. So when the prepare happens, so even at prepare, the transaction decoded up to prepare will be sent to the subscriber. So with this option, we will be able to decode commands like prepare transaction, commit prepared, and rollback the prepared. So earlier we were decoding and sending the transaction information at commit. So here it will help us in sending at prepare transaction time. So only a small change is done in the syntax. The with option is enabled, wherein we can specify two-phase equal to true. So then if you specify this, it will take care of it. So up till now, we were not supporting logical replication of tables in a schema. So either if user need to publish one schema tables data, user will have to manually identify what are the tables that are present in this schema and create a publication. So this new option is being added to the publication, wherein we can specify which schema data need to be published. So here is this. It's the create publication statement is extended to include the for schema. So and you can specify it can be a single schema or a multiple schema. And after creation, if you want to add the schema, just say add schema name. And there is also an option to skip tables. So up till now, if user want to skip, if he wanted all the tables but just skip one table, so he couldn't use all tables. So user will have to identify all the tables present, get the list, and create a publication to create for that particular publication. And he need to remove that tables and specify it in create publication. So new option is being added, so wherein we can specify along with all tables which table need to be skipped. So this again is like we can specify one table or multiple tables. And similarly, there is an alter publication, so wherein we can add skip tables later once we have created the publication. And this row filtering feature, so up till now we had to send the complete tables data. So this feature adds row filtering capacity. So you can specify where clause along with the publication table. So you can specify the which rows you want. So like, so here only when A is greater than 100, only those rows will be sent to the subscriber. So this option is being added recently. And column filtering. So up till now, we'll have to send all the column data. But if user intends, like he wanted only few column data from publisher to the subscriber, so a new option is added. So this reduces the network consumption. So wherein we were sending complete data earlier, so all those data will be filtered in the publisher side, and it won't be sent. So here, along with table name, we can specify the column name optionally. This new option is added. And similarly, if you want to change the columns that need to be added, so that can be done using alter publication at a later point of time. So this is quite a good feature, like that's being developed. So skipping logical replication transactions. When we publish data from the publication to the subscriber, there is a possibility that there can be an subscriber side. Maybe the table is not present, or the constraint is violated. So when this kind of situation happens, the subscriber will not receive any more any new data. So it will wait until user intervenes and resolves this problem. So ideally what we will do is we will maybe create the table if the table is needed, and in case of conflict, maybe we will check and delete the row. So this to solve the problem. So or else we will have to advance the LSN in LSN and in the publisher and subscriber. So but when we advance the LSN, we will not be able to skip exactly one transaction. We'll be ending up skipping more transaction. So there is a new feature being added wherein we can skip one particular transaction in the subscription. So identify which transaction is causing this error in the subscription and specify it. So this transaction will be skipped in the subscriber, and it will then the subscriber will start receiving the new set of transaction data. And once that all the transaction data is fine, there is no conflict, so reset the skip transaction. So there are few limitations that I have told, so that maybe will be picked up in the future and handled. So there is a lot of interest for this. So wherein we don't send the DDL statements. So if we use pgdump to create the tables in the subscriber, so if this can be handled, then that step will be removed. And we have some restrictions wherein we'll have to use super user for creating all tables publication. So this might be removed in the future. And currently sequences is not supported. Logical replication of sequences is not supported. So that will be handled. And large object replication is also not supported. And the bidirectional replication is currently not supported. So we just send data from publisher to subscriber. So maybe if we can address this together, it will be good. So logical replication will become a complete solution. Yeah, thank you. So these are the things that I had to present today.
So thank you, and it was like very, very concentrated technical talk. I'm afraid we have time only for a couple of questions, but anyway, there are lots of questions in the chat, so we try our best to answer them. So the first question is, can I use the logical replication if need to get just a subset of original table, limited number of fields on subscriber side? What happens if I did some fields, if I add some fields to the table on the publisher side?
I didn't get the question clearly, but I'll try to answer. Is the question like maybe
can you replicate a subset of a table?
There can be two possible. Yeah, so currently there is one option. So wherein we can publish only certain operation, like maybe insert, update, or delete. That is possible. But there is no option like wherein we can filter some data, like if we want to use a where condition. So there is a feature that is currently happening and a lot of discussion is happening. So I had explained it in the current work. So a lot of discussion is happening on this. Maybe once we get this feature, so we will be able to replicate a subset of data. So we can specify the condition and that data will be sent. So the patch is available, but more fine tuning is required in the community. So we should be able to we might get it in this version.
Thank you. Another question is, the person who asked it didn't get an idea of what alter publication at skip table does. Can you explain that once more?
Okay. So initially, if we have created the publication for, we will generally create publication for all tables or maybe certain set of tables. And later we feel that we need to skip one particular table. So we will publish. Initially we are publishing, let's say 100 tables data, and later we come to know that we don't want to publish 100 table data, only 99 is required. We need to skip one table data. So in this case, we can just do an alter publication, add skip table. So maybe some confidential employee details table, and so it will stop skipping. It will start skipping this tables data. The rest 99 tables data will be sent.
Thank you. I think that would be the last question. Or maybe we have time for two. Skipping failed transactions is not safe, as every failed transaction has a reason. Will skipping transaction be logged somewhere to investigate what's happened?
Actually, so by default, the transaction will not be skipped. So what will happen is when there is an error in the subscriber, the error will be logged, and the subscriber side we will not advance. So whatever data we have received from publisher, the subscriber will keep failing and it will exiting, and it will tell in the subscriber that this error has occurred. So generally what will happen is DBA will intervene. He will identify what is the error that is present. So by default, what he will do is he will either create the table if the table is missing, or if there is a conflicting record, right? He will analyze and take care what need to be done. But if the user feels that this particular transaction need to be skipped, right? So only in this case, this need to be specified explicitly to solve this scenario. So we don't want to adjust the wall instead of wall adjustment. So system itself will take care if we specify the transaction that need to be used. So that is not a default operation. So only on need basis it will be used.
Yeah, thank you. So we regret to say we run out of time. Thank you for very technical, detailed talk, and thank you for coming. Now we proceed to the
Thanks a
Q&A
lot.
session with Vignesh. I think there are a couple of questions still not answered. We can copy them there, and Vignesh will answer them. Thank you. And we need to say
Thanks a lot.
hello to our next speaker. We'll be back soon after we set up the next talk. See you.
Okay, guys, so we're ready to continue with our talk, with our next talk. We're a little bit late on time, so I will keep this short. Our next speaker is Piet. He is a very experienced and energetic individual. He knows quite a lot about databases due to his very extensive experience, and he's very passionate on the subject of using databases as smartly and efficiently as possible. So we'll be talking about how to use actually databases as microservices. It's quite maybe a controversial topic in some way, and hopefully Piet will offer some insight on the subject. Hello, Piet.
Hello. Can you guys hear me?
Yes.
Of course. Not too much echo, and there is a mouse on the screen moving at the moment. Okay, good. Good afternoon. It is. I think it's 12 o'clock your time. Thank you for the introduction. I can be passionate about IT because I see so many people doing really stupid stuff, and that is often the reason for my talks. Microservices and databases, and I also, well, my real life is riding around on a motorcycle, and I have been about 700 kilometers from Moscow once when I was in the Baltics, between Narva and Daugavpils, who's on the Russian border, and I sort of said hello to you guys. I'll visit one day. I'll try, I'll promise. The agenda for this one is used to be about 45 minutes. I think I have an hour. I don't mind questions. And if there are a lot of questions, pop me halfway through or keep them to the end. I know it can be controversial, and it's no joke. I learn more from the audience asking questions than you could possibly learn from me. Don't hesitate, put questions in. Do I have to go through history of microservices? I'll keep it simple. Microservices, the main thing is they are decoupled. They are sort of standalone items somewhere. And microservices have a problem with state. State is a, I need to store something. Yep, you need to store something. I have a few ideas. You'll end up with 3 classifications and an A and a B. I've put in a lot of Postgres references because it is a Postgres conference, but the things I will explain in this talk are probably applicable to other databases. And one of the conditions for a good database system is that it can do user-defined functions or user-defined procedures. If you can have a stored procedure in your database, you're halfway through creating a microservice. Maybe it's a bit of a short conclusion, but you'll find that pgSQL is important. Oracle does that with PL/SQL. A lot of you probably know it, and if you hate Oracle, don't worry, I'll try not to mention it too often. And there are new databases on the block. YugaDB and CockroachDB pretend to be clustered databases. I'm not going into their concept or their topic too much, but if you can run something on Postgres, you may find it fairly easy to port it to something like Yugabyte or Cockroach. That is going to be an interesting development in the future. You can see I added it. There's a typo. No, apologies for that. And yes, I hope there's a bit of time for discussion. So keep your questions. Microservices. When I learned about them, I thought they were a great concept. And I also had a bit of a déjà vu, because microservices are just really complicated, large objects. And we used to have objects somewhere in the mid-90s, object-oriented programming, anyway. You may find some of the concepts come back. Microservices are about decoupling, so about having independent items doing work for you. And when you come across that, you should probably Google the solid principles as well. The solid principles come from the object-oriented theory, practice, attempt in the 90s and the early 2000s. And some of that stuff applies to microservices. Microservices are currently sold as, they're scalable because we can start 1,000 of them. And that's why they represented here like the virus a little bit. Microservices are like a virus and they have a really high replication factor. And I'm not going to advocate any vaccine yet, but maybe. Microservices, the serverless people are wild about microservices because you don't need a server anymore. You don't need a hardware, you don't need to configure it, you don't need to cook your file system, etc. You just deploy on Kubernetes. So where's Kubernetes running? Microservices, of course, are agile and very much into DevOps. Microservices can be deployed on something like Kubernetes, on a Lambda in AWS, on a function in Microsoft. It's an on-demand principle in many cases. Amazon will say it's pay as you go. If you need 1,000 microservices, you can start 1,000 microservices. I think something's going to melt, at least your credit card. Maybe. Microservices are very hip and trendy, so be careful with that. I found a lot of good ideas in microservices, but now you got people running around with a big word microservice on their front head going, And the sucker is, of course, a microservice. It's still an IT program. It's software, and it needs data. At some point, your microservice will need state or a state machine or store something. It may have to write to a file, to an object, or to a database. So the elephant in the room, the big item coming in always is that database. If you want to, anything you've done, you want to keep it, you probably need to store it in a database or some object store. And This guy, Vlad, is in charge of the Java Hibernate software. If you have a serious microservice architecture, you probably need a database. You may have to need a database per service. That's a nightmare. Well, he formulated it differently. He said, frankly, I'm not sure how that can work in reality, as more databases mean more monitoring, more backup, more security, more replication, more tuning, more DBAs. Yeah. So here's the challenge. If you multiply your microservices, how are you going to keep up with your data store, your database? And of course, this is Postgres, so I'd call the database the elephant in the room. Hello, Slonik. And everybody knows databases are a problem, or used to be. But most microservices are just known as a URL. Here's the URL, you call it. And that thing is running somewhere in a cloud. You don't need to know whether it's on Kubernetes or on a virtual machine or in a function. You just call the microservice. You give it a get to get some information. You give it a post or a put to store something. You can see the problem coming. If you put a post into the microservice, the microservice is supposed to keep the data. It is already assuming a state machine. Keep something, save it, back it up. So if you have some application component, you probably also need a database or a data store. And of course, you can choose object stores and put everything in buckets or in glaciers or what have you, but you still need to store it somewhere. And by the way, the best place to store it, of course, a database. I don't need to tell you guys that. The sequence of activities in a microservice will generally be something like you call it, or somebody calls the microservice, and then the microservice needs something to work with, a database. And it may have to look up something in a database. It might have to save and return something to the database. You can already see that a single microservice call results in a chatty talk between the service itself and its object store, its database. And of course, you want to avoid returning 400 or 500 errors. You don't want page errors or server errors. So we have to figure a way to build a microservice that does something with data and doesn't return errors. Here's the challenge. And of course, always the database is the problem. Everybody knows the database is the problem. Everybody knows databases are slow. So thinking about it and listening to the hype guys for microservices, there are about 3 cases. There is the easy case, the simple case, and the difficult case. The easy part is if you have a program that can run totally standalone, I call that data is null. There is no data. Doesn't need any state at all. Immediately there's a question mark. How can a useful program not have or need or use state? There's always state somewhere. But for example, if you want to calculate Celsius to Fahrenheit or Kelvin, you know that you maybe have an ideal microservice. It is simple, but a very rare case. Most microservices will need some sort of state. If you're lucky, it's read-only. So you have something that's almost stateless. You you don't have to return. Your database doesn't have to receive any data. You don't have to store anything. You don't have to worry about something like a commit and a save and a backup. Examples of that are catalogs, zip code lookups, postcode lookups, list of values, the eternal list of 200 countries that you need to produce in a pick list. The R for Russia is all the way to the back of the alphabet, so you keep scrolling. But a read-only microservice might still need a database, or it needs some place to read data from. It needs a read store. The more difficult one, and probably the more common one, is a stateful microservice or a stateful system. You need to store something, and it has to be either completely ACID or at least base. You know, basic availability, safe, eventual consistent, and the eventual is the big question. You need a database. For example, if you do stock keeping, you want to know how much is in stock. So you take something out and you update the total, or you make sure somebody can verify the amount of stock that is in there. You need updates. You need the elephant in the room, a database. Number 1 is easy, number 2 is doable, number 3 becomes a problem in many cases. Let's have a look. Have a standalone microservice. You're just executing something. For example, you divide by minus 32 and divide by 7 or something, create Celsius and Kelvin. You can format a string or do something clever with CSS. You can compress a file. Already, the compressing of a file, you probably need some sort of state. You need to receive your file, process it, and send it back. There's always data involved somewhere. But if you could say you have no data, I would say, so you don't need any extra components. You don't need extra connections. You have a fairly small program. You can containerize it, run it in Kubernetes, off you go. I'd be tempted to ask everyone in the class, build a Celsius to Kelvin converter and deploy it in Kubernetes. But you can deploy something like that quite simple. You can scale it out forever. You can start 1,000 instances with no problem because they don't hurt one another. They won't choke on some sort of choke point. If that's your challenge, you're lucky. You have a microservice. You are buzzword compliant, totally. Your replication probably looks like this. Yes, you can scale. So standalone, completely isolated microservice is beautiful, and I won't challenge the usefulness of a calculator, but it is a relatively minor part of IT. The read-only microservices, a bit more complicated because you need data. Your system needs to have the list of countries, the zip code lookup, the catalog data. There are a lot of image stores out there for web shops, and that is static data. It doesn't update a lot, and you can replicate that data if you like, as long as you know where it's going. Your choices for a microservice that needs a limited amount of read-only data. So your choice for a microservice that just needs to present data are to include the data in the microservice or to call out to pick up the data. Including it means your microservice becomes totally independent. There's no external call, no connection needed to get the data. Calling out means you have to find it somewhere. If you include your data in your microservice, the data may become outdated. Timeliness is a problem. If the catalog is no longer valid, if you have an image of a 1980 Lada or so, you're probably not selling 1980s cars anymore. So how old is your data set and can you live with that? If you include your data, your microservice becomes fat. And they call it, oh, that's a very fat container. Yeah, it's a fat container because it has a lot of data in it that is readily available for presentation. It does mean your microservice becomes a bit slow on startup. It means it becomes a bit slow on deployment if it has to go to the other side of the world for some Cloudflare system. So if you decide, I have a smaller microservice and I'll call out to find my data, that's fine. But calling out to pick up data means you need effort, you need time, latency, you end up with something called a chatty protocol. Your network has to be able to handle it. And by the way, who are you getting the data from? Database? That might become a bottleneck because if 1,000 microservices suddenly call up to find the image of your product, the database runs a bit hot. And your microservice now becomes coupled to something else. And that's probably less preferable, but it's a solution. You have to weigh the pros and cons. In drawings, I would say you either have a microservice, the virus with the data attached to it, or you have a bunch of microservices calling out to read data from a database. And I don't know if I put Slowdig in there, but Slowdig might get busy if you get 1,000 microservices calling up for data, but it may work. There he is. He's an elephant. He can handle something. If you have a stateful service, you need to save something. So you're updating a bank account, the extreme one. You're updating stock in a warehouse. You need to save that somewhere. You probably end up with a lot of microservices and a really big database. you want to keep data, you have a single point of truth or a system of record. In the old school, you need a state machine. And that would be the case for order taking, keeping stock, or doing payments. It's important that you know what your amount is and where you store it, and don't lose track of the amount. I remember how much I have in stock, and I don't want your number to be different from the stock that I have in my warehouse. You have a limited choice. You need to call some kind of storage, and it probably has to be ACID. For stock keeping, I don't want my base eventual consistency stuff really. So there's a consideration of, can I afford data loss, and what is the cost if I lose something? Can I afford that? How quick do I need an answer? And in database land, we're used to something like a 10 millisecond reply on a query. A lot of microservices will take hundreds of milliseconds, if not a second, to reply with something. That can be a problem. If you have a lot of microservices, capacity immediately is a problem. So how much traffic can you handle? And if you send too much traffic to a critical component, the database, it'll melt down or it'll generate errors. You probably don't want that. So later on in the presentation, I will argue you need a safety valve or a throttling mechanism to prevent overload. And you'll need that anyway, regardless of what kind of microservice you do. And then if errors occur, you have to sort of gracefully handle the error. The typical example of a graceful error handling was the fail whale in Twitter years ago. I haven't seen that one in a bit. Every now and then I still see a 1555 error. That's different. But you need a database. For anything stateful, you'd have to consider a database or an object store or some place where you put data. And in most cases, that's probably going to be an RDBMS or a relational data model. I hope, but this is part of the discussion because a lot of people will come in and say, oh, you know, we use object store and that's fine. Or we have this Mongo key value thing and it works for us. And if it works for you, I'm happy with that. But I kind of choose an RDBMS. I come from a mechanical background, hence the T Ford, and we always use an automotive equivalent. You know, oh, you don't buy that kind of car. Engineering rule of thumb: minimize your components. Make sure you can do everything with just 5 components. That's easy. You can have components in reserve. You know how the component works. You can fix it. You can replace it. If you need a lot of components, try to minimize the different number of components. So do everything with an M13 bolt, for example, and then you only need 1 bolt and 1 socket. And it's repairable with just the 1 socket and the 1 bolt. Easy. In database land, in IT land, you probably still want to minimize your number of microservices because it's easier to monitor and to control 10 microservices than 1,000. Although, you know, real fanatics will say, oh, it scales, no problem. I can start 1,000. Yep, Amazon will love you for that. If you use just a single database, you end up with a monolith. And in my opinion, that's fine as long as you can keep the monolith healthy. And if you need to scale out, well, you have all the considerations in this PowerPoint. If you do have to multiply your number of databases, try at least using the same one. So if you're using Postgres as a backend repository, as your point of truth, maybe your microservices should also use Postgres. It's just easier that way. And you end up with a CQRS model, which is debatable. Maybe put that in the discussion for later on. Was CQRS a good idea? And does it help with microservices? And someone will say yes, and somebody else will say no, maybe not. So microservices and databases, I will try to nudge the architect into using something simple, something solid. You know, go back to the object-oriented approach. And if you need an analogy, this is my favorite analogy, the Lada. And in France, I use the Deux Chevaux, and in England, I'll use some English car. But that Lada, it might break, but it will never die. I think you guys can relate to that. There's your microservice again. If you have to add data to your microservice, there's a database. The decoupling. Remember, we need decoupled microservices. Remember, we need them scalable. We need them fast. We need to be able to start 100 of them, maybe not 1,000, but a lot. You have to fit, if you have to fit your data in your container, because container people like to have the container totally independent, so they'll pick up the data, and that's possible if you don't have too much data. You can store a gigabyte is a difficult number, but maybe your container can store something in the area of a single gigabyte. You can choose to put that in comma-separated file-like objects. You can have associated arrays right into your code if you'd like to. I'll make the case that if you want a small database in a microservice, you could have SQLite. This is what I look into the audience. Anyone use SQLite here ever? And then some people will go, yep, I did that. And do you like it? And some liked it and some didn't. SQLite is a database. You can use SQL, you can use views, you can even define functions if you find out how to do that. It's a database. It'll work. I'm not saying it's a very high quality, reliable database, but for read only, it's probably good enough. You can use Postgres in your microservice, which in my opinion is still lightweight because you can deploy Postgres still in megabytes. You don't need gigabytes of software to deploy Postgres. It's fine. You could pick up Oracle, the free version, if you don't want to if you don't want to pay Oracle, that is the XE variety. You do that, you end up with a fat container, a multi-gigabyte container at least. So be careful with that, but it'll work. If you do it, you have to complete PL/SQL in there, for example. You can do fairly complicated stuff inside that database. So sometimes I can recommend it. I'm a bit careful because it's too big, too fat, and nobody likes Oracle. So go back one option and highlight Postgres with a big highlighter. The gist of this one, and I'll repeat that probably 17 times. Your database can be smart. You can do a lot of work at the database level, close to the data. And it's easier to bring your code to the data than to suck all your data into your service and process it at some remote location. It's just easier to process close to the data than it is to process far away in a microservice deployed into South America or something. Your choice. Yeah. And this is your, this is, well, I like my animation. So I would argue you can take the microservice and slide it into a database, sort of. And this is why the intro says, maybe your database is your microservice at some point in time. There's two keywords to keep in mind, apart from the database and Slonik. Your database can do a lot of work for you. SQL is a processing mechanism. Views and PL/pgSQL are effectively code, can do your work for you. So bring your code to the data. And the other one is a database can handle much more than just tables. Everybody thinks at a database, they think of the Northwind example or the employee department type of thing, or a table with orders and a table with product and a table with customer. That's fine. If your data consists of JSON documents, docs, geographical data, graph data, you can still store that in the database. Now, don't discard Postgres because it is a relational database. It'll handle JSON, it'll handle geographical data, it'll handle graph data, it'll probably handle any data you throw at it. And the advantage of putting something in your database is enormous because your database can easily be backed up, it can be recovered, it can be replicated. You get a lot of information, you get a lot of intelligence if you use a database. And you will miss that if you go to something like Mongo or Elasticsearch. Those are more or less single-purpose data store utilities. They're probably not asset, and because they're single-purpose or single task, single item, they're not as flexible as a proper database would be. I'm not going to put that point too hard, but you need a database. If you're not using a database, you're doing it wrong. Keep that in mind, though. And the next guy says, "Oh, but the database is a monolith," and that's true. We'll handle that. We'll learn how to deal with that. I stole this from Oracle. the Oracle presentation is, once you have that database there, you can put all your intelligent stuff in there, and you can store your database, your docs, your graphs, your blobs, your geographical information. Everything goes into that database, and you know where it is all of a sudden. We currently have a customer with MySQL, Postgres, Elasticsearch, and not Mongo, but Cassandra. And the disaster recovery exercise is a nightmare because those 4 data store components never recover to the same point in time, of course. So if you get read-only data, I'll still argue you need a database instead of a file system. You put your database in your microservice, and you end up with a microservice and a data component attached to it. SQLite, and this is why I look into the room, but there's nobody looking back. If SQLite is too lightweight for you, you can consider deploying Postgres and put your logic in PLPG-SQL. Postgres stored procedure is maybe not quite PLSQL. There's a few things about the compile and stuff, but we'll get there. You can code your logic in PLPG-SQL, and that becomes your program. Your PL/SQL Postgres will fit into a container if you have to, and there you have it. You can consider Oracle. You end up with a big fat container. You can consider using something like PostgreSQL and do REST calls to your database. And you probably end up with 2 containers in that case, but it's still easily deployable. And 2 light containers rather than one big one if you compare it to PL/SQL. Whatever you do, you have to think of reducing calls to and from other components. Your microservice has to be as independent as possible. So if your microservice needs to call out to the database, if between the 2 here, between the virus and the database, you have a lot of chat, that takes up time. That becomes a risk. In Oracle, they'll say you need to reduce context switches, which is another way of saying don't be chatty. If you want to know more about that, there are the hashtags SmartDB and ConvergeDB. You have to filter out the Oracle PR, but the basic idea is good. You process close to your data, and you store all your data in one or in a similar component. The database, Slonik. Where's Slonik? Microservices. You can multiply microservices and databases as well. There you go. Poll time. We'll put this in the question marks later on, but normally I try to find out who likes SQLite, and then you either you like it, you avoid it, or you go, huh? Oh, good. Nope, I don't. Huh? What is SQLite? If I had this in March or so, I got about 7 reactions. Oh, thank you for telling me about SQLite. But I guess the audience here already knows SQLite. If you have state in a microservice, the easy part is you don't have state, so you have the standalone program. The read-only state is you have to choose whether you take your data into your microservice or you have your microservice call out. That is your architectural choice, if you like. If you have a stateful microservice, you need data, you need some sort of ACID database. And that is the biggie, the big database. Slonik. I think I made the point already. If you need data, use a database. In case of Postgres, use Postgres. If you have that ACID data in the database, so you've chosen to use a database, you might as well make it smart. You can put the database close or behind your microservice, and then make sure it doesn't get chatty. You need some sort of overload prevention mechanism. You need a fail whale that effectively says elegantly, I'm too busy now, please excuse me, here's the error. And then if you have a proper overload prevention mechanism, you'll find that things might scale out, but not your database, because it remains a single point of truth. I'm very curious to see how things like Cockroach and YugaDB are going to handle extreme loads or single points of truth at some point in time. Because database, by definition, is a choke point. Again, start and converge. Put as much as you can inside that database. It's more efficient. In most cases, that's more efficient. It's your choice as the architect or as the business person. You know your problem domain. You know your data. You can decide what you put in the hot database, single point of problem, or what you distribute out into your microservices, into the big wide world. And remember, if you send a microservice to Brazil with a bunch of data in it, the data will be out of date at some point in time. The picture that the whiteboard for that one is generally this. You have a standalone microservice. It's just there. There is no connection between the service, between the virus and the database with all the truth in it. If you have read-only data, you can choose to bring small databases with your microservice or connect your microservices to your big bad database. It's a light coupling. And if you do this well, you do it in a non-chatty way. Make sure you don't have to do thousands of calls to get a single answer to a customer. If you need to store asset data, you need to be sure that whatever the user enters is stored, like my hotel reservation. Please keep that safe and make sure it is there when I get to the hotel. If you need asset processing, your coupling is hard. Your microservice has to have a stateful connection to the database or a REST call with a proper reply. They are inevitably linked to the data, and there is inevitably a single point of truth and possibly a choke point. I would argue if you have that, you can consider moving the code into stored procedures and process as much as you can inside that database. And this is the big discussion point, of course. Do we want to have our processing truly inside the database or not? And for asset and important processes, I would say seriously consider putting your stuff in the database. There's a bunch of loose ends, of course. If you truly have a stateless database, do you really need an RDBMS? And because people will say, oh, I'll put my stuff in Amazon buckets and I'll pick it up when I need it, or I'll put it in object store and I'll query that when I need it, or I'll HTTP get it when I need it. Yes, but if you want your data to be efficient, it's probably a bunch of tables, and you don't want to store everything 100 times. There is old wisdom of logic, like joins and views in code, that probably belong in your database. So if you want to do, if you have to process data after picking it up, you have to think again. Maybe you could have done that processing closer to the place where the data is stored. Queries and logic and the power of SQL are still important. If you distribute your data, you might end up with something called CQRS. This is where you look into the rooms. Anyone still using or familiar with CQRS? Command query response system. Effectively, CQRS is a bunch of read-only data copies, read-only copies of your original, and you do the querying from the read copy, and you only go to the source, only go to the base when you need to do an update. It complicates your software, in my opinion, but it's usable, and it's more or less, probably more or less proven technology. If you have an asset data store, I'll say this again, you need to be able to throttle it, to protect it. You need a safety valve. It comes down to limiting the number of connections or limiting the busyness of the connections. In Java, limit your pool size. Make sure your pool size cannot grow to a disastrous number. And whatever the number is up to you. But if you have 100 microservices and each of them opens a Java connection pool with 50, 5,000 connections to a database, in my opinion, is a lot. Is probably the limit of what I can handle. You have to protect against overload. That counts for the database. That probably also accounts for your deployment repository, for your other components. At some point in time, something will melt. and you'd like to know that in advance, and you'd like to be able to give an elegant error rather than something like a 404 not found or 1555 rollback too small, or vacuum errors. If you need serious scaling, you'd have to look at something called NewSQL. The products that I know currently are Yugabyte and CockroachDB. They pretend to be able to handle a very huge load of data processing and connections. I still have to discover them. I think Yugabyte seriously looks promising, and I know a couple of people who went to work there. It's technically cool, really. Have a look at it. The last loose end is always, you have to know, you have to monitor what's happening to your system. You need metrics, probably more than just a count. Doing a count of the transaction table is a nice way of knowing how busy you were. You probably want a little bit more information. Make sure that whatever you build, a microservice or a database or anything, make sure you have a measurement system of how it's been used, what kind of trends, what kind of usage, and that you are able to evaluate what your users do with it. A zip code lookup system might get abused to verify street names or something like that. You will find in practice that your users are not using your system the way you thought they did, but they're doing something with it that you never expected. Your monitoring, your measurement should be able to find that out. You will find that a component will melt that you hadn't expected, like your network is your bottleneck rather than your database. You'd like to have the measurement in place to know that. And that is something that tends to get forgotten in microservices. People just deploy them, and then when they don't work, they don't know where to look because we don't know. Effectively, monitoring is missing in a number of cases. I'm going to repeat my main message. This is where the consultant in me looks at the watch of the customer, and then I'll tell him the time. State is important. It generally is. So if you have state, consider processing in a database. Use a database if you can. Whatever you do, minimize your calls and reduce your chattiness. In a cloud world, in a microservices world, the communication between the components is probably your even a bigger problem than storing your data. And chattiness, latency, in my opinion, is going to be the problem of the next couple of years. You have to be able to maintain your components, so simplify maintenance, create identical components, and don't deploy 1,000 of them if you can help it. Less components is always better. If you can use stored procedures, I would say do so, and you will find by using stored procedures, your database becomes your microservice. That was the original title of the talk even. Your database is your microservice. If you build stored procedures, make sure that the other components around them, the calling components, have to be as lightweight as possible, because those you will deploy, and your procedure will do the work. And whatever you call your procedures, make it one single call and return the result. If possible, in one round trip is much more efficient. If you have to mitigate the monolith, you have to find a way to prevent overload. Throttling is the word the English use. You have to be able to put a pipe somewhere so that no one can overload your critical components. And that throttling, in my opinion, has to be at the application level. I'd hate to return a funny database level when I get overloaded. If you end up with an overload type of problem, you can consider read copies and do get calls to read copies to the CQRS sort of comes back in again. The one analogy here that I've stolen from the French, you may know this guy. He carries large boulders around, and he goes to a place, picks up a rock, and carries it back to his home. I would say, take the tools, go to the rock, and work at the rock. This is, the French recognize it immediately. I'm not sure if you have this in Russia, but I think you know Asterix. Rather than carry that rock to your application, take the application and bring it to the rock. It's lighter. Really, those tools are lighter than that rock. Used to call that SmartDB. Now we call it ConvergeDB. I will say, bring your code to your data. I forgot to check my time. I'm probably way early. We have interesting times ahead. I'm quite curious how the microservices will develop, because a lot of the microservices now discover we can't really store our data. And a lot of microservices grow to containers of multiple gigabytes and then become a deployment problem. The new SQL databases that pretend to shred and shard everything, the distributed databases, that is probably going to be my point of attention for the next couple of years. I'm really curious how that will develop. There are many new systems out there, and I'm really interested in, find me over coffee. But if you guys are all over Russia, I'm in the Netherlands. It's a bit difficult to have coffee together. But I'd like to hear what you think of all this, and we should discuss. I am quite curious to see what kind of a microservice we'll have next year. Don't take my word for everything. Always read the manuals. In case of doubt, simplify. Google for simple DBA. Okay. You can find me on Twitter. You can flame me on Twitter, but if it becomes too bad, I'll block. No, I never did that. There's this German guy who said that simplicity shows the master, and I'm sure you have an equivalent proverb in Russian. If we were in a face-to-face meeting, you could tell me and I could write it down. Questions, reactions, should be. I think I'm going to pop my screen share away and read the questions. How do you want to do this?
Oh, well, we'll actually help you.
Thanks.
Thank you, Piet. That was, as usual, very intensive talk. And you're right on time. That Goethe rhyme in Russian can be literally translated like shortness is the sister of the talent.
Shortiness is the sister of the talent. Shortness is the system of shortness is the sister of talent.
So like if you explain something very short and very simple, it's like means you are very talented.
Can you write that down? I want to keep that. Yeah.
Oh,
thanks.
I sent it to you.
Thanks. Okay.
Yeah. So basically, first question is, we have microservices, and then we are talking about microservices. We're usually talking about container and all the ecosystem around the containers.
Yeah.
Some times ago, we used to tell people that containers are the thing which is designed for something very unstateful, stateless. And now we are telling people that we are putting something very stateful, a database inside the container. What is your opinion? Are actually the containers database ready already, or not yet?
The question is exactly on the topic of the presentation. And I think my soundbite now is, I am okay if you put read-only data in your container. So I'm okay with that, but only if it's not too fat. And you'd have to find out what is a practical container size for an image size for your container. And we used to say it has to be below the gigabyte. As long as your data is a limited amount of data, and small is relative because 10 years ago a megabyte was big and now a gigabyte is average and a terabyte is big. As long as your data is limited and read-only, I'm okay that you put it in a container and distribute it. And then the warning is, of course, if your data is time-dependent, that's riskful. You'd have to cycle that container every 12 hours just to make sure you get the fresh data, for example. But I'm okay with read state, with information in the container. I am less okay with something like a stock keeping number in the container. So I wouldn't save persistent data in the container. I would send it to a monolith or to a safe place somewhere. Is that relevant? Is that a sort of answer to that?
It's around that, because in addition from my side, for example, our next speaker usually used to say people that that's no difference, just put data into container. It's like it's ready. So, but I personally been a bit more old school, and I probably share your point of view in this regard.
Your container will die. Your container is disposable in theory, so you can't save anything in your container.
No, you can use the outside disks. Yeah. Probably.
Yes, correct. Mounted disks. Yeah.
Yeah. Another question is for databases. For years, we use like very specific, efficient, performance efficient connection pullers.
Yeah.
Like some of them in Java, Oracle Listener is in some regard a good connection puller. In Postgres, we use pgBalancer. Sometimes we use pgpool or Odyssey. Is there a need to have something more universal to use such a microservice architecture from the database point of view? Do we lack enough such tool? And if we do, how it's supposed to look like?
The honest answer is I don't know, but I will, because a database can only handle so many connections. There is a limit number of CPUs under your database component. So, and that determines how much calls it can do in a second. And one of the errors in microservices when they deploy Java components is that the Java connection pool is by default at 20 or 50, and it creates those connections and they sit there idle. And the container or the component only uses one connection ever, and it has 49 idles. That's a total waste of resource. Please don't do that. If you try to bundle those connections, no, let me rephrase. So your microservice has to have the discipline to not create too many connections. That's probably lesson number 1. Don't create idle connections. Pooling in a microservice is less relevant if your microservice only has one thread or one CPU available. It can only ever use one process anyway. So it shouldn't need a pool. Is that part of the answer?
Yeah, it is. It is.
And the other thing is, is pgBalancer and server-side connection pools are become the responsibility of the database. And we need to, you guys know more about this than I do, but I am not in favor of pooling on the database side. I would much rather you do a quick call over an open connection. So have the connection open, do a call, wait for the answer, than to do a call and have to activate a server-side mechanism to find another connection or to find an idle thread on my server. It would be an extra layer of overhead of finding a process or finding a connection or finding a state object to execute my code and return the result. I would rather not have pooling on the server side. But there are people who know more about this than I do. So maybe the pgBalancer team doesn't agree at all. But does that mean something? You have to have a microservice that does one call, or you have to have a program, period, that does one call, uses that connection until it gets the result, and that's it. And for efficiency reasons, you probably want to keep the connection open. One day we might come to a point where connections can be created so fast that you can actually close the connection. But there's more to that. I realize not a complete answer, but that's about what I have to say before I start saying nonsense.
It's actually a very interesting question, because in Postgres world, many people are coming from high-performance web services, high-performance web, and there is a general very suspicious attitude towards the persistent connection to the database, because then you have a large federation of servers which are starting and dying and going back, which probably corresponds to microservice architecture in some regards. It's really a difficult task to maintain a proper persistent connection with the database, because it's like slightly scary to do this. Isn't it like more difficult in microservice environment to deal with persistent connection, or maybe rather it makes it easier, or what do you think?
I think I understand why, because the high number of connections, the high number of calls in a web environment makes it very difficult to keep your connection lines open. And that's why you have something like pgBouncer and shared server in the ancient Oracle world. I'll declare myself not qualified to answer this further. But when we meet in person, we need a room with a whiteboard.
Yeah, sure.
Yes.
Sure, definitely. It's not so long way to go. I hope so.
Just another 12 months, hope.
Yeah, hope. Depends on our 5G.
But going back to the question, can you rephrase it? I think we answered only half of it, and the other half I declare myself totally incapable to answer.
Yeah, it's does the microservices bring extra difficulties to handle the persistent connection to the database?
The answer is yes, and you can mitigate that by, if you really know what you're doing, you can avoid some of that, but the problem remains.
Against the ideology of microservices? You don't need to know what you're doing if you're using microservices.
True, but if your microservice does a REST call or a HTTP call or whatever call, that the component on the receiving end of the call becomes hot. So put this down as a topic for next year's discussion or whenever meetup.
Yeah. Great. Thank you. And we almost run out of time. So thank you, Piet. Once again, a great talk. And it's really nice to have you at the PG Day Russia. Regret to say that's not offline. But
well, don't worry. There is hope, If the whole thing becomes better, I'll ride it. I'll bring my motorcycle to St. Petersburg maybe one day, please.
Yeah, hopefully next year.
Yeah, and just come to think of the connection pool, the Yugabyte will claim to be able to handle 5,000 connections just like that. Investigate that, because we are not the only ones thinking about that problem, by the way.
Yeah.
Right. Sorry.
Good point. Thank you. And now we are having some sort of lunch break. Once again, it's online lunch, so we're not serving you a proper lunch, regret to say. But we'll be glad to.
Virtual lunch.
Yeah, and we see you approximately in 1 hour. It would be.
Yeah, we will be back around 1 p.m. by Central European time. That is 2 p.m. Moscow time. So it's approximately an hour. We will come back with our next speaker. So yeah, see you soon, guys and girls.
Thank you, and see you soon.
Bye.
Bye.
Hey guys, we are back live again after our short lunch break. Hope you have had nice lunch, everyone, if you did. Our next speaker, Álvaro Hernández, he's a very well-known member of the open source and Postgres community. He's a very frequent guest, or at least he was before the recent events in Russia. He participated in many technical conferences, including PG Russia as well. And I'm very happy to have him back here with us online. Today, Álvaro will talk about scaling of Postgres. We've all heard about successes of DynamoDB and its fantastical numbers that it has shown recently when it comes to throughput. And Álvaro will offer his insights on whether Postgres can achieve the same efficiency. So let us welcome Álvaro in our room.
All right, thank you very much for the kind introduction, Roman. As known as a fact, you pronounced perfectly my name, which is quite unusual for me, but I know it's because you know Spanish very well, which is it's great. So happy to be here back at PG Day Russia. As you mentioned, I've been participating quite a few times here, and I'm very proud to come back. I would also love to come back in person, but in real life, as it's said these days. But okay, I'll wait until next year or whenever this pandemic is over for everybody. That's my hope. So today, I want to focus on an interesting topic that I hope every one of you are very interested in, which is scaling and database scaling in general, and Postgres scaling in particular. Now, what I want to talk about today is look at successful stories. And DynamoDB, as I will explain, is a very successful database or application, as we'll see later, that scales amazingly well. So one of my goals is to look at other projects outside of the Postgres realm, where most of us are usually moving around, and look outside and see what we can learn from other projects, and hopefully bring them in some other way to Postgres land. And so today, we're going to do a small study about DynamoDB, how it works internally, not what the API looks like or how to use DynamoDB, but rather how it works internally, and understanding how it works internally and how it scales, achieves the massive scales that it does, if there's an opportunity to something similar in Postgres. Hence the title, Can Postgres Scale Like DynamoDB, like following the same principles that DynamoDB does. And so we shall see whether this is possible or not. Feel free to write questions on the chat window. I will not be able to read Russian questions. I'll try to, but obviously I will have some translation helpers. If not, obviously feel free to write in English or even in Spanish, and I'll take questions more or less at the end. But you can also write down what your bet is. Can we make ever Postgres to scale like DynamoDB, or this is going to be absolutely impossible? So feel free to already drop just a yes or no or da or niet or whatever, and we'll see who. This is like a contest. Let's see who wins the contest. So just before starting, let me also do the compulsory "Who am I?" slide. I am the founder and CEO of a company called Ongres. Ongres means on Postgres, as a short for on Postgres. So it should be pretty obvious what we do. Most of you probably will know us already. We're a Postgres highly specialized company. I've been using Postgres for almost all my professional life. I started using it more than 20 years ago. Yes, it's now Postgres' birthday. It's older than the time I've been using it, but still I've been using it for such a long time. So by the way, congratulations Postgres for such a successful professional career. And I spend most of my time trying to innovate and to do research and development on databases, and obviously specifically Postgres or other databases, to bring things to Postgres and to innovate. As such, as I have been the principal architect behind some very innovative projects like ToroDB some years ago, which is a software for doing live migration of data from MongoDB to Postgres while transforming documents into relational structures in Postgres, or nowadays StackRest, which is Postgres on Kubernetes platform, very innovative, very disruptive platform for running Postgres on Kubernetes, which you should check. And I do a lot of community work. I belong to Postgres community, have created the Postgres user group in Spain, as well as a non-profit organization, a foundation called Fundación PostgreSQL. I'm doing a lot of talks at Postgres and other conferences like this one. And so, yeah, that's pretty much it. Feel free to ping me anywhere on Twitter, email, LinkedIn. I'm available. So let's dig first a little bit into DynamoDB. What it is it good for, and how it scales. So the first thing we should ask ourselves is DynamoDB good? Because that is trendy or reputed or like well-known doesn't tell me anything. There's a lot of technologies which are not so good for me that are very famous or very much used by users. That's not a measure of success, in my opinion. But if you look at, for example, what has been over the last few years, the Amazon Prime Day. Amazon Prime Day is this 2-3 days. It's not a single day, right? Where the Amazon has very good deals and offers, and people go and purchase a lot of stuff. And they use a lot of AWS, Amazon resources for doing this. That obviously DynamoDB is an Amazon Web Services exclusive software service. So if we look at these numbers, we see that DynamoDB actually achieved amazing, very impressive numbers. So here we can read from this quote made on this blog post that the DynamoDB API, DynamoDB is exposed, the database exposes a REST API, okay, HTTP API more precisely. So this API served 16.4 trillion calls, and it peaked at 80 million requests per second, which actually on 2021, which was a few days ago, a couple of weeks ago, it reached almost 90 million requests per second. And this is actually quite impressive. If you think about it, 90 million operations per second is a pretty large number. We can discuss what are these requests, whether they are small things or big transactions, but it doesn't matter. Even if they're tiny operations, 90 million operations per second is a really, really high number of operations. And this is already impressive by itself. We can discuss that maybe this was split among several tables. DynamoDB calls the unit of work a table. Postgres will say it's equivalent to a cluster, but it doesn't really matter, even if it was spread across several tables, because DynamoDB essentially is a multi-tenant service. So there were, even though it was probably only for Amazon, these numbers, they were probably split into many tenants. Again, still 90 million operations per second is a pretty hefty number. Let's compare this number just to give some perspective to another high number. I can tell you about a Postgres cluster. So look at this example. This is all public information, so it's something I can definitely disclose and talk about. This is about one of our customers, Owners customers, called GitLab.com. You probably know them, right? They're like GitHub. This is a slightly different service. And their main platform, GitLab.com, which is serving millions of users, is backed by a single Postgres cluster composed of approximately a dozen nodes, one primary and many replicas. And in overall, all this cluster, this is a single cluster, but this cluster is picking around 300,000 transactions per second. So look at the scale we're talking about here. DynamoDB, we're talking about 90 million operations per second. Maybe there are several tenants. So let's say that a tenant is doing millions of operations per second. Here we're talking about a peak of 300,000 operations or transactions per second. We might argue that maybe these transactions are heavier than DynamoDB's, but still it's a difference in scale between hundreds of thousands to millions up to 90 millions. So 2-3 orders of magnitude more performance we're achieving. So again, the question is, we love this. We would like to see if we can make something similar in Postgres. DynamoDB, other than the performance, is a building block for other services. Internally, Amazon uses DynamoDB as a backend store for many other services. Mentioned here is SQS, the queuing service, the auto-scaling service for Amazon instances, the EC2 service, CloudWatch, all the monitoring goes also to DynamoDB, the console, and possibly others. These are, I just captured this because they were known to be disrupted when there was an outage on DynamoDB. So we obviously know that they're based on them. It's actually mentioned. So it's interesting. This is very powerful, very fast, and is a building block. But so then why? Why is so popular? Why Amazon uses for critical services like Prime Day and all the services? Why people like DynamoDB other than performance, right? So let's try to understand first what it is, to understand why it's so good thing. First of all, it is a scale-out NoSQL database, and scale-out means that you can grow as much as you want. There's potentially no limits to the size or the performance that you need on DynamoDB. You can start very small and grow very large, and it will work the same way. It is also a NoSQL database. Even though there's a concept of a table, there's really no relational concepts. There's no relationships, there's no foreign keys. We'll talk, there's no joins. It's a NoSQL database. And it's based on a augmented key value model, where the key is a primary key. We're gonna discuss what it is, can be simple or composite. And then there's a value. And the value can be kind of a JSON document. It's not really JSON, but we can map it conceptually to a JSON document with a limitation that cannot be more than 400 kilobytes. But other than that is, key value, where the key may be simple or composite, and value a JSON. So schemaless, unstructured, nested fields. So you can input some richness into this model. And internally, type supports maps, lists, sets, and scalar value. So it's quite rich, being a key value store from that perspective. What is really interesting about DynamoDB is its performance. Apart from being potentially very high, it is consistent at any scale. So DynamoDB makes this claim that its performance, all its operations are performed always what is called single-digit millisecond, which in other words means below 10 milliseconds. And this is an interesting number we'll keep in mind. The other characteristic is that it is serverless. And well, buzzing around the term, it just basically means that you don't need to manage servers. You don't even need to think about it, because you don't provision based on CPU cores or memory or RAM or storage or anything. You just say, I want a table, and what you specify is the write performance that you want to have and the read performance you want to have. These are specified on units called WCU and WCU and RCU. It stands for write compute units and read compute units. They are not cores or anything like that. They're just the amount of operations per second that you want to be capped at. So you say, okay, I want to have 1,000 write operations per second and 5,000 read operations per second. So just ask for 1,000 WCUs and 5,000 RCUs, and that you'll get that performance. You want 10 times that, you ask for that, and you pay for that, of course, and that's it. So that's the model. You don't need to think about cores, memory, or anything, but rather I/O performance, essentially. And obviously, you also pay for storage and data transfer. So it's absolutely pay per use. If you just want a database to store a few data points every hours, you'll basically pay nothing. So it's also convenient to get started with. Now, what it makes it so successful, based on these characteristics that I told you, what makes it so successful? Yeah, that is serverless. A lot of people nowadays like serverless, and you don't need to manage, you don't need to think, just go, click, drop down, select, or from the CLI, create a table and use it. It's very simple. In one command on CLI, for example, you'll get it started. And you don't need to think about it. You specify the WCUs, RCUs, and that's it. Or even you can even set up dynamic provisioning for the capacity, and you will scale up and down according to some criteria. You didn't really need to think about anything. Just start using it. Also, yeah, it's interesting that you can scale without limits. You can scale to 90 million operations per second. But to be honest, not everybody needs to scale to 90 million operations per second. Unless you're Amazon, but there's only one Amazon, or couple if you consider other similar competitors, Alibaba maybe, even though they're not using DynamoDB. So you don't have this scale. So it's very good that you can scale as much as you need, but in reality, maybe you don't need that much of a scale. But anyway, it's good to have, right? So it's kind of also, yeah. So yeah, it's serverless, yeah, it can scale. But the reality, the main reason why DynamoDB is so interesting is the consistency of the performance. And the performance, I'm talking mostly about the latency. On databases, it's becoming more and more critical to understand the latency of their operations. The time bound that you have for an operation to succeed or to return an error. Because this consistency is what makes the high percentiles to be acceptable, and then complain with all your SLOs for the application and make sure the experience of the application using the database is also consistent to the user, which is sensitive to high latencies. And DynamoDB promises, this promise not always fulfilled, but mostly, let's say, yes. And when it is not, it's because of some special operations that are available. But in general, you can expect almost all operations to execute below 10 milliseconds. And at any scale, it doesn't matter if you have 1 kilobyte of data or petabytes of data, you'll still get operations below 10 milliseconds. And this is what is really compelling about DynamoDB. But wait, 10 milliseconds? That's not really fast. Postgres can do way better than that, right? Postgres can do queries in 1 millisecond, in less than milliseconds. In microseconds, you can ask or queries. If you test on your laptop, you'll get better performance than this. So why is this so special? Well, the reality is that you can get faster results with Postgres, but not at any scale. Try with a small database, then make it larger, then make it larger, to keep getting it larger, and try to see, even if you're accessing by primary key, you have the appropriate index. Well, if you have primary key, you have obviously an appropriate index. You will start increasing slowly. It's logarithmic, but at some time, you'll definitely get past this 10 milliseconds. And if you try a little bit more complicated operations, you'll soon exceed this budget. Then you'll see what the effect is in Postgres about checkpoints. And all the on vacuum, and all these operations are going to increase significantly under production scenarios your tail latency. So if you look at your P99 or P95 latency percentiles, you're going to see that you definitely exceed this. And that's the beauty of DynamoDB, that makes these operations run almost guaranteed. There's no actually guarantee from an SLA perspective, but the experience shows that they deliver on this promise of single-digit millisecond latencies. So this is what makes really DynamoDB so special. So how data is structured, and this is important for us to understand. Now we're going to dive into the internals of DynamoDB, how it is structured and how it works internally. This will help us understand how they can achieve this consistent latency of the operations. So basically, when we insert the document, let's call it document for simplicity because it can contain nested structures, it is going to have a primary key and the attributes. Let's look at the primary key first. The primary key, as I mentioned before, it can be simple or composite. If it's simple, which is the picture here in the middle, it will just contain what is called the partition key. So the primary key will equal a partition key. Guess what it is? It is a key by which data is going to be partitioned. We're going to see this later. So it's called the partition key. And the partition key, it's something which will distribute, you should select as a partition key, something that will distribute the data more or less uniformly. So something with a high cardinality. For example, in this example, we're talking about users. And if I pick a user ID, which is probably a number, and it will change per user, they're going to have thousands, millions of users. This is going to probably be a good partition key because it's going to distribute more or less uniformly with some caveats, but yeah, should work. And then the attributes. The attributes is a schemaless free-form JSON document, so I can say whatever. I can change from row to row. I can have name and surname, later name and not surname, and age, whatever I want, right? If the primary key is composite, then it's also going to have the same, a partition key, and it's going to have a second key called a sort key. It cannot be more. There cannot be more than a true tuple. And the first one is going to be the partition key. The second one is going to be a sort key. The sort key is part of a primary key that is used for having values that have the same partition key ordered by the second key, the sort key. So for example, on this example, if I'm having sensor data and I want to uniquely identify every row on this sensor data by 2 fields. One is going to be the device ID, which is a good candidate for a partition key because they will be spread more or less uniformly. But then if I want to read all the data of a given sensor, and in order, a particular order, then I can use the timestamp, which is the sort key in this example, to sort them out. And obviously the combination of the partition key and the sort key, in this example, the device ID and the timestamp, they have to be unique, not null, because they are the primary key. So this is how the data model works. Now let's look at the role of the partition key, which is important here. And this relates to the sharding logic. So to scale, DynamoDB uses sharding. This should be pretty obvious, right? And the way it does the sharding is by using this partition key. So you take a document, you have the partition key, the potential sort key, and the attributes. You just extract, for this purpose, the partition key. And you apply a hash function. It's not revealed which hash function it uses, but probably a good hash function. And this generates a value. Now, this value, called XYZ in this example, we're going to map it to a topology called a ring. A ring is just a circle, and you spread the partitions that you have. These partitions are going to be servers, right? They're called partitions. But for us, Postgres land, let's call it servers, if you like. So these partitions, which map to servers, are spread more or less uniformly. Doesn't need to actually could be randomly placed on a circle. And then when I find the value, in this case XYZ, I also map this value into the circle, and then move, for example, clockwise. And the first partition that I meet will be the partition where this value needs to be stored. So in this case, I take the partition key, I make a hash of it, I map this value into the circle. It goes to a place between partition 2 and partition 3 according to this graph. Then I move clockwise and see that this XYZ maps to partition 3. So this is called ring topology. And so with this, I know that I need to store this document into the partition 3. So how does it work exactly? In reality, behind the scenes, the architecture of DynamoDB looks like an application, an HTTP application, where the user is speaking this HTTP or HTTPS, because that's a DynamoDB API, and goes to a DNS entry point. DynamoDB is exposed as a DNS, a regional one, so one per continent, if you want to call it that way. And this DNS is going to load balance across a fleet of what I call the HTTP servers or request routers. These request routers are basically the entities that compute the hash and decide which partition this is going to belong to. And so in this case, let's say that it's going to be the bottom request router, the one who receives this particular request from the user, is going to compute the hash, is going to realize that this needs to go to partition 3, and then it will go to the server where this partition 3 is stored for this particular user, and we'll call this storage nodes, and we'll go to the storage node to execute the operation. By the way, mind you that this is multi-tenant environment, so on a single server, you may have different partitions of different users, all mixed up. They're all encrypted, addressed, and in transit is a very isolated environment, but it is multi-tenant. So other than this, of course, it's a simplified diagram. There's other elements here like metadata servers, where you have the mapping between users and partitions to storage servers, so you know exactly where to point. But conceptually, this is the idea. This request router is going to be responsible to talk directly to a single partition. Now, what kind of operations can I do with DynamoDB? First of all, there's the single value, single partition operations. They're called put item, delete item, get item, and update item, basically CRUD operations. How do they work? Very simple. That's the way I shown in the previous diagram. You compute the hash of the partition key, go to the appropriate shard, and operate on that value. Read, write, update it, or delete it. Super simple. Then we have multiple value but single partition operations, like the one called query. This one is an operation that applies mostly to composite primary keys, where you say, given this hash of this value of the partition key, which obviously will map to a single hash value, give me all the values sorted by the sort key. So in other words, using the example that we said before, give me all the readings by this device from this date to this date, for example, or order by date. That's the more precise example, right? And then there's the scan operation, which is multi-value, multi-partitions, which is basically read all data. If you look at the first two, which are the most common operations, they always talk to a single partition, which means to a single server. And this is the key to this latency. Most of the time, you're basically finding a server and just talking to that server. There is no coordination between shards. There's no talking. There's no data shuffling. There's no data movement between shards. Everything goes to one shard. And then scan operation, which is mostly discouraged to be used on DynamoDB and is expensive. It may go to multiple shards, but if you really think about it, it's a composition of a query operation. You'll just do it. The order is not guaranteed, so you can just say, okay, I'll do a query on this partition to return the results. Is the user satisfied? No, it's asking for more, and then I'll go to another one. I'll go to another one. It can also support this operation in parallel. The client says, okay, I want this number of threads, and then it will go depending on some offsets, but there's no order warranty, and it's just a superset of scan operations. So at the end, the goal of DynamoDB is try to make almost all operations essentially just go to a single shard and then compose them and avoid across nodes coordination or data shipping, because that is what will kill not necessarily scalability, but this promise of single-digit latency. So these are the operations that DynamoDB has. What are the operations that doesn't have? It doesn't have joins, doesn't have aggregates, doesn't have advanced queries like Windows subqueries. Why? Why is this? Sounds like a huge limitation, isn't it? Well, this is again done by design. If we would allow this kind of operations, we will break this promise of single-digit millisecond. If you think about it, at any scale, it is almost impossible to guarantee that any of these operations will run under 10 milliseconds. And the reason why is because they require a cross-node coordination. You need to ship data from one node or execute an operation in this node and combine the results, for example, for an aggregation. And that will kill this latency promise. So I'm not saying this is necessarily the best model or is better than others. It is just a compromise, as always. DynamoDB architects and product managers decided that the strongest promise they wanted to make is the single-digit millisecond latency. And then from this, it cascades which operations you may not have as part of the data model. If you're happy with this, that's a fantastic use case and fantastic database for you. If you're not happy with this, you should use something else. But this is the why. So how does it scale? At the beginning, when you create a DynamoDB table, you start with a small set of partitions dedicated to you. That's pretty obvious, right? If you just insert a few data every several minutes, you're not going to get a lot of resources for you. So let's say you start with 3 partitions. And they have some data on it, as we can see they're colored here in blue. And at some point, we realize that partition 1 is almost full. So what we need to do is scale out. To scale out, we'll introduce a new server. On this ring, let's say that this new partition enters in this position between partition 1 and partition 2. According to the ring buffer, the ring topology that we established before for the mapping of values to the shards, to the partitions, we realize that all values between now the segment of circle between partition 1 and partition 4, they're going to need to be migrated to partition 4, because before this, they belong to partition 2. So in this case, we initiate this data movement. It is typically done online. So it's running in parallel. So partition 4 is not active yet. And we're moving some data that is going to land on partition 4. And once all the data is moved, then we can just make it online and have it scaled out. So yes, it increases a little bit of I/O behind the scenes, but this is done online. This is using probably some tools like similar to logical replication in Postgres. So this is how DynamoDB works. And up to now, I just described DynamoDB. Now, let's look at Postgres. Can we make Postgres scale like DynamoDB? Again, I'm not saying this is the best way to scale or not. I'm just saying if we want Postgres to scale the same way as DynamoDB does, because apparently a lot of people like this model, then can we do it? And if so, how? Before this, let me take a small break to see if there's any question in the chat that I can address already. If not, I will wait until the end of the session for doing this. Okay, I think there's nothing special for now, so that's fine. We'll continue. If you have further questions or you have, write them on the chat, and we'll get them at the end of the presentation. All right. No problem. All right. So, can Postgres scale like DynamoDB? Let's look at the potential models that we may use for this. The first one that should come to mind is using Citus. Citus is an open source extension for Postgres made by previously CitusDB, now Microsoft, that allows sharding on Postgres or assists on sharding Postgres. So sounds like similar model to what we're looking for. Creating shards, splitting the data into multiple servers, and that's it. So how does Citus work? Citus has a node called the coordinator. And this coordinator has some metadata about the sharding, how ranges of data are split into multiple shards, what is the IP address of these shards, and so forth, and may also contain local tables. Local tables are tables where the information is not sharded. They're typically small tables, which you may use for local joins. When you want to join some data, for example, that will come from several shards, and at the same time, you want to join it with small lookup table, for example, to do a more complete view of the information you want to get. You can do that with a local join on the metadata, sorry, on the local tables on the Citus coordinator. So the key here under this model is that the user connects to the coordinator. This coordinator speaks the Postgres protocol, looks like a Postgres protocol, a Postgres server, regular Postgres server, but then the queries will be sent to the shards. And then the results will come back, will be processed on the coordinator, which might do further aggregation, joins with local tables, whatever is required, and then return the data to the user. That is how it works. And it's a quite powerful model because it allows you to execute a wide range of Postgres supported SQL queries, and they will go to all the shards that is appropriate to resolve this query, return the results, perform aggregations, joins, whatever is required, as I said before, and then return all the results to the user. Now, will this model allow us to scale similarly to what DynamoDB does? Well, in my opinion, no. So this is not to mean that Citus is a bad software. I think it's an excellent software and supports a wide range of sharding or scale-out scenarios. But it doesn't support, again, in my opinion, this particular one. If we want to scale like DynamoDB does, there are several limitations here. The first one is that it's a single controller. Think about this controller. It has a bit of state. The state is basically both the metadata tables, which includes the information about the shards, plus the potentially local tables that you're using. Is it possible to have a multiple controller? Yes, it is possible. You can basically set up usual Postgres, because the control is also Postgres node with the Citus extension. You can use streaming replication for these, and then use a tool like Patroni or PG auto failover for high availability. But it's not mainstream. It's not I don't know if it's really part of the project or not, because it's not fully documented as part of the CITES documentation. It is something that you're going to need to work on yourself, right? To have multiple controllers to basically avoid a single point of failure. And obviously, you cannot use local tables. You need to forget about local tables and only have metadata and this replication if you want to have multiple controllers. So in any way, having a single controller doesn't fit exactly this model that we want for scaling like DynamoDB. But then the main reason is that actually, if you recall from this diagram, I mentioned that the coordinator is going to throw the query to multiple shards. And then it's going to potentially, and then it's going to gather the results back, perform final operations like aggregation, joins with local tables if there's any, and then return the results to the user. This involves quite a fair amount of processing. So first of all, to determine which shards this query needs to be sent to, you need to parse the query. So actually, the query is going to be parsed kind of twice. It's going to be parsed with the coordinator first, and then it's going to be parsed. Then it's going to be sent to the appropriate shards, and it's going to be parsed again and executed again. But then the results may come from several shards. You need to wait until all shards have completed that query, and then they're going to be reprocessed and aggregated and reshaped or whatever is required on the coordinator and sent back. So we have in both ways of the query execution path extra time run by the coordinator. And it potentially supports more wide range of operations that we need to. It supports operations across multiple shards with aggregations, and DynamoDB doesn't support that. So this actually supposes, for this particular case, additional performance, in particular latency, extra work to do, right? So this doesn't give us a warranty that this controller is going to scale well in terms of latency. It may scale in terms of throughput, especially if you have multiple controllers, but it doesn't warranty that it will basically process every single query below this 10 milliseconds goal that we have with DynamoDB. Okay, let's look at another option. Let's use a model proposed for sharding for Postgres for quite several years already, which is a combination of two key technologies that have been introduced in Postgres. One is the Postgres foreign data wrappers. The other one is partitioning. Postgres foreign data wrappers is a way to access other Postgres servers from within a Postgres server. So you can have a connection from one, let's call it coordinator node, to multiple external servers called shards. Okay, sounds already more or less similar to CITES from this perspective. What I will do then on this coordinator, which will not store any data at all, is to create, via partitioning, a parent table, which will be the main table that I want to have, and then several partitions. These partitions, instead of being like real partitions or real tables, they will be virtual tables using the foreign data wrapper technology, connecting to external shards. So in other words, what we will see on the coordinator as a single partition, it will be in reality a whole server, a whole Postgres server. And because I have partitioning with a parent table, this is very convenient because me as a user, I will just insert or do any query just on the parent table. The Postgres query planner will determine which partitions are involved on this particular query. We'll send the query to these partitions, and these partitions, because they are foreign data wrappers, they will funnel out to the appropriate shards. So this model, which didn't work well until recent versions of Postgres because of limitations on the partitioning performance, partitioning pruning, or the push-down capabilities of the foreign data wrappers, as of today, is a quite comfortable model to use. It's almost transparent to the application. You didn't even notice that there's sharding behind the scenes, and it works more or less well, with several caveats we'll also see. So is this a good model to simulate scaling like DynamoDB? Does it have any limitations? It does. So first of all is that the foreign data wrapper technology is not able to push down all the clauses. So if I say where, and then I specify several conditions, several predicates as part of the query, maybe some of them will not be able to be pushed down to the shards. if this is the case, then we're going to be making the foreign data wrapper infrastructure is going to do wider queries to the shards, gather all the data, and then filter on this main or coordinator node. So the query results will be correct, but we may be shuffling a lot of data from the shards down to the coordinator because of limitations on the foreign data wrapper pushdown capabilities. Limitations that are disappearing with every release. Every release is getting better and better and better on pushing down more capabilities to the foreign data wrapper, but there are still some limitations. There's also this limitation that when talking to multiple shards, it works serially, or I should say it worked, or it's about to stop working serially, because there are some improvements coming here on Postgres 14. But still, if you're talking to multiple partitions, which means if your query involves multiple partitions, which will be translated to your query involving multiple shards, this performance of right now the Postgres executor will not be optimal, and it will increase the latency potentially. And I haven't run any benchmarks yet with Postgres 14, which is on beta stage. I'll be doing this shortly to assess what the performance is, but up to this point, the performance was, from a latency perspective, very bad, because it was going one by one. It couldn't open many connections at once for executing the query. So it's processing one partition at a time, which means one shard at a time. And so the latency is very bad. Throughput can be good, latency will not. And also because of the number of connections, you really want to have connection pooling. This is not a limitation, but it's complicating the architecture. But the main reason, other than these limitations, the main reason is the processing time in the controller, because we're performing something similar to what we were doing in Citus. It's just a different model of working, but we're having the coordinator node here parse the query, because it actually is the one executing the query, is going to determine the partitions that it's going to send to the partitions. They're going to wait for the data for potentially one or more partitions. It's going to final status of the query execution, and then it's going to return the results. And for these operations, we're doing extra processing, and we cannot guarantee that this will scale at the levels that we want in terms of latency. In other words, the latency may skyrocket for certain operations or certain volumes, which we cannot guarantee that will be kept below this 10 milliseconds. So what is the solution? The solution is what is called application-based sharding, which is a term that I found in the literature that is not uniformly defined. Some people call this application-based sharding. Some people call this application-assisted sharding. Some people call this application-side sharding, also abbreviated as ASS. Funny stories apart, there's no universal term for this, but the concept is pretty simple, right? So let's focus on the two previous solutions, and we'll see that the main reason for not achieving DynamoDB scale in terms of latency, both for Citus and Postgres foreign data wrappers plus partitions, is essentially the same. It is the coordinator node. We need to eliminate this coordinator to save all this processing time and eliminate all the potential complexity of these queries and parsing the queries at several points. We just need to eliminate the coordinator. If we eliminate this coordinator and have the application, instead of being super transparent and not understanding that there's a sharding process behind the scenes, if we tell the application to cooperate and ask the application to be aware of the sharding of the topology and understand the metadata servers where this is going to be placed, where the information about the shards is going to be placed and so forth, then we'll be able to direct the queries from this application to the appropriate shard. Now, when I mean application, I don't necessarily mean the final user. Final user should be totally transparent for this. But what I mean is that instead of being the user talking to a coordinator and the coordinator doing all this work, what we need to do here is the user talk to some intermediate application layer. And this application layer is directing the query to the appropriate shard. Actually, this is surprising because it sounds pretty similar. You're just replacing the coordinator by an application. How is it going to make it better? Well, the difference is actually substantial, because this, it's called request router. I call it request router in DynamoDB. That's a term used by Amazon people. So let's also call it request router here. This request router here is doing a much simpler job than the coordinator on the Citrus or Postgres for the wrapper model. It is not parsing the query. It is not determining how many shards that it needs to funnel out to. It's not doing processing after the query is returned from one or multiple shards. It's just extracting from the document the partition key, computing the hash, and then directly knowing which server to send this query to, and everything else is left for this server. So the latency introduced by this is a constant, because it's a so one. It is just extract the partition key, compute the hash, consult on the metadata tables, which should be cached in memory, and then direct to the appropriate shard. And that's it. That's all the work you need to do. And this is independent of the type of query you're doing. It's independent of the volume of data. And so it can be warranted a constant induced latency by this element. So, by the way, the last item here is interesting. This will work for all operations in DynamoDB except the scan, because they're all single shard. But as I said before, the scan operation is an operation that can be composed. And I can subdivide a scan into multiple such operations. And the same model will still apply, because I don't even need to aggregate all the results of the scan before sending it to the client. I can send the results directly to the client after performing the very first scan on a shard, and then operate on another one. So you just need to keep a very tiny amount of metadata information about the operation in memory. But I don't really need to wait until I receive all the results and aggregate them, because they're not warranted to be in order. So I can just stream them back directly to the client as soon as I start receiving from a single partition. So basically, the model is still the same, and it works this way with this application-based sharding. So let's see this on a diagram. This is probably easier to see. But this diagram, in reality, is pretty much similar to what we saw before with DynamoDB. So let's say the user is connecting to a load balancer. This load balancer could be based on DNS or IP, doesn't really matter. The user, from the client perspective, it is just an entry point. Then this load balancer is going to load balance across a fleet of request routers. These request routers are stateless. They will connect potentially to another external service called the metadata service, where the metadata about the partitions will be there, but it's not really relevant. And then let's say the request comes into the first request router according to this diagram. Then it will extract from the document this partition key, depending, irrespective of if it's a simple or a composite partition key, will compute the hash and determine this should go to the shard 2. And then it will just throw the query to the shard 2, pick the result, and send it back to the user, and we're done. That's why the job done by this request router is much, much simpler and is constant, irrespective of the operation. How could it look like? Well, this is just an exercise of pure simulation. How we would do this in Postgres. In reality, because this is a key value store, it's pretty simple. I'll have a document where I will store all the data, including the whole primary key, even if it's simple or composite, and I'll call this content. I'll use JSONB data type in Postgres because it allows us to store a JSONB. And as I said before, the primary key will be contained within this document, within this content column. Now, if the key is simple, it will only have a partition key. And this partition key has to be a primary key. So in this case, I will create a unique index on the JSONB path expression, extract the partition key, and let's say a standardize and always call partition key field of the document for the partition key, right? So I extract from content the partition key, and that is a unique index on that. So basically, I create an index on the expression, extract the primary key, the partition key, sorry, from the content to ensure that this value is unique according to the rules that this is the primary key on a simple one. And then I also need to store the hash value for this document according to the hash algorithm that I determine. And this is what will allow us to direct the query from the request router, because the request router will compute the hash value And basically, the query we're going to be performing in Postgres, once we identify which shard this hash value is stored, which could be by ranges, then I will say, hey, do insert or do update or do delete or do whatever, where the hash value equals this hash value. So it's pretty simple schema, actually. If the primary key would be composite, it will be pretty much the same, except that in this case, the unique index that I will be creating for the content part will be extracting the content partition key and the content sort key, because that's what determines the uniqueness. And that's it. That's pretty much it. So of course, this is just an example of how this could be simulated. It will be, from a Postgres detailed perspective, quite simple. Now, would this architecture scale like DynamoDB or not? Well, first of all, scaling will be essentially linear with the number of shards, because if you think about it, there's no cross-partition operations or cross-shards operations. There's no data shuffling, and the operation performed by these request routers is independent of the number of partitions. You're computing the hash. You're extracting. Request routers are extracting the partition key from the document. They're computing the hash value. They're mapping to the ring. They're determining the shard. That's it. It is irrespective. It doesn't grow with the number of shards. So yes, the scaling should be essentially linear. Then, because almost all operations are single partition, as I mentioned before, this request router knows exactly which partition to direct to. So it will just send the operation to the partition, and it will perform the operation. So it scales essentially on a linear fashion. And as I said, scan, you can composite with multiple query commands without the need to aggregate results later. So it also scales essentially linearly. Well, the architecture is a bit complex. I didn't show on this diagram the whole architecture. As I said, you need metadata servers. You need the procedure for resharding if you need to introduce new shards. So it's a quite complex thing. But in reality, it should work. So what I would say is that Postgres should be able to scale like DynamoDB. And you know why? The real reason is that in reality, after all, DynamoDB is just this. DynamoDB in reality is just an HTTP application backed by MySQL. There is a comment on Hacker News some time ago that basically says that DynamoDB is a Java application with MySQL, where Java is a very specialized Java with a lot of GNI, which is a native interface. So it's called calling C++ components with a very customized MySQL, probably stripped down of many components, maybe more just InnoDB than MySQL, but it doesn't matter. It's built exactly this way. So the final answer to this talk today, which is, can Postgres be made to scale like DynamoDB, with its good things and bad things, but with the main goal of achieving single-digit millisecond operations? The answer is yes. And the way to do it is just to follow the same architecture as DynamoDB does, which is essentially application-based sharding. So my final takeaway from this presentation today is you can achieve really good things using some of the available technologies for scaling Postgres, like Citus, or the model of foreign data wrappers and partitioning. But don't forget the power of application-assisted sharding, because if you make your application sometimes even just slightly more complex and understand a little bit that some of the operations can be made by talking directly to the appropriate shards, you don't need to go through coordinators. You can avoid coordinators. And in my view, the future of Postgres scale-out will be a combination of both, using coordinators, either Citus model or the partition and foreign data wrappers model for the most complex operations, but directly send to the appropriate shards the simpler operations. And you use later latency and better scale out. So that's mostly what I wanted to say. Just stay tuned, because there's going to be benchmarks coming soon. Follow me on Twitter if you want to know more and see the results. And I'm open to questions.
Yeah. now we are. Hi, Álvaro again.
Yeah.
So let's proceed with the questions.
I'm all ears.
Yeah, we have not a lot of time, but anyway. So the first question is how, from your point of view, DynamoDB is positioned between modern open source key value storages and things like this. Of course, some people think that it's sort of a vendor lock. Are there any alternatives which bring the same functionality but just pure open source and can be installed on the premises? So what's the difference? Where on this landscape DynamoDB is?
I don't think can be compared. DynamoDB is not that much about the technology more than the provided service. If you want to run something like DynamoDB, even if DynamoDB would be open source tomorrow, it will be huge effort for anyone to build a service like DynamoDB and operate at the scale of DynamoDB. All these servers that I mentioned that you would need to create, the architecture is highly complex. All the high availability, the backups, the resharding, those are really complex processes that you will need to run on yourself. It supports behind the scenes also authentication via IAM, which you will need to provide for authenticating the requests. Then it also connects to streams like Kinesis streams. If you really want to support global tables, if you really want to support all these things, even if it would be open source tomorrow, it will take months or years for someone to build a service and operate it the same way as DynamoDB does. So it's absolutely vendor lock-in, this is no question. But it's the service that matters here even more than the technology. People like DynamoDB because of its conveniency. Just go, click, create table, boom, start inserting data and start getting data and scales as much as you want with this single-digit millisecond prompts. So I don't think there's anything comparable, either open source or not. But we need to understand it's a service.
But do you think that some things could be emerged at some point? Because if you take a look, like things like ZenithDB, Zenith Labs, they're actually playing probably on the cloud field, but in total open source way. So maybe something can happen.
Yeah, I definitely like this project, and I have high hopes for it, as well as other projects for potentially help scaling Postgres better, including feature improvements to Citrus and the partitioning model. All these technologies are going to contribute to have something that could be more on the way of what DynamoDB does. And by the way, DynamoDB has a lot of limitations also, so I'm not saying it's by far the perfect model. This is a particular use case that has been resulted to be appealing to many, and that scales almost endlessly, right? And so I think there's a lot to learn from here, and I wish the Postgres project will take this as learnings and introduce some of these key technologies somehow into orchestration layers that we all could have from an open source perspective.
Yeah, we have another question, which is probably related to this your answer. Person asked, which programming language, in your opinion, is suited most to write such a coordinator to allow Postgres scale the way DynamoDB does?
Well, first of all, it wouldn't be a coordinator, right? As I mentioned before, it will be something like an HTTP application. If we look at purely DynamoDB API, is an HTTP API. So you receive an HTTP API, extract the document, will verify the signature of the request. If it's authorized, then you just extract the document, extract the partition key, compute the hash, direct to the query. I'm very biased here because I'm a Java programmer, and I believe Java is one of the most practical programming languages out there, and not because of the language itself, but rather because of its ecosystem. It has, in my opinion, the largest amount of libraries, ecosystem of high performance, very good quality libraries that are open source. You can just plug into your project extremely easily and just use them. And so processing things like HTTP at high performance is a very high performance language. I would say it's ideal for these kind of things. And actually, DynamoDB is apparently also built in Java, except for some C++ components used that talk directly to the database, bypassing all the parsing layers. But I would say it's a great language for this, but there could be others, obviously.
Yeah. Okay, thank you. We are
You
almost
guys,
run out of time, and
Yeah,
we
we're actually a
invite-
little bit over time already. Yeah.
We invite
Okay.
Alvaro to the Q&A room, the separate one.
Yep.
There would be
I'll be there.
instructions on Slack, and those who still have questions can ask them there. So Alvaro, thank you for coming. That was a
Pleasure.
nice talk.
Thank you.
And after short pause, we will welcome Federico Campoli with the next talk.
Okay, thank you.
Thank
Goodbye,
you.
everybody.
Bye.
See you on the next talk.
So we're back, and we ran a little bit late, so I will be short right now. We are welcoming Federico, who's joining us from Italy, I believe. And with Federico, we are continuing actually our small series of talks on how to create stable Postgres solutions using pgBackRest. We already had a great introductory course on pgBackRest in the morning, and now Federico will tell us more on how to employ the powers of this wonderful instrument along with the Patroni to make your Postgres more stable. Federico, could you please join us in the talk room?
Hello.
Hello.
Hi. Cool.
Yeah, so the stage is yours.
Thank you very much. And yep, let's start. Okay. All right. So I see the slides. And good afternoon. I'm very happy to be there. This afternoon, I will talk about Patroni and pgBackRest. This morning has been quite interesting talk from Stefan Fercot about pgBackRest Advanced, but in this case, it made my life simple because I could just keep some topics already covered by the previous talk. So, but in any way, there's a lot of stuff to go through. So let's start. I will tell you just a little about me. This guy is me. I'm on the back with showing you the back. The cat on my shoulder is my no longer kitten named Ozzy. I was born in 1972. I look younger. I started with the IT in 1982, joined the Oracle Secret Society, the Oracle DBA Secret Society in 2004. I love PostgreSQL since the 2006. At the point, I have a Postgres tattoo on my right shoulder. This guy, the FreeBSD, joined the tattoo a couple of years ago. And I work as a freelance DevOps data engineer, but I consider myself a DBA after all. Those are my contacts. My blog is not really active, honestly. My Twitter, GitHub with some projects, my LinkedIn, and my YouTube channel. I added also this thing, but I'm just publishing my videos in learning to play the guitar. is something I really want to do for a very, very long time. So let's move into the agenda, the table of contents for today. I used some reference to the movie Tron, so I can show you how old really I am. And we will have greeting programs. We will learn about the programs in our presentation, the grid, how to set up something, the lifecycle maze, complete with pgBackRest, the installation, end of line, what happens when disaster strikes, and I fight for the user, just final remarks and wisdom about what we discussed in this talk. Let's start from greeting programs. So our friend Tron, Clue, and girl, I don't remember the girl name, but she's amazing anyway. So PostgreSQL, our beloved database, is an enterprise class RDBMS. We know. Is it compliant with HA, disaster recovery? We have a lot of stuff with just one tiny little catch. There's no built-in mechanism for automating backups or failover. We have to do everything by hand, so set up stuff, usually. And that was the way we used it to work. I also made a lot of stuff, but nowadays things are no longer this way. We have great tools for doing that. So let's forget about bring your own tools, shell script, manually operated Cthulhu summoning for setting up auto failover options in Postgres. Is much better to rely on something else like Red Manager, PG auto failover, PostgreSQL automatic failover for friends PAF, or the topic of today, Patroni. Patroni has been built by Zalando. It's a great tool. It's written in Python, relies on DCS to maintain the cluster status, and this requires a lot of changer perspective. And is available in the pgDG official repository, so apt and yum or DNF, whatever. We can get just installed in a very simple way on the main kind of distribution, so Debian-based or RPM-based, Deb-based or RPM-based. Patroni, as already said, is developed in Python, supports for different flavors of DCS, etcd, console, zookeeper. We will see the example with etcd. Support for Python Raft requires the PySyncobj module for working properly. Automated bootstrap and replica setup. So there's nothing to do when you need to build up a new instance. We will see. Automated failover or switchover. Centralized configuration for Postgres stored inside the DCS. This is the way Patroni maintained the consistency across the nodes. Very resilient to the split brain. The system relies on tokens, so it's very difficult for, well, almost impossible for the system to have a split brain, because an older primary, if he fails to acquire the token, it just becomes the follower to the new primary. It's completely automated. And using HA proxy or PG bouncer, the connection can be routed via API check. So those two tools can query the API, understand and know exactly what's the primary node to connect to. So it's also possible to automate the connection routing. But we are not covering this part today. Caveats. As I said, everything is managed by Patroni, so we need a change of mind. No more manual edit for the configuration files, for example. Even the restart, we will see later, it should be managed by Patroni itself. Some part of the documentation is unclear. Yes, standby cluster, I'm talking of you. The documentation is pretty good. I think there are some parts can be improved. In particular parts not particularly common as use cases. The standby cluster is one of those. Configuring a cluster, Patroni cluster without a primary, using a remote streaming replica, a remote standby or a remote primary for just sending the wild data into this particular cluster is not explained very clear, to be honest. It took me a while for getting grip on it, but maybe I can just contribute to improve that. Client in only interactive mode. Patroni CTL is an amazing tool for managing Patroni. Unfortunately, is interactive. There's no batch operation. And so any automation for operating via API call, it has to be built using any sort of tool. The example on the documentation shows curl, but this can also be done through the Ansible URI module for just calling the API. Let's move to the other actor, the other side of the coin, the backup, so DR. Back in the days, we used it to do logical with pgdump. It's not a good idea to do anymore. Yeah, pgdump is still useful for validating the data, in particular forcing the read of any single block so we can detect if, in particular, if it coupled with the PG checksums, is very useful for understanding if our blocks are corrupted or not. But when you do a dump with pgdump, you just get a snapshot. If you do every day, you can lose 1 day of worth of data if you are unlucky enough to get the crash and lose the database before a new pgdump is complete. So physical tools, the physical tools implement the point-in-time recovery, basically. So we can restore at the last second is much more efficient in terms of, and much more dependent on the from the perspective of high available data. So we are PG-based backup. So PG-based backup is part of the distribution, Postgres distribution. We have Barman, a tool developed in Python for automating the backup and recovery. Wall-E, Wall-G. The Wall-G is the latest incarnation, has been developed in Go, if I correctly remember. And our friend pgBackRest. pgBackRest is simple, reliable solution for automating backups. I'm not spending too much on this part because we already seen Stefan talk this morning, but it's a community-driven project. It's a physical backup tool, implements HA and DR, supports different flavors of backup from full to differential incremental. It supports parallel job for performing the backup and the restore for speeding up our operations, can backup from standby server, asynchronous while push and pull. It was initially developed in Perl, now is fully migrated to the C code for performance. Actually, it's a self-contained C executable, and that's amazing. It's completely monolith. You can use it without any risk of breaking dependencies. It's an ini style configuration. The configuration is in ini style. I really like it. It's also like Patroni is available in deb yum pgdg repositories. And initially, it supported only S3 as a cloud backup option. Now they add the GCP and Azure in the supported cloud backup. We will see the GCP configuration today. Supports multiple repository for the backups we've seen in this morning. Another point of strength, I really love this part, is the self-contained backup repository. We just need the repository for being able to restore our databases, our database. There's nothing else for required, differently from other tools that use the a Postgres database for storing the backup catalog. Caveats. Configuring remote backups via SSH may be complex, require a different configuration for the backup server for the database. There's a different philosophy for the backup and the restore. So it requires attention. When configuring archive push qmax, beware, because if you overfill this value, there's the risk of all files not being archived. So there's the risk of having an invalid progression of WAL files and not completely supported point-in-time recovery. The backup, it will stop at the last contiguous WAL file available. And if in doubt, rule of thumb, always RTFM when doing operation on data. Whatever is HA, DR, or managing data, always RTFM. And for an advanced topic, we are seeing this morning. So I think this entire session will be available offline after we finished. So if you missed the talk, as being the first one, so please rewind the video and watch it. It was absolutely amazing talk. So let's move into the grid. How do we configure Patroni? Let's start from the idea. This is a super biased configuration describing Patroni. etcd is just one node. It should be at least 3 for having a way to elect a leader within the etcd cluster. Patroni, it doesn't have any connection router, but in this case, it's just fine. We need to just show how to bootstrap a Patroni cluster. So we have the 2 Patroni nodes talking with TCD. etcd decides, well, assigns the leader to be, and the leader will push the data, will stream the data through the streaming replica to the follower. So Patroni 1 is the leader, and Patroni 2 is the follower, and the streaming replica is working, is replicating the data from across the 2 nodes. In our example, we will use a CentOS 7 and the GCP bucket. I didn't use it initially. I talked about using Rocky Linux as a new, the new CentOS incarnation, not really a CentOS incarnation. But this talk last week, it wasn't there, so it took me. I had to work very, very fast for writing this talk, and so I used something that I knew. So we have 3 machines: etcd1, Patroni 1, Patroni 2. The operation, the steps to do is optionally set up etc host with the names. If we are using an environment with the DNS, this is just optional. It's very useful to have to being able to call the machine by name. Open the required ports on firewall D on etcd and Patroni. Install etcd on the etcd server. Configure and start the etcd. Install Postgres 13 and Patroni on the 2 Patroni nodes. Configure Patroni, start Patroni, and profit. Very simple. So this is just the optional step for setting up the hosts, just a match between the IP address and Patroni. In my experiments for writing this talk, I used a VirtualBox machine configured inside into a local network for having the machines talking to each other. But there are obviously different options for doing that. So next step is configure firewall D. Firewall D is the firewall daemon for provided by CentOS, and the command is very, very simple. So we need to specify firewall sudo firewall D CMD, specifying that the port has to be permanent. The zone is the only one installed initially, so it's the public zone, and add the port to on etcd, the 2 ports used for advertising and connection, 2380, 2379 on TCP protocol, and then reload the firewall D through systemctl. On Patroni, we need to open 2 ports, the Postgres port, the Postgres default port 5432, and the Patroni API port, which the default is 8008. Again, after configuring the firewall, the sudo systemctl reload firewall D. At this point, on etcd, on the etcd machine, we just need to do sudo yum install etcd. Wait for the installation, and then into the directory etc etcd, we need to edit the the prefix is quite confusing because it's called etcd.conf, but in fact is an environment file. all these variables are just environment variables for Bash, for the shell. So we need to set all these variables required to open the etcd listening to a different interface. Instead of the localhost, we need to open the DCS for listening on a specific IP address. By default, etcd listens only on localhost. So when we have set up this thing, we also specify that the initial cluster state is new, because there's no cluster state yet, no cluster etcd in our machine yet. So, and then we just need to systemctl sudo systemctl start etcd. After the start, we can use etcd-ctl specifying the endpoint, checking the cluster health, and we should get this nice message that the cluster is healthy. And we are done with the etcd. Let's move on the Patroni machines. On the Patroni machines, we need to first install the pgdg Red Hat repository, which is just downloading a no-arc RPM, which will install and configure the repository on the YAM archive, and then use YAM install PostgreSQL 13, PostgreSQL 13 contrib, and PostgreSQL 13 server. It will install basically everything we need except the source code for making this machine work. And this is for the PostgreSQL install. We are not creating the service or the instance at this point. We will let everything do by Patroni. We will get everything done by Patroni. At this point, we can move to the Patroni install. Before installing Patroni, we need to install the EPEL release. It has more libraries available in the CentOS ecosystem. And then we can install Patroni, and the Patroni etcd module, the extension, is some sort of extra data, is the set of libraries used by Patroni for connecting to etcd. In case we use a different DCS like Zookeeper or Consul, we need to install Patroni-Consul or Patroni-Zookeeper. But in this case, it's just etcd. After doing that, we create a directory in etc named Patroni, and inside this directory we create a configuration file patroni.yaml. Another thing I really like about Patroni is the fact that the configuration file is YAML and is very structured for the scope, and is translated directly into the logic of the Python dictionaries. This is not related with the niceness of YAML, but is with the niceness of the translation into the Python objects. So our configuration in Patroni, we need to specify several things. First of all, the scope, which is also the cluster name, in this case is test, the namespace, which is the folder inside the DCS where all the configuration will be created. So when we bootstrap this Patroni, we will get inside our etcd a directory Patroni_test. Inside this directory, we will get another directory named test, our cluster. And inside the cluster, inside this directory, we will get all the configuration data for the nodes we are adding to the Patroni cluster. So another thing important is the name for our node. It has to be unique within namespace and scope. So in this case, it's Patroni01. On the Patroni02, we will get the Patroni02 instead of for the name. Log directory, the REST API listen and connect address. Look at the port is the one we opened before on the firewall. And finally, and then we need to specify the etcd hosts to connect to. So the IP address, we could use also the names with the port we opened before with firewall B. And then it comes the bootstrap section. The bootstrap section is read and executed only when Patroni is bootstrap for the first time. So it means it finds an empty or not existent data area, and also he finds the etcd or the DCS empty. So he has to bootstrap completely from scratch. When this happens, when the bootstrap starts, all the information written under this specific key are used for configuring our cluster. So the DCS party, it sets the some settings for like the loop weight, retry timeout, and the maximum lag on failover. But what's important is the Postgres section and all the others. Under the Postgres section, we specify particular operating parameters in terms of Patroni, but also we can specify the Postgres parameters. So, for example, we have the use pgRewind set to true. It's not really clear on this slide, but it's set to true. It means when remastering, when recreating, reattaching an old primary to a new primary, use pgRewind for speeding up the remastering. Use replication slot is set to false, but you can set to true if you know how to do. Again, RTFM. And parameters, it sets the parameters for the newly created Postgres instance. In this case, I'm just setting one level to replica. Is redundant because it's already the default. Archive mode is set to off, and the Unix socket directory is set to a specific value, var run PostgreSQL. This is useful for having local connections automatically through the sockets, because PSQL will go searching to this directory. Then we have the method for initializing our instance, which in this case is initdb. The default is initdb. So it will call initdb with the options specified under the dictionary, under the key initdb. In this case, we are adding to the normal initdb operation encoding set to UTF-8, and also we are enabling the data checksums, which is always a good idea to have. So also, after initdb, we have the pgHBA section where we can specify additional lines to add to the pgHBA after running initdb. And finally, the users, which at the moment in this example is empty, it also allows us to specify the users to create after initdb is executed. So with the bootstrap section, we define completely our database, our cluster, our instance. We don't need to do this thing manually anymore. The Patroni, it will do everything for us. Let's move into the operational part of the configuration, because Bootstrap is executed only when bootstrapping, but we also need to tell Patroni how to operate normally. And this is done through the via the key PostgreSQL, which specifies several things. For example, the listen is a combination of listen addresses and port. In this case, it's star and 5432. Connect address, where Patroni should connect for checking his own internal stuff. Patroni 01 5432. Data directory, where we need to create the data directory. Where is located the binary directory for PostgreSQL? There's also the configuration directory. Is very specific for Debian, because Debian, it doesn't install the configuration files inside the data area. So there's all this sort of stuff. pgpass authentication, specifying the replication super user and rewind. Unfortunately, the password is set in clear. So this file should be extra secure. Parameters for operating, so one level replica, archive mode set to off. Again, we have the socket Unix directories and the tags, which are operating tags to set over the specific node. After configuring this patroni.yaml, we also need to set up the systemd service file. So in etc systemd system, we will create the Patroni service file. Inside this file is very, very simple. We have the description of the unit, after which target it should be started, the user and the group that should run Patroni, and eventually environment file, the working directory, and so on. Exec start, so we are running bin /bin /Patroni with the configuration file we have defined previously. Very important, exec reload. So how to reload Patroni by sending the sig up to the main pid. And also it's very important to set the kill mode to process, because the sig kill, it should be, well, sig kill, the sig term, the shutdown signal, it should be sent only to the main process, so Patroni can shut down the nodes gracefully. The timeout for the server to wait for start and stop. Restart equal no, because if the database, if the system crashes, we want to inspect what's happening before having an automated restart. So automated restart usually in the database universe is not a nice thing. And wanted by multi-user target. This is internal systemd specific configuration. So after setting up the unit, we need to reload the daemon. So sudo systemctl daemon reload, enable the service, and start the service. As soon as we start the service, Patroni on the first machine, I'm assuming is Patroni 01, it will contact the etcd. It will see that the etcd is empty, and then it will initiate the bootstrap operation. etcd, it will return the token leader. So it will say, Patroni 01, you are the leader, and you will become the primary. So bootstrap through initdb, with the configuration we are setting the bootstrap section, it will create the cluster and start the instance automatically. And at the end of the story, so when the cluster is up there, the Postgres instance is up and running, with the command patronictl-c with configuration file list, we will see the only node inside our Patroni. If you see, we have the cluster named test, our scope, and also the number within the parentheses is the database unique identifier, the cluster unique identifier is something you will get from the pg control file output. So we are ready for starting the second node. As soon as the second node comes up, it will try to acquire the token lead, the token leader on a TCD, and the TCD will say, "Oh, there's already a leader," and then Patroni 02 will become a replica. It will start PG-based backup against Patroni 1, and we will create a complete physical replica, and also all the part related with the primary connection, primary constring, the connection data. It will be managed and generated automatically by Patroni that will establish the streaming replica from the Patroni 01, from the leader. And at the end of the story, Patroni CTL, it will show the two members, one leader, one replica with the timeline 1, because we are just initdb, we are just initialized with initdb this instance, and the lag in megabytes. If we add writes on the leader, we will very likely see the lag in megabyte increase, because it will be calculated in terms of lag between the primary and the secondary in terms of replay operations. And that's it. We have a very nice HA solution. But this is not sufficient, because if we lose the entire set of machines, we are screwed. We cannot recover anymore. And here comes pgBackRest. pgBackRest is based on WAL archiving, rather streaming replication. And it can also back up the contents of the data area. I'm not showing in this case how to do it, but you can back up from the standbys. So it's even better for backing up very, very quickly the data without overloading the primary. So in this diagram, we are adding a GCP bucket, pgBackRest installed on Patroni 1 and Patroni 2. Patroni 1, which is the leader, is archiving into the GCP bucket the WAL files. Patroni 2 is using the streaming replica. But if for some reason the streaming replica breaks down and the WAL file is no longer available on Patroni 1, it will fall back on pgBackRest for replaying the missing WAL file. So it will also ensure an extra robustness on our streaming replication, because we will have a fallback procedure for the WAL restore. So let's configure and install the software. Again, install pgBackRest on both Patroni servers, create the GCP bucket, create the shared key JSON file, and grant access to the GCP bucket to the user owning the shared key. Configure pgBackRest for using the GCP bucket. Configure Patroni for using pgBackRest. Run pgBackRest first backup, so create the stanza and then run the backup and profit. I'm skipping the part related with GCP. The GCP part is not exactly pleasant to go through. You need to just navigate the Google interface for generating all this sort of stuff. So it's something I do not consider useful for this talk, and also it will take us a lot of time for going through. So I'm just skipping. I'm assuming I have the GCP bucket and the JSON file in place. So after installing pgBackRest, which is basically a yum install pgBackRest, we will need to set up the configuration file. We have seen the configuration file this morning from Stefan presentation. We have a global section and a stanza section. By the way, stanza in Italian it means room, but the stanza name in English is something related with poetry rather with room. So it's quite interesting choice of names. So inside the global section, we define the repo type, in this case it's GCS, repo path, the path where to create our repo inside the GCS, the bucket name, which is something you have to assign when creating the GCP bucket, the location of the GCPK .json. This file is full of sensible data, so it should be treated like a .pgpass file, accessible only by the Postgres user or the user that is supposed to run pgBackRest. We also set the repo1 retention full, so we are keeping just one full backup, and the log level console, and also where we are storing the logs. I'm using the same log where the Patroni log are stored for some sort of laziness or convenience. Then we have the stanza. In our stanza, we are specifying the location of the data area, the port to connect to Postgres, and the user to use for connecting to Postgres. I'm not specifying the host name, because in this way, the Postgres user, the pgBackRest, will use a local Unix socket connection. So the connection, it will be local, not through the network stack. It will be slightly faster, and they can also take advantage or enhance security by, for example, the peer or the ident method in pgHBA. But if we are not using pgHBA ident or peer, we may need to set up the .pgpass file for having our pgBackRest process connected to Postgres, because we need to run some sort of stuff, pgstart backup and pgstop backup. This is so inside the directory etc GCP files, we save the GCPK JSON file. I redacted all the sensible data, but there's for example, an SSH private key, so it's quite sensible, and it has to be treated as something very, very important, not to be accessible by everybody on the machine. So when we are set this thing in place, we are basically ready for configuring Patroni to use pgBackRest. So what we need to do, we need to use Patroni CTL specifying the user, the configuration file, and use the command edit config. This will access the data stored into the DCS, the configuration part, and will allow us to modify this value without the editor choice. So in my case, it's just VIM. It can be Nano, it can be Emacs, it can be anything. In this case, I'm adding the following lines. The PostgreSQL, under the PostgreSQL key, I'm adding under the parameters, archive mode, I'm changing from off to on, and I'm also adding the archive command required by pgBackRest. So the archive command using pgBackRest. So in this case, it's pgBackRest -- stanza test archive -push %p. After saving the command, the Patroni CTL list, it will show an extra column called pending restart. It means we have changed a parameter that requires a restart, an instance restart for being applied, archive mode. And so the Patroni is showing that it needs to be restarted every instance on the cluster before being applied. So we just need to run the Patroni CTL restart followed by the cluster name test. And this is the point. We are not using systemctl for restarting Patroni. We are restarting Patroni via Patroni CTL. Because if we do using systemctl, Patroni will consider this operation as a failure of the primary node, and it will fail over on the standby. So we will cause a switchover failover, call it the way you want. If we run the restart through Patroni, Patroni will shut down and restart the primary and secondaries without any risk of having the failover, because it will be managed by itself. And then we are ready for creating the stanza in pgBackRest. So as we seen this morning, pgBackRest stanza create -- stanza equal test stanza create, and then we create the stanza and we can run the backup. And when we are done this, we are good to go, because pgBackRest, it will store our backup into the GCP bucket, but also our WAL files will be archived safely into the GCP bucket. And now it comes the MCP. End of line. An asteroid, something, it just wiped out our data center, but we are lucky because the GCP bucket is stored in a different availability zone. And so we are left with nothing than the GCP bucket. How do we recover from the GCP bucket? Well, let's reinstall the machines. Let's set up the 3 machines we're seeing before, empty. Again, let's install and configure etcd, install and configure pgBackRest, again, PostgreSQL and Patroni, set up the firewall like we are seeing before. Configure, at this point, we need a different bootstrap strategy, because if we start Patroni as we've seen before, Patroni will create a completely new instance, but we don't want that. We want to restore from the GCP bucket. So we need to configure Patroni to bootstrap and clone start a new instance by using the backup stored in pgBackRest. So we can do this way. Then we start Patroni and profit. First of all, check that pgBackRest can access the repository. So always pgBackRest info. It will show you no stanza in the repository, or errors, or this nice message that says all the data is still there and your employment is safe. So for instructing Patroni for bootstrapping with pgBackRest, we need a shell script. I grabbed this thing, if I correctly remember, on GitHub. There is an example on this thing. Basically, it just manipulates the options passed by the Patroni process, and then build up 2 variables, the data directory and the scope, which is also the the cluster name. And that's the reason why I named the stanza after the cluster, the Patroni cluster name. So I can use automatically this value into my Bootstrap script. And this Bootstrap script, it does a very simple thing. It calls pgBackRest, it specifies the stanza with the variable scope, asks the restore, and also specifies the parameter link all. The link all is very important because if we have the WAL directory in a different file system and we are using symbolic links, the link only will create the data, the WAL directory into the different file system and will create the symbolic link. Same if we are using table spaces. If we don't use link all, everything will be restored inside the data area. So take care. You need to adapt to the installation of your instance when doing this sort of stuff. In the Bootstrap section, we change the method from inidb to pgBackRest. And also, we specify a new key named pgBackRest with all the commands we need to run for restoring our database, our cluster. The command for restoring, for bootstrapping, is the file I created in the previous slide. Keep existing recovery.conf false. I think in Postgres 13 there's no more recovery.conf. This is probably for just for compatibility stuff. Recovery.conf specifies what to add to the recovery.conf part. Again, in Postgres 13 is part of the PostgreSQL.conf. In this case, we are specifying recovery target timeline to latest and the restore command. So pgBackRest, stanza, archive get, %f, %p. On the other side, the PostgreSQL operational part, we also need to specify extra parameters for making pgBackRest work. In our previous example, we have written the data into the DCS, but we did not change the configuration file. So we are doing this in this moment. So we are setting archive mode to on, archive command to the pgBackRest command, but also we are specifying the create replica methods. So how do we want to create a replica when we have already a leader? In this case, we are specifying, again, pgBackRest, and pgBackRest contains similar values we are seeing in Bootstrap. So the command usr bin pgBackRest stanza test restore delta link all, parameter we are seeing this morning, delta for delta restore link all for the symbolic link management, the keep data equal true, and no parameters equal true. That's the reason why, because pgBackRest is not accepting any extra parameter coming from Patroni itself. We are specifying the entire command line into the command. And also we are setting the recovery.conf in this section. And one part I didn't find a way for automating the creation of the directory, so I had to do by myself. So make dir the missing data area, otherwise pgBackRest will fail. Set the permission on the data area and set the ownership on the data area. This is important. The data area must be in place. It can be full, it can be partially full, it can be empty, but the directory has to be present. Otherwise, pgBackRest will fail. And that's it. Start Patroni. When starting Patroni this time, we will see the state during the bootstrap running custom bootstrap script is running. The bootstrap script we are specified in the bootstrap section, and this one is just running pgBackRest restore. So it will take some time, more time than running a normal inidb, but obviously we are restoring our precious data. When everything is in place, we will get the cluster test and also the database unique identifier will be the same as seen before. Otherwise, if we are running inidb, this value will change. So we have the Patroni one up and running with the timelines shifted to 2 because we had a failover. So because the Patroni 01 first starts in recovery and then it fails over. So we have a timeline switch. Then we start Patroni on the second node. And this Patroni, it will create the replica as before, not using PG-based backup, but this time is running pgBackRest. So it will take more or less time, depending on different option. Usually it's slightly slower in particular because we are pulling from a GCP bucket. And at the end of the process, we will get a leader and the replica up and running. And we have saved the day. I love Patroni and pgBackRest working together because they save the day. They are, maybe I should have called this presentation like the dynamic duo, but I already use it for Patroni, pgBackRest, and Ansible. So probably I will think a different name in the future if I add the Ansible stuff to this thing. But anyway, we are at the end of the presentation. I fight for the user. Just a little considerations and some suggestions for implementing this thing properly. This is just an example. So please do not use in production as it is. Work on it, improve it. So step 1, point 1, Patroni and pgBackRest are amazing. They are absolutely trustworthy and amazing piece of super software that can help us to protect our data. Working with Patroni requires the DBA to change the point of view. Is necessary because the point of view is completely different. Patroni does everything. Patroni, it doesn't implement the DR, but pgBackRest does it. This example is massively biased, missing a lot of pieces. I'm not using HTTPS, there's no connection routing, etcd is just one node. So if you want to use it as a starting point. Seeing all the configuration we have to do when managing this stuff, using tools like Puppet or Ansible, personally I love Ansible, is a very, 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 very good idea. And final remark, always RTFM. Never start something without knowing what's inside the manual. Because even if you read the manual, there's something that you will miss. Even worse if you don't read. And that's all, folks. There are any questions?
So thank you, Federica. That was a very technically loaded talk, which we always appreciate. So
I try to make entertaining.
Oh yeah, yeah. It's what can mostly entertain a DBA than Patroni and pgBackRest.
Oh, doing performance tuning on bad queries. That's very, very
yeah, yeah.
exciting.
Sure. So we have a bit of time for a couple of questions before we move to the Q&A session and to the next talk. So can you actually explain maybe a bit more philosophical thing? You mentioned that usually we do not like restore from the backup. So basically pgBackRest in this case, it's some sort of last worst case scenario. So most likely we will fail over to the replica. From your experience in a such setup with Patroni and pgBackRest, how often you actually need to restore from the backup? How often could this worst case scenario happen?
From my experience, restoring from the backup has been very, very, very rare. pgBackRest is very useful if you need to restore large installations, because PG-based backup is a very good tool, but it has one weak point: is single-threaded. So you are using just one connection for streaming the blocks, not connected. So if you have an installation which is 10 gigabytes, it's fine to use. If you have 12 or 13 or 50 terabytes of data, is something that it will take a long time to complete. So pgBackRest in these terms has shown to me that is an amazing tool for using for cloning the database and creating new replicas or doing any sort of stuff. Just as a matter of example, I restored a 10 terabyte database in 30 hours with pgBackRest by using parallel processing. I had a multi-core installation, and the restore itself, it wasn't bad. The bottleneck that took more time, it was the restore, the recovery process, because at that time pgBackRest didn't have the archive push and pull asynchronous, so it has to call every single WAL file with a Perl command. It was also in Perl at that time, so it made a massive improvement in these terms.
Yeah, thank you. We have another question regarding pgBackRest as well, and it is how pgBackRest reacts on timeline changing during WAL archiving.
Well, it manages very well. The timelines are obviously the WAL name is designed to avoid to overwrite the WAL with the same name but different timeline, because the timeline is part of the WAL name. And pgBackRest follows the same philosophy. Plus, it adds the checksum at the end of the archived file. So there's no risk of overwriting an existing timeline when there is the switch. pgBackRest, it will show the timeline progression from the start at the end of the archived WALs. And this is up to the person, to the DBA, to choose which timeline to follow when restoring. And this is done as into the pgBackRest configuration file. Recovery option, you need to specify the default timeline. Normally, latest is fine, but if you want to follow a different timeline, you can specify at this in this part. And this will be set inside the recovery.conf for the Postgres still supporting recovery.conf, or into the PostgreSQL.conf.auto when for the newer versions.
Great, thank you. And we almost run out of time. So thank you, Federico, for coming. That was a very nice talk.
For having me.
Thank you.
It's been a pleasure.
Yeah, thank you. And after short pause, we will get to our next talk.
Thank you.
Hi, everyone. We are gradually moving to the end of this difficult day with yet another exciting talk, which I ultimately advise to quite wide audience, not only to developers, but to DBAs as well. And we have maybe the expert on the explaining unexplainable. It's Michael Christofides. welcome Michael. And he will tell you lots of nice stories about Explain. Hi, Michael.
Hi, thank you. That's very kind of you. Hi, everybody. Nice to see you. I am Michael Christofides, and today we're going to look at, Explain, but beyond the basics.
Great. So, audience is yours.
Wonderful. Hi, everybody. I am half the team behind a tool called pgMustard. So we visualize, explain, analyze, output, and provide advice on perhaps where the problem might be or what might be possible to speed it up. So as a result, I've spent a lot of the last few years looking into Explain plans, but also behind the scenes. So yeah, hopefully I'm here to share some of that with you today. My background is in product management, a lot of that in database tools. So obviously pgMustard, but also previously at a company called Redgate, where I spent a lot of time working on SQL Server and Oracle tools, as well as MySQL before Postgres. Below there, you can see my contact details, as well as the first link there is a link to a glossary of terms that we put together last year. Spent a lot of time on that, documenting every operation, every field that we've come across, mostly because we couldn't find good explanations of them elsewhere. So hopefully that will be helpful to some of you as well, perhaps as a reference. Wonderful. So today we are going to pick up where other talks leave off. So I've seen a lot of good introduction talks and blog posts about Explain, and they cover a lot in an hour or so, but it's such a deep topic that I wanted the next hour of that. I wanted them slightly beyond the basics. So hopefully this is that talk. Specifically, we are going to cover some of the arithmetic that you need to be able to do to calculate, for example, per operation timings or the number of rows returned at each stage, as well as some less spoken about and maybe slightly rarer issues that you can spot through Explain that maybe not everybody realizes that you can. If you are interested in the basics, then my recommendations are, as always, the Postgres documentation. So the guide's really good. It gives quite a brief introduction to Explain and then Explain Analyze. For a bit more information, I thought the ThoughtBot blog was really good. There's a post that they've kept up to date called Reading, Explain, Analyze. And then the talk I think is best for the basics is one from about 2015, 2016 time. I think he gave it a few times. It was by Josh Burkus, and like a lot of them, it's called Explaining Explain. Even though it's a few years old now, the topic, it's still super relevant. Everything in there still makes perfect sense, and it's still a really good introduction. So the aim here today is to pick up from that. Great. So yeah, specifically, the arithmetic's important for working out why is this query slow, and trying to do that as quickly as possible, and not missing something or being taken in the wrong direction. And then the second half is going to be, so we now kind of can see which part is slow, but is there anything we can do about it? And if so, what? So we're going to go into some of those. Brilliant. So yeah, firstly, a disclaimer. One of the biggest challenges with Explain plans is that they can be very text heavy, which doesn't lend them very nicely to slides. So I have edited them mostly for space, but also for clarity and anonymization. I have checked them a lot of times now, but it is still possible that I've made a mistake in editing them. So apologies in advance if I have. Great. So diving into the arithmetic, the first thing I'm going to mention is to keep an eye out for loops. So this could be, and I'll show you an example in a moment, a nested loop where one of the operations is being looped over multiple times. Many of the stats that you'll see reported and that you probably have covered in previous Explain talks, things like costs, rows, and the timings, are reported as a per loop average, so that's a mean. Now that's really useful in a lot of ways, and it's how the planner thinks, but it can cause some issues. Costs and timings are fairly specific. So costs are measured to 2 decimal places in an arbitrary unit, but they tend to be that tends to not be a big issue. And timings are 3 decimal places in milliseconds. So again, if you're around the 0.000 milliseconds, is probably not the slow part of your query. So rounding doesn't tend to be an issue there, but rows are an integer. So the difference between being rounded to 0 and being rounded to 1 can be quite dramatic when you're looking at a lot of loops. Equally, even 1 to 2 can be quite a large difference. So there are some potential rounding issues to be aware of, especially in the row department. So let's look at an actual example, and you can already see what I mean by the editing. So in this case, I've squished things onto multiple lines where they would normally be one long line. And I've put some of the numbers we're going to be looking at here in bold. So as usual with explain plans, we read kind of inside to out. So let's look at those children operations, and the index only scan, we can see that it's returning 9 rows across one loop. And then for each of those, we're then doing an index scan. So we can see that loops 9, and those are returning on average, so to the nearest integer, 10 rows per loop. If we look at the nested loop operation at the top, the parent operation, we can see that 86 rows are being returned in total. So you can already see a slight discrepancy between that number we could get from multiplying the averaged number of rows, so the 9 times the 10 versus the 86. We know the nested loop isn't discarding any rows in this case, so you can see already where rounding starts to come in. It's not going to trip you up in this simple example, but you can start to see where it can be problematic. Wonderful. So in related news, we also have threads. So this can be, so parallelism can make some of this arithmetic quite tricky as well. Again, those statistics I mentioned before are a per thread average, and that's convenient since their threads are also displayed as loops in explain analyze. You can get more information on the worker threads by using verbose. So specifically explain analyze verbose in parentheses or brackets. That's a parameter. I tend to recommend using quite a lot of parameters for explain. So the buffers one is particularly useful, but verbose is useful when you're looking at threads specifically, as well as a few other things. Importantly, the loops, you quite often see a discrepancy of 1 between the number of loops and the number of workers, and that's because the main thread is counted as a thread, as a loop, but it isn't reported in statistics. And I'll show you in a moment how we can calculate the leader thread's contribution, which is quite important because when it is doing work, it quite often does more than its fair share of the work. Great, so this is a, again, simplified edited example. And the important numbers here to look out for, again in bold, we can see the parallel sequential scan being run across 3 loops, threads in this case. Now you'd be forgiven, I think, on first glance for thinking this whole sequential scan was returning, what's that, 63,600 rows. But in fact, that needs to be multiplied by your 3, and it's more like 191,000 rows in total. Now that becomes a bit more obvious once you include the verbose and the worker numbers below, and you can see that each of those 2 are returning fewer rows than the average above, which means the leader must be returning more. And you can see from taking those numbers away from that, that average times 3, it's about 76,000. Now that's interesting when it comes to rows, but it can be really important when it comes to timings. So I haven't highlighted it here, but you can see that those two workers were taking about 66 milliseconds, and the average per thread was closer to 72 milliseconds. Now that's about 5 milliseconds higher than the two workers, which means the leader is probably taking over 80 milliseconds in total. Now that might not seem that important, but it's quite a big discrepancy versus 70. And if you're then subtracting that from a parent operation, you can start to see where, if you're not careful around these calculations, and if you naively take the average away from the parent, you might not be getting quite a true picture on where the time's going. Wonderful. So I mentioned buffers briefly just then. If we include that as a parameter as well when we're requesting explain analyze, we'll also get the number of blocks read or written at each stage. Importantly though, unlike the other numbers we've mentioned briefly, this is not a per loop average. So this is a total at the operation level. But like the others, it is inclusive of its children. So a parent operation reporting a certain number of buffers, in order to work out if the parent has been responsible for any more reads or writes, you need to subtract the numbers from the children. Luckily, this is a bit simpler than before because we don't need to multiply by loops or take anything else into account. So in the simplest case, we're back to that nested loop example from earlier. You can see that that initial index only scan we're doing is reading 4 blocks. So that's the shared hit statistic there. That means they're coming from the buffer cache. And for each of those, we're not doing, so for each of those, the index scan is not doing 101 blocks of reads. That's across all 9 loops as a total. And we can then see that the nested loop above is not doing any additional reads as expected for a nested loop. So hopefully that's nice and simple. On the slightly more complex side of things, we have timings. So as I mentioned briefly, these are per loop per thread numbers and inclusive of children. Now, the per node times can get tricky, even for tools. So we've spent quite a lot of time on this with, for PG Mustard. And it's nice to see, I think, some other tools starting to as well, which is really cool. But yeah, I'm going to show you where it can get tricky and therefore where to be maybe a little bit suspicious of what you're being told, even if you are already using tools to do this. But first, a simple example. So again, we've gone with the, I've tried to highlight the important numbers here in bold. You probably already covered previously, but that first time being reported is the startup time for the operation, and then the second time after the 2 dots is the total time. So the first one could be thought of as the time taken to return the first row, and the second time is the time taken to return all of the rows. So in this case, you can see if we again go inside out, that the index only scan is reporting that it took 0.019 milliseconds. The index scan, we can see 0.030 milliseconds, which looks a lot less than the nested loop total above, until we remember we need to multiply that by the number of loops. Once we've done that, we can see that it is in fact responsible for the majority of the time here, and the nested loop is only adding a small overhead of 0.079 milliseconds in total. Great, so that was the simpler case. This is the simplest version of a slightly more complicated case, and one of a few, but I think CTEs in general and recursive CTEs, especially those where the query references them more than once, so taking advantage of a Postgres optimization that lets it materialize that, that can get tricky in terms of timings. Now we're going to look at a really simple example here where it's fairly clear to a human where the timing is going. That's deliberate, and credit to Felix Geisendorfer for this example. He was great to talk to when we were looking at how we wanted to apportion time correctly in these cases, or at least maybe not correctly, but in a way that's most helpful performance-wise. So yes, so this is a fairly simple example where we're using a function to make Postgres sleep for 100 milliseconds, 200 milliseconds, and then referring it to it twice in the query below. So looking at the query plan for that, it's fairly clear that the whole thing is only taking 300 milliseconds. But if we were to use the rudimentary logic we've talked about so far, where we sum those or subtract those from the parent, the children total 300 plus 100 plus 200 milliseconds here, so a total of 600. Now that's due to some double counting, and each one on their own makes sense, but to a tool it needs to work out which one do you want to point at for having taken the majority of the time, or which one do you want to subtract from which. So yeah, that could be a conference talk in its own right, and part of me hopes that Felix or the other half of PG Mustard Dave give that talk one day. But for anybody super interested in ways you can do this in more complex cases, I highly recommend Felix's site, flameexplain.com, and his post specifically titled Quirk Correction. He goes into that in a bit more detail on how he views it and how he calculates it. So speaking of tools, there are so many tools that can help you visualize, explain, analyze output. A lot of IDEs offer them as well, way more than I could fit on one slide. But here are some of the more popular ones that have come across. There's the original, or a very old one, but has been kept wonderfully up to date by Depez. So explain.depez.com. You'll see that all over the place in terms of on IRC and Slack and places. It focuses it preserves the text format, but also tries to highlight some of the problematic areas and the timings, some of the timings that we talked about. Delibo is similar, but much more visible. Much more visual. That's based on a lot of you might be familiar with a tool by Alex Tatians called PEV. This is effectively, they've called it PEV2 even. There's a Russian, or it was Russian language only, a tool by Tensor that's now in English, but that's the one I'm least familiar with. So if anybody here uses that a lot and likes anything particularly about it, that would be wonderful to hear about. So I'm not as familiar with that one, but it looks great. And then Flame Explain is much newer, but that's by Felix, and he's really, really focused on trying to get these per operation timings accurate. And the reason for that is, like us, he's got a version of a flame graph in his tool, and that only makes sense if you're looking at things on a per operation level. So that becomes really important. And then PG Mustard's the one I work on. So part of the tool is a timing chart that is effectively a flame chart viewed from flame graph viewed from above or below, I guess. And yeah, we try to give advice as well, but it's a very visual tool. Brilliant. So once you've got an idea of the, in summary, I would advise checking the arithmetic and double checking, because one mistake, one missed loops number, and you could be really far out on where you think the time's going. The CTEs, be particularly cautious or maybe suspicious when you've got CTEs. And when I'm in doubt, I do check in a second tool and just see how are they apportioning times here. Is it massively different? One case I didn't go into, but I saw recently somebody having problems with was a tool not calculating partitions or subtracting partitions correctly from I think it was a gather or maybe a gather merge operation. So anytime where there's a lot of subtraction or anything subtle around CTEs, be a bit suspicious and maybe check in a second one. That would be my advice. Brilliant. So on to the second half, we're going to have a look at some of the less common issues in detail. But first, the three that pretty much every talk or blog post will at some point mention are looking out for sequential scans. Now, I would add to that, and it will become clear in a moment why, but sequential scans on their own, I think, get a bit of a bad rap. They're the fastest way of getting most of the rows from a table. It's only with your filter, or if you are or you'll later filter down to a much smaller subset of those rows, that it makes sense to think about indexing. So yeah, I would recommend looking out for those large filters, specifically on any operation, not necessarily just on sequential scans. And we'll look at an example of that in a moment. The second thing that most cover, because it's really common cause of Postgres picking the wrong plan, is if the row estimates are off. And generally they advise if it's off by a lot. I would add to that even if it's off by a small amount, but it's in your critical path or on part of your slowest subtree, they can be interesting to try to get better. And there are lots of ways that you can try to do that. But I think it's pretty well covered elsewhere, so we're not going to go into an example here. And then the third one that's fairly well covered elsewhere are, for example, sorts and hashes that spill to disk or happen on disk rather than in memory. So perhaps the solution there is reducing the memory requirements, so maybe doing it on fewer rows or fewer columns, filtering down sooner, that kind of thing. But the other thing that people often mention is increasing work mem, especially if it's still set to the default of 4 megabytes. Great, so let's look at some slightly rarer ones, or ones that aren't as well covered elsewhere at least. This one, the short version of an inefficient index scan is what I'm calling it, is an index scan where you're scanning a lot of rows still to return relatively few. So you'll see those being filtered out. There's a couple of ways Postgres can report that, and we'll look into one in a moment. Importantly, in fact, crucially for these index scans, it's worth remembering that these filters are a per loop average again. And because they are a number of rows, they're an integer, and there can be quite severe rounding issues, especially around 0 and 1 rows per loop. This is a simpler example than that, though, where we only have one loop, but you can still see a very inefficient index scan. So the rows removed by filter there is the super important thing to be looking out for. We can see here that that's over 3 million rows being removed by this filter to return, as we can see above, 1,000 rows. So the short version here is, just because your query is using an index doesn't mean it's fast, it definitely doesn't mean it's optimal. If you can work out a different index or different way of getting to those 1,000 rows that you want without having to scan the other 3,000, chances are it'll be a lot faster. So yeah, if you want to put a number to it, you could say that for this query, this index is 0.03% efficient. And yeah, my advice here again would be, do keep an eye out for that loops number. So even if your rows removed by filter is 1 or even sometimes 0, but yeah, let's say even if it's 1 and your loops number is really high, that can be problematic as well. Great. So the second issue that we're going to go through today is the concept of filtering rows late. So if we go through our query plan kind of bottom to top or inside out, this is kind of in the top left. So if you see a lot of rows disappearing quite late in the process, perhaps through a limit, but you're still having to do a lot of that work up front, chances are there's a different way to get that data, or that if you can work out a different way to get the rows that you want without having to do as much work, chances are you can do that a lot quicker. So yeah, those row calculations that we've done in the first part of the talk become really important for spotting these. Look out for a lot of rows being discarded, very similar to the tip before, and yeah, if you can, filter earlier. So super simple example here, and this would have been caused by a limit operation from memory, where you're still, because it's a sort, because the data is not coming back sorted, it still needs to get all of that data, then sort it, probably a top-end heap sort in this case, before returning the top 100. So if you can work out a way of getting that data sorted earlier, your chance will be a huge amount faster. So yeah, naturally an exception to this is an operation that's designed to do exactly this. So if it's an aggregation, then you're going to have to read a lot of rows in order to provide relatively few. So yeah, I'm not talking about that in this case. Wonderful. Next one requires you to use that buffers parameter that we were talking about earlier. So at minimum, explain, analyze buffers. Is if you're reading a lot of data, and specifically for the amount that you're returning. Again, caveat: if you want to be doing an aggregation, this might not be. You might be willing to accept this, but in other cases, it's a real big flag for an inefficiency. So yeah, lots of data being read for the amount returned, and one of the things that this can be a sign of is table or index bloat. And in order to calculate or get a feel for how much data we're talking about, it's worth knowing what block size you use. Pretty much everybody, I believe, uses the default of 8 kilobytes. Wonderful. So, simple example. Here is an index scan, and you can see a lot of loops, interestingly. One row returned per loop, and then the width value is an estimated average width in bytes. So we have a few caveats here. So that width is estimated and the rows number is rounded, and it could be anything from 0.5 rows per loop up to 1.5 rows per loop, which is quite a big difference when we consider how many loops we're talking about here. But luckily the buffers numbers are not a per loop average. So in this case, we've got, we can clearly see those. Now to get an idea of the data read, we can sum those together, times it by 8 kilobytes, and we see it's about 10 gigabytes in total. But the amount we're returning, if we times that single row by the number of loops times the 8 bytes, is only 2 megabytes. So this is a really good sign that there's likely a way more efficient way of doing this. It might not be an option for you, or it might be something to consider down the line. It might not be something you can just optimize just for this query, but it's a sign that there's something inefficient going on, or possibly a sign of bloat. Wonderful. Next are lossy bitmap scans. So you're probably aware of bitmap heap scans, bitmap index scans. It's a really cool feature in Postgres that allows it to scan one or more indexes and then keep pointers to the rows that it needs to look up in a sequential scan. So it's kind of an in-between between an index scan and a sequential scan that's really good for certain patterns. And yeah, if it's the concept of it being lossy is if it can no longer within work mem keep a pointer to every tuple ID or each row. So it instead reverts to keeping pointers to the blocks that it needs to. So therefore it needs to keep fewer of those so that it still fits in work mem. So we'll see these as lossy blocks, and I'll show you an example in a moment, but it's worth remembering these are not a per loop average, like buffers. So in this example, we can see the lossy, it's the heap blocks lossy that we're worried about. And as you can see, we still get some exact pointers. So unlike a sort, for example, this can be done partially in memory, so work mem, as work mem scales, you'll get a less and less lossy heap scan or bitmap heap scan. So yeah, this is an interesting one, but like sorts and hashes that we've discussed before, if you can reduce the amount of work in the first place, that's a better option rather than increasing the memory available. Great, so In this specific example, you can see that we are returning 3.85 million rows. But in order to do so, we're also scanning another 5.9 million that we're later removing because we brought them in because they were in the blocks that we wanted to look at, but they don't meet the condition. So in this case, the lossy blocks are a huge proportion of the total blocks, 99% in this case, but beyond that, I believe. And then the extra, we've read in 6 million, so 60% roughly of the total are being read in and tossed away. So hugely inefficient. Chances are, if you can make this better or make there be fewer, either do less work or get it done in memory, chances are it could be quite a lot faster. Wonderful. The next issue is if you're doing an index-only scan, that is no longer index only, so it still needs to go to the heap. Now this happens if the visibility map suggests that that block has since changed, since maybe the last time you vacuumed or last time vacuum was able to reset that bit in the visibility map. But the short version is this is a performance issue, because instead of only having to check in the index for the data, it's had to go to the heap. Maybe if you're doing a lot of index-only scans and you're only getting 1 or 2 heap fetches, that's probably not an issue. But it's when they're a large proportion of the total that I'd recommend taking a look. So here's an example, and this is going to also be an example of where that rows equals 0, and that being a rounded integer is problematic. So the thing to look out for is that heap fetches number. We can see 19,160 heap fetches. Now, we don't know exactly how many rows this index-only scan was returning just from this operation, but it's somewhere in the region of, well, I've put an estimate here, or sorry, a maximum. It could be up to 0.5 rows per loop, so up to 43,800 rows. The time, again, but the time we can get a much closer number for, it's a 0.037 milliseconds times that loops number. It gives us about 3.2 seconds, or 3,200 milliseconds. And the heap fetches, therefore, are at least 44% of the total rows. Could be a lot higher. Could even be 100%. But we already know that that's probably a problem. It's more than a few, and there's a chance this could be quite a lot faster if it wasn't having to do that. Great. So the next 3 I'm going to go through, I think the last 3 I've got are all things that appear in the summary section of the explain output, so right at the bottom of the query plan. You'll probably be used to reading query plans inside out anyway, but I would additionally add the advice of going straight to that bottom section and seeing if there's a dominant issue in those, just because it might avoid you having to read especially for a complex query plan, it might avoid you having to do a lot of work looking at the rest of the query plan. So one of those is planning time. And something, yes, a couple of little things to be aware of here. If you're only ever looking at queries that have really fast planning time, you'd be excused for thinking that it was included in the execution time. Now, I see this come up a lot for fast queries, people talking about this query only took 0.1 milliseconds. And you see above, you see execution time 0.1 milliseconds, but planning time 0.2 milliseconds. Now, it's tiny, but really in my head, that query's taken 0.3 milliseconds in total. So summing those together is a more, in my opinion, more appropriate total for the query. And then so you'll see that it will become obvious once the planning time is more than 50% of the total. One last caveat, for anybody using auto-explain, you might have noticed that you don't get planning time back as part of that. So this kind of issue cannot be spotted through auto-explain. So if you're ever in a situation where there's a big discrepancy between what you're seeing if you run explain manually and what you're seeing in the logs, you might have missed that it's planning time dominated. Great, so this is a super simple example, possibly the most edited of all of them, but it's just an example where planning time is a huge proportion of the total. And if you look above in the query plan, you can see where the rest of the time, the 11 milliseconds in this case, went. But there's very little benefit to speeding that up, and you're better off trying to work out why is it spending nearly 28 milliseconds planning. Great. The second of the three that you can see in that summary section at the bottom is JIT, or just-in-time compilation. So this was added in Postgres 10, but turned on by default from Postgres 12 onwards. So the idea of the feature is on average to save you time, but for some workloads, or in some cases, it can be the biggest bottleneck or the biggest problem in your query. So depending on your workload, you may even want to turn it off. I've seen some extension providers recommending that for their customers. But the way to spot it is looking at the bottom of the query plan. So crucially though, unlike planning time, JIT is included in the execution time of the operations above it. And yeah, so that's something to be aware of. So here's another summary section of a query plan. You can see that the execution time is just over 5 seconds, and the planning time is only 9 milliseconds, so not an issue in this case. But if we dive into that JIT section and jump straight to the end, which is the total, we can see that more than half the time, more than half of that execution time, or even the total time, is could be accounted for through JIT alone. So whilst you might be able to spot some optimization you can do in the tree above, this is probably your biggest problem. Yes, and if you happen to miss that, or if for some reason you're turning summary off for the query planning question, or maybe you've been given it by somebody else, and they've trimmed that to be helpful, this is another way you can spot that JIT can be that JIT might be the dominant issue. If you spot a really suspicious startup time, so remember that's the time taken to return the first row of an operation. So this example here is being taken from the example before. So it's a real world example we saw that's been anonymized. The actual time here is super suspicious. So we've got a sequential scan on a very small table. We're expecting it to return 72 rows. It only returns 54. The total number of blocks read is 3. So it's 24 kilobytes of reads, and it's taking 2.2 seconds to get started. That's, in this case, that was due to JIT, and I've seen this pattern a few times. So yeah, hopefully that helps a few of you if you ever aren't able to see the JIT in the summary section, or if you forget to check it at that one time. Great, and then the last of the three that you can spot from the summary section are any triggers, any trigger timings. So if you only ever, so first thing to note is even if you don't use triggers explicitly, chances are you are behind the scenes for things like foreign keys or any other constraints. So you might see it as a result of that. And something I haven't included here, but if you're using explain analyze verbose, you'll get the trigger names as well, which I find particularly useful because you can see, for example, if it's a constraint by the name of those. Great. So there at the end, there are total across all calls, which is obvious once there's a performance issue. So I'm not going to spend a lot of time on. But if you see a very small time, even if it has a lot of calls, it's not a problem because that small time is the total across all of them. And then one other subtle thing that probably won't matter to you as but is a thing that tools can get tripped up by, is that before triggers and after triggers are naturally accounted for differently when it comes to the timings. So the after triggers are not included in the first operations time, but they are included in the total execution time. Any before triggers are also accounted for in that top parent or root operation. So unfortunately, there's no way of telling programmatically as a tool whether a trigger is before trigger or an after trigger. Sometimes you can infer it, but that's something that tools might struggle with in terms of telling you exactly which operations are responsible for how much time. Great. So as I mentioned, here's a trigger name that's come from running verbose. So we can see RI, so referential integrity, underscore constraint trigger. And then that's taking a total of 83 seconds or 83,000 milliseconds across a lot of calls, 2 million calls. That's a huge proportion, or 95% of the total time for this query. Definitely the dominant issue, and very little point looking at the rest of the query plan, except to work out which constraint is this. The most common place we see this is in deletes of a lot of rows where the foreign key in question has not been indexed. So you probably all know that foreign keys in Postgres aren't indexed by default. So yeah, that's the most common place we see this, but it obviously can appear elsewhere as well. Great. So in summary, for the rarer issues, I recommend checking that summary section first before you do anything else, just in case you spot a dominant issue in there and can avoid the rest of the time spent analyzing it. Look out for all of the things I mentioned, or bear in mind that just because it's not got a sequential scan with a large filter, or you can't spot any operations on disk, or you can't see any really bad row estimates, don't give up. There's a lot of other things you can look out for. Filters, rechecks, lossy blocks, heap fetches, even trying to work out how much data is being read at each stage for the amount returned. So yeah, that's not exhaustive. There are a few others as well that we look out for and we want to point out in future. And yeah, as I mentioned, there are tools to help with this kind of thing. And if you've spent quite a while on it and still stuck, there's a huge number of Postgres communities, including the performance mailing list, that we found really helpful and got a lot of ideas from. On that note, the last link here is particularly helpful. So it's advice on how to ask for help when you've got a slow query. But as a result, it's also a really good debugging process. So in gathering the information you need to help others, there's a decent chance you'll spot what the problem was yourself. I suspect that's not an accident, but it is really helpful when people have followed that, and then the community can normally help them really quickly. The other two links here I've mentioned previously, the quirk correction post by Felix around especially useful for CTE timing calculations, and the explain docs or glossary that we spent a lot of time on last year. Probably don't want to read through that. It'll probably be pretty dull read, but a really good reference guide if there's ever an operation you spot that you've not heard of before, or you want to check whether one of these statistics that we've been talking about is per loop, whether it's an average, or we've also linked to things like the Postgres source code or other guides on or like maybe even Stack Overflow posts that we found that have been helpful. So hopefully that'll be a good resource for you. Yeah, I think we're going to go live for some questions in a moment, but if you are watching this afterwards, or if you'd prefer to do it privately, that's my email address. Very welcome to contact me, and that's my handle on pretty much all of the Postgres community sites. Cool, I think that's it. Thank you.
So thank you, Michael. That was a great talk.
Thank you
so much.
I would say a very precise and very methodical as usually, but probably it's the only way to explain. A bit of questions to you. So for many people, starting with explain is sort of the task when they do not know where to go, from which point to start, which queries should be explained. Do you have some advice how to work with this? So from which point to start?
Yes, so well, I think it's a really good point that explain can only really help you once you know which queries which query you want to look into, or which query is problematic for you. So it can help you go from this query is slow to what can I do about it. In terms of actually working out which query is slow, you're probably better than me. But my understanding is there are if you don't have pgstat statements already installed, that's almost a must for people, and that can help you look at your top 10 queries by total execution time. And there's a chance that some in there are optimized, but there's a good chance that some in there aren't. And that seems to be a particularly popular way. But yeah, otherwise there's a lot of monitoring tools, aren't there? And I think there's even an alternative to pgstat statements by the team at Percona that looks really interesting. But I'd be interested in your thoughts on that as well.
Yeah, well, I always trying to figure out that myself, because people keep asking those questions. And if people starting to take a look on the database with lots of complexity queries, it's just a bit strange to try to optimize everything, because you do not have all the time in the world to do this. So yeah, basically I'm always tending to start with some top queries. And then this top changes drastically after first optimizations. So it's usually like this. We have rather a couple of comments instead of questions, which are saying that's very good talk, and thanking you about this in our YouTube chat.
Thank you.
Another common question, actually, are you lacking some instruments in PostgreSQL explain? So are there some things which could be improved, some functionality which is not there and could be probably be better?
Always, right? We're incredibly grateful to the people that are responsible for the planner, and the Postgres team's incredible. We've seen some talks recently by Robert Haas and Peter. I'm not going to try and pronounce his second name, but yeah. As somebody with a difficult to pronounce second name, I can sympathize. But yeah, so we love, yeah, right. I'm in the right crowd for that. Yes, there is a really good patch that I think needs some extra reviews, but I'm not sure. I think hopefully it will make Postgres 15. But somebody is working on giving you a max and min and total number of rows per loop. So it's not a per loop average anymore. So I think that would, a lot of the caveats I gave in that talk were around looking out for row numbers that have been averaged and might be hiding some important information. I think that would be added with the verbose parameter. That's the patch that's in there at the moment. I think that would be incredibly helpful, especially for tools, but also for humans. And in terms of other things, yeah, I have to think about it. I think we haven't spotted many things that we're frustrated by. There is one. There's if you're on a system with a really expensive system clock lookup, you can end up with timings having quite a high overhead. And I think there's some people thinking about how you could reduce that even on systems with that high overhead. But I think most modern systems don't have it. So my understanding is it might be something people are more scared of than it is true in reality. But in specific cases, it can be very misleading.
Mm-hmm. Yeah, thanks. That's That's actually interesting. Yeah. I probably always thinking if we can have some sort of trace information more than buffers, like wait events, things in explain. But it's usually always connected to things you mentioned. That's clock thing became extremely expensive in this regard. Yeah. Okay, so it looks like we do not have any more questions, but we have one another thank you. So people appreciate this. But anyway, we invite you to the Q&A channel in Slack, just in case if anyone hesitate to ask things, and probably people would ask further questions more privately on the credentials you gave them. Thank you. That was an excellent talk, as I told already. And we make a short pause before we welcome our last speaker, Bruce Momjian. And we'll be back soon.
Thank you so much. Thank you.
So we are ready for our final talk, and I don't think that our next speaker, Bruce, needs a lot of introduction because he's like the godfather of the Postgres community. And so I will just allow myself to share some sentiments about Bruce. He's a wonderful speaker and probably one of my favorite speakers, and not just in the Postgres community, for his approach to detail and just wonderful way of explaining things that you just get them, really. And I feel like it's very appropriate for it to be Bruce who closes our conference with this talk that looks into the future of Postgres and tells us all about what's going to happen with the next upcoming release. And so I am very happy to invite Bruce to our room. Can we? Okay. Hi, Bruce.
Hello.
So without further comments, the floor is yours, please.
Wonderful. Well, thank you very much. I do appreciate the opportunity of being able to present today. It's an honor to be able to speak to you and to talk to you about Postgres 14. Obviously, this has been a a challenging year for all of us, and it's nice to see the Postgres has continued in a good way during the pandemic. I'm gonna show you sort of my highlights for Postgres 14, give you some of the backstory of some of the features, talk to you a little bit about the strategy of how I see the release, and then also talk about where I think things are going. So this release obviously is, as typical, has been around, been development for roughly a year at this point. We started in late June of 2020 with this particular release. This release is scheduled to appear in September, October of this year. And I'm pretty happy with the results. We weren't sure exactly how the pandemic was going to affect us, but in fact, it ended up being very positive. Again, my name is Bruce Momjian. I am one of the Postgres core team members, EDB employee. If you're interested in looking at my slides, they are right here at this URL, in addition to 58 other presentations, which is kind of surprising, but that I actually got the number recently. Again, if you find something you want to review back or you want to look at another presentation, I think there's 89 different videos of me giving presentations. So again, if you want to find a presentation and watch another video, feel free to do that. But today we're going to talk about Postgres 14, and I think you're going to find it quite interesting. What I did was I took the 8 major things that I think are in this release, and I want to go through those in detail, and kind of explain why I think they're important. Now, here at the bottom, there's a URL that has a link to the full release notes. So if you want to look through the entire release notes, and I recommend you do, that's the URL for you. One interesting aspect of this release is that typically, if you look back over the past 10 years, Postgres typically has between 170 and 190 features in every release. This release has 222. So that's roughly a 20% increase in the number of features, or actually 15%, 10%, and I think that's pretty significant to have a jump like that from roughly, we were averaging about 175 roughly the past couple of years, and it jumped to 222 or 224. I think is the current count, is pretty impressive, and I think. I'm not sure if some of that is related to the pandemic and people being more available, working from home, or if it's increased interest, increased activity from a lot of the companies and users of Postgres. So I just don't know which one it is that's sort of driving that increase. It'll be very interesting to see if Postgres 15 has a similar count that's high, or whether it kind of goes back down to the 170, 180 range. Obviously, the pandemic has not affected our ability to put out the software. It has obviously adversely affected the events that we've been able to do. I usually do about 35 events a year, many of them in Russia. I have not done any events since February of last year. In person, the odd thing is I've still done the same number of online events. I am hopeful that maybe I'll be able to come to High Load in the fall. There may also be another Postgres conference or two maybe in Russia in the fall, and I would love to go to those if it's possible. So it looks like things are starting up, and we. I will say there is not a single big feature in this release. We have had releases where partitioning was the big feature, or logical replication was the big feature, or something that was sort of massive that you could say this is the big carrier. In this release, I can't say we have a big carrier. What we do have is a lot of improvements in what I want to call edge cases, edge use cases, things like doing massive insert updates into partition tables. There have been some vacuuming improvements, particularly one related to vacuuming of databases with a large number of objects, which had been a problem that somebody, I believe one of our Russian colleagues has reported, and I'm hoping this is going to fix that. I think it was somebody from Yandex actually reported the problem. And we have the ability to rewind with logical standbys. So there's some sort of edge case cleanups in there. And again, when you start to look at the release notes, you'll start to see that. But what I tried to pick here were the sort of either features you aren't going to see a lot, but are going to make a big impact. So things that might be a feature you don't even have to configure, it's just there. Or features you might not really think are important when you read them in the release notes, but actually I think are going to be pretty significant. And that's why I kind of picked this 8 that I think are going to be pretty strategic. There's also a lot of features out there that I'm not really clear how significant they're going to be. For example, we have a new compression method for toast storage. How significant is that going to be? I don't know. We're going to have to see. We have array subscripting capability for non-array data types like JSON. These are things I'm not really clear exactly what their impact's going to be. But these ones that I picked, I think, are going to be pretty interesting. And again, a lot of them you may not kind of catch when you read it, and that's why I wanted to kind of go over these. And I think these will have, to me, these will have sort of the widest impact in terms of usability and adoption for Postgres. And the first one is something that all databases have to deal with. It's really not a problem unique to Vacuum or unique to MVCC, but the problem really is keeping a B tree index lean. Preventing bloat or preventing almost empty or a lot of empty pages from sort of bloating or increasing the size of a B tree index. This problem goes back, back into the 70s probably. And every year we seem to make small improvements of it. You may remember last year, thanks to code we got from Russians, we were able to add code that more efficiently handled duplicate entries in B tree indexes. So if you might remember that from Postgres 13, duplicate handling was greatly improved, and I think that's been pretty significant. This one is kind of an interesting one. I'm going to try and explain it to you why it's important, and there's a philosophical kind of idea to this I think you'll appreciate. So this is typically the way a B-tree index is laid out. You have an internal page at the top, and then you have leaf pages underneath it, and the leaf pages effectively point to the heap pages. So this is a standard way that B-tree works. And if I look at it a little differently, what I've done is I've sort of split apart, you know, the detail. And what I'm showing you here on in the leaf page on the left is that the leaf page on the left is almost full, and it's got a couple dead rows in there, and that's the blue. You see the dead entries there. On the right, you see a page that is completely full. So you see it's completely pink. So what we have is we have a page that's completely full, but there's a couple dead row pointers in here. These are row pointers to either updated rows that have been expired, or they're basically row pointers of deleted rows that were marked as deleted back when somebody accessed them a while back, but they're still in the index. And previously to this, only the vacuum process, which you may be familiar with, would come along and remove these dead index entries and so forth. But the problem is if you needed to add a row to an index and it happened to need to be on the right-hand page, in previous versions of Postgres, there was no way to put the row there because vacuum was going to run sometime in the future. You know, you were performing an insert or you're performing an update, and you needed space on this right-hand page. So effectively what we would do we would split the page. So this page would become, the page on the right would become two pages, and half full roughly, or 2/3 full on one, 1/3 on the other. And the page would split, okay? And the problem there is that effectively you're splitting a page when you kind of could be more aggressive. So what Postgres 14 will do is when it sees a full page and needs to put a row in that page, instead of splitting the page, which is somewhat of a permanent operation because we don't merging B-tree pages in a concurrent environment is very hard. What we actually do is we remove the dead row pointers and we free up space. So now I can do the insert. Okay, so I'm going back a slide. So instead of this, and we're trying to insert and the page is full, we're going to remove the dead pointers, the dead index entries, and we're going to make space, and now we can insert into it. Now you might think, okay, this is like a rare case. Why is this the #1 item he's picked? And Peter Gagan, who sort of authored this concept, really had an interesting email discussion talking about it. And he said, people optimize for the common case. So when they're looking to gain performance, they're looking to optimize for what's a common, what's a common problem, what's a common inefficiency. But he said, when we're looking at performance, we should also look at rare activities that have permanent consequences. So I'm going to kind of say that again. He was basically saying, normally when people look at performance, they look at things that happen commonly. So if I have a loop and that loop is commonly run and it's inefficient, I can improve that. But what he's also saying, he says there are some rare cases that should also be optimized if those rare cases have permanent negative consequences. And in this case, and I think the reason we hadn't optimized this is the first time we've kind of done this optimization, is the idea that a page is going to be full and have some dead row pointers in it like this one is fairly rare, right? But what he's saying is that if you split this page on the right, you create two pages, you're never going to get those pages back to one page again. For the life of that index, you're going to have two pages there, even if no new rows ever come into those two new pages, okay? Because it's very hard to merge B-tree pages while there's concurrent operations going on. You typically have to reindex the column or recreate the index to fix that. So what he's saying is that this is a rare case, but every time this rare case happens, we're creating bloat in the table. And over time, this is why I don't think people really, I didn't think people were really going to kind of get it unless I kind of went over it. Over time, these rare cases happen once a day, twice a day, 3 times a day. After a couple months, you potentially have a lot more bloat in the B tree index than you should. So again, I don't really understand I'm not positive what value this is going to be, but I think it's going to be pretty significant. The other good thing is there's nothing you need to do. You install 14 and it's there, right? So to me, that's a beautiful way to go. So that's why that was my number one. It philosophically, it handles a rare case that has permanent negative consequences. And second, it's automatically enabled by default. There's nothing you have to do. And that's why I named this one number one. I have a tendency to like the more complicated features anyway, but I think that's kind of cool. Number 2, BRIN indexes improvements. You're probably aware of BRIN indexes. We've had them for many years. Thomas Vondra, I think, and Álvaro Hernández worked really hard to kind of get this in. And for this particular release, we've kind of taken BRIN indexes sort of to the next level, I would say. So as you may know, BRIN indexes up until Postgres 14 effectively took a range of pages or a range of bytes in the table, maybe a megabyte, and it had a min-max value for that megabyte. And then when you scan the index, it would tell you, the minimum and maximum it existed in that 1 megabyte range, and if your value was in that between the min and max, you had to scan that range. And if it wasn't, you could skip it and go to the next one. So again, for really big tables, this was very useful. However, there was a problem, and the problem was that the min-max indexes only had 1 min and max, right? So you couldn't, you just had a min and max. You didn't have anything like more granular. So in Postgres 14, you can effectively have multiple min and max ranges. So for example, you may say this was 1 megabyte range has values between 10 and 0 and 10 and 30 and 40, right? So now instead of having just two values of min and max, you can have multiple min and max ranges within a single block, 1 megabyte chunk. So there are certain values that makes a lot of sense for. Not everyone, but I think there are definitely use cases where this min and max will be beneficial. So again, you can control how many of these min maxes you want per range. But again, if you've got a complex layout, you might find that having multiple min maxes is valuable. The second feature, which I think is really a game changer, is that typically BRIN indexes were only good for data that had some kind of locality. So data that had some, particularly, it was really good for time series data, where you're always adding to the end of the table. So you had, typically you had, certain months at one part of the table and maybe a certain month at another. You could still move stuff around, but you had to have some kind of locality typically for min-max to make sense. In this change now, we can actually use what's called a Bloom filter. So the whole requirement of locality is kind of gone. You end up with basically creating a huge Boolean array, and you hash your constant. You don't sort of have to do min-max anymore. You hash your constant, and your constant represents a bit in that big array, and you just basically mark that bit as present or not present. So you can basically say, I'm looking for a certain value. I hash my value. I look at the bitmap. Is there a 1 there or not? If there's a 1 there, it might be in the range. If there's a 0 there, it's not in the range. That's the way typically you know, it's a lossy index. You don't know for sure it's in, but if it says it isn't there, you can be sure it isn't there. Same thing with the way min-max works. So again, I think this is taking Brin to a completely different level because the locality requirement really isn't there anymore. Now you can do it with distinct values rather than ranges, which only, again, worked for certain use cases. So again, I'll be really interested to see what type of data use we end up using with these Bloom filters. But this all work done by Thomas Vondra. I think it's really, really interesting, particularly the Bloom filter one, which I think takes Brin indexes to another level. Number 3, this is work by Andres Schröd. And again, this is one of those, like, you're going to squint and say, I don't get this. I had trouble understanding it. But basically, if you've been around Postgres for a long time and heard some complaints over time, and I know we've had complaints from Russia, particularly, that Postgres didn't perform well with very high connection counts. So if you had 100 connections, you know, 400 connections, Postgres ran fine. But if you had thousands of connections, 5,000 connections, 10,000 connections, Postgres, it didn't perform well, and particularly didn't perform well as other competing relational databases. The reason for that, we've been sort of chipping away at this problem for a while, but this is we did a little bit in 13 related to this, but 14 is I think going to be the big one. And the big holding, or the big slowdown we had seen in that 5,000 connection workload is something called snapshot acquisition or snapshot generation. So this slide here is from my MVCC talk, and effectively every time you start a transaction, you have to generate something called a snapshot. And that snapshot says which rows you can see and which rows you can't see. Again, very, very typical for MVCC. And when you had 100 connections or 400 connections, that snapshot could be computed very easily. But when you had thousands of connections, particularly thousands of idle connections, so you may have only 50 active connections, but you may have thousands of idle connections. Imagine. When Postgres would sort of look through all the connections to figure out which ones are active, which ones weren't, it would slow down Postgres because it had to look through all thousands of these connections. So what Andres did is he basically restructured the way that we track and way that we compute these snapshots in a very clever way, which allows you to quickly acquire or quickly compute the snapshot for a new transaction without being slowed down by a lot of inactive transactions or inactive sessions that may just be sitting idle. So again, I think this is interesting. It happens automatically. Again, there's nothing you need to do, but just like with the B tree expansion, I think this kind of this is going to allow Postgres to work in more high connection environments with better performance than I think we had in the past. Now, where this probably is not going to help, if you have 1,000 active connections and very few inactive ones, is probably not going to help you. Where I think the major help is going to be is when you have a lot of inactive connections and being able to compute a snapshot without being slowed down by having to look at thousands of other idle connections. I think that's going to be the real win. And I've seen Andres had some pretty interesting calculations of the speed up of that. Because again, you don't know, sometimes your system's very busy, sometimes it's idle. You want the system to sort of adjust to that automatically. And I think you're going to get that here. So I'm excited about that one. This one has a whole story on its own. I'm not really sure where to start. I guess I'll start. I was in Korea probably 8 years ago at an EDB customer. And the customer explained that they were using pgstat statements, which everyone loves, right? And he said, I'm using pgstat statements. As you know, pgstat statements will take a query, it'll remove the constants, it'll generate a hash, and then it will compute for that particular hash how long the query takes, and then you can get aggregate stats on, well, how often did I run this type of query, irregardless of the constants? How long did it take? How many times did I run it? What was the average runtime? So forth. But he said, you know, he said, I'd like to take the information from pgstat statements, and I'd like to be able to look at a current query. So this is really interesting. He said, if I look at pgstat statements, it tells me a certain query takes 5 minutes. I should be able to look at my current queries and look up, okay, for this query that's in pgstat activity, what is the average runtime as reported by pgstat statements, right? You want to be able to get that query. You want to be able to take the query ID of a running query, get the ID, get the hash of that, and compare it to pgstat statements. And again, this sat in my inbox or in my sort of to-do wish list for like 7 years. And fortunately, we got it in Postgres 14. It was not easy. It's actually, you would think it's really, you would think it should be really easy because how hard could it be? We already have the code. It's already in pgstat statements. Why can't we just move it over? But Julian Rahaud, who actually is French, but he lives in Singapore now. He worked really hard to get this code out of pgstat statements and into the core server so that you could see it in pgstat activity and you could also see it in the server logs. The reason it was complicated is because the computation of this hash is fairly expensive. So I think we saw something like a 2% overhead of computing this hash, which I was kind of high, but that's what it is. So we couldn't enable it by default, but at the same time, everyone was using pgstat statements, so we didn't want to require everyone using pgstat statements to somehow also configure the server to compute the query ID. I actually committed Julian's code, which did it that way. And about 2 weeks before feature freeze, people said, oh, I'm using pgstat statements. I don't want to go and modify PostgreSQL. And I'm like, how hard can that be? Like, you already installed pgstat statements. I know, but you know, I'm so used to it. And anyway, we had a big discussion. Álvaro Herrera ended up being the committer of this because I kind of it was so close to feature freeze that I passed it to Álvaro because I thought he would be better at fixing it and making sure it worked, because he uses pgstat statements a lot, so he could like test it and make sure everyone was happy. Because it was the weird thing, like I got Julian's code in, and then 2 weeks before, everyone's like, no, I don't want to have to modify PostgreSQL to deal with pgstat statements. I want it just to work on its own. So the end result was that we have a new server variable called compute query ID, which you can see here in red, but the default is auto. And auto means that an extension can turn on the query ID computation, which is kind of unusual for an extension to be controlling the server, but to prevent any kind of need for modification of the PostgreSQL, you had to have a way for an extension to enable it. So I thought that was kind of odd, but anyway, Julian was good with it. Álvaro Herrera was good with it, so it's in. But again, this was a weird case where the actual code was easy. It was getting everyone to agree on what the API should be with the interaction with pgstat statements that was so hard. And also we have to allow for extensions to compute their own query ID. If they want to, you can have an extension use its own algorithm for query ID as well. So again, it got really complicated, but I'm really happy that we got it in. Julian, I'm sure, is happy. and I'm very, very pleased. And I think this is a big one because, as I explained from the Korean example, you now can tie pgstat statements to pgstat activity and the server log, and now have a one place, or what we call a global query ID computation, that you can use to sort of reference the same query types without constants in all of these places at once. So I think this is really opening a whole new way of doing monitoring. To enable it, I used alter system here to turn on compute query ID to on instead of auto. I did set logline prefix, and what I did is I added a new letter %q, which will output the query hash. And then I also said logmin duration statement, as you can see here at the bottom. The query ID appears in pgstat activity, and it also appears in the server log. So again, I think this is really a big thing. You might not sort of see it that way, but it opens up a completely new way of getting analysis of queries that I'm surprised it took us so long, but we got here, so I'm happy. This is another one, number 5, which is one that you would think we would have had forever, but we kept thinking, how do we do this cleanly? How do we do this without like causing weird behavior? But we ended up just, I guess, by the time we came to 14, we're like, oh, we're just going to do it. So the new setting is idle session timeout. You set idle session timeout to 1. If you wait 2 seconds and then you type select 1, okay, it basically disconnects you. So between this command and this command was 2 seconds. And by the time this was issued, I'd already been disconnected. So this, again, kind of related to what I talked about earlier with the snapshot computation. This gives you another way of trimming or removing sessions that are not active. We think it's awkward that you're just thrown out, like you just get this error, but there's really nothing else we can do, right? You've disconnected. We've disconnected you. You no longer have a connection to the database, and you get an error. So not much we could do there. It is what it is. But it's something you would have thought that we could have done a long time ago. But I think there was some sense that just disconnecting people is rude or disruptive. But there's some people clearly who want this, and I think I'm very excited we got it. Number 6. This is a really interesting one. I'm not even sure how to kind of explain this, but Stephen Frost has been doing a lot of work with what used to be called default roles, but will now be called in Postgres 14 predefined roles. So when we used to call them default, people would think, oh, that's like I default to something, but in fact, they aren't really that. They're just predefined. There's nothing really default about them. So those were renamed in Postgres 14. So you're going to see the term predefined roles a lot more. And 2 new predefined roles, which I think are really powerful, is a role that allows you to read all data and a role that allows you to write all data. So in this example here, I'm creating user 1, user 2. User 1 is a standard user. User 2 is in a group called pgRead all data. That's all we did with that. That's the only difference between the 2 users. Then we create a table with the value 100. We connect as user 1. We do select, and not surprisingly, we can't see it. Because I was Postgres as I created the user, because I was a super user. Now, obviously, as user 1, I can't read from that table. I haven't been granted select permission on that table. Okay. But then I switched to user 2. And the big takeaway here is that when I select from user 2 can see the data, even though they haven't been granted anything different than user 1. All right. And of course, the same happens with write, with the PG, write all data. These are very powerful roles. Don't use them, capriciously. But for example, if you wanted to create a backup user which could read all of the data, that kind of thing, this would be a very natural role to give that person, and they couldn't write any of the data, but they could read all of it. So again, I think this is kind of very powerful, and I'm glad to have this new capability, because I think it makes management a lot easier. Number 7 is kind of a catch-all. There are 3 optimizer improvements I think are important. The first one is the use of a hash lookup for an in clause with many constants. We've all seen queries where, whether they're user created or computer generated, where they say, where column in parenthesis, and the numbers just go wrap around the screen. And you're like, whoa, how does that happen? Well, a lot of, auto-generated code is that way. Sometimes there are legitimate reasons to have that many constants instead of having them in a separate table, any of this list. And I just hash it, and I can see right away if the value's there or not. So again, I think it's not a common use case, but it's a use case that people expect to work fast. And sometimes it didn't if there was a lot of constants. And I think that's a really nice change. The last 2 that are mostly Thomas Vondra from Prague, and they're related to extended statistics. Now, you might not be familiar with extended statistics. Extended statistics are. I was so happy when Tomas did this a couple of years ago, because there were so many cases where the optimizer was not able to get good statistics, particularly when there was some interaction between, like, say, 2 columns or 3 columns. We couldn't kind of get a good analysis of how the 2 were related to each other. And I estimated probably 90% of poor plans were probably caused by our inability to have these extended statistics. And Tomas was able to get these a couple of years ago. I think it went a long way. So now when people have problem queries, they have the tool of extended statistics, particularly if they've got 2 columns that are correlated. Now they can create extended statistics between the 2 columns and get much better statistics for the optimizer to use. But there was a limitation, particularly they could not be used for certain types of OR clauses until Postgres 14, and they couldn't be used for expressions. Tomas in Postgres 14 has fixed both of those, so now you can use extended statistics for OR clauses and expressions, which I think is taking it another level of sort of giving the optimizer that kind of information needs to get good estimates. And once it has good estimates, it's pretty good at generating good plans. And finally, this one is really kind of going to be a surprise. If you look at the release notes, this item isn't even like listed at the top of its section. It's like somewhere down in the middle of the section that relates to foreign tables and general performance. In fact, it looks like it's number 5 in a list of 10, right? So why am I picking an item that I wrote? Or no, I did the release notes. Why would I pick an item that I put so far down on the list? Well, this is one of those sort of long-term features that I think is very significant. As you may know, Postgres runs great on single machine. It runs great if you get a bigger machine. It runs great in a primary standby kind of setup. But a lot of workloads we're finding, if they have very high write volume, they can't exist on a single machine. It's just too big. It's too much data. Think petabytes of data, for example. And Postgres really, at least Postgres community, has not had a great answer for sort of multi-server or sharded workloads. Now I know Citus has worked on that. Greenplum has a version certainly that does it very well, but Community Postgres really didn't. And what I see this item as is a pretty big step in the direction of allowing us to improve our ability to shard data across multiple servers, where maybe 10% of your data is on the first server and 10% of your data is on the second server. Maybe you have 10 servers. And the ability for queries to be sent to a coordinator, as I'm showing you in the green triangle here, and the coordinator to send the queries down to the shards. The big change is that now you can send these queries in parallel to the shards. So now we can effectively support things like parallel aggregates, parallel sequential scans on these shards. I'm waiting for somebody to do some performance benchmarks of exactly what is possible if you take 10 machines and you sort of put them together and use partitioning and use all the push down capability we've been adding for years to foreign data wrappers to sort of see what capabilities. Now, because we don't have a global transaction manager or a global snapshot manager, this is not going to be very useful for write heavy parallelism, because you can't really do transactions across them real easy. You can with prepared transactions, but it's a little awkward. But I think for data analysis, I think this is going to be pretty big, and I'm curious to see what people are going to be able to do with this feature, because it's only been in a couple months. But once it gets into production, I'm really excited. So that's why this is sort of my closer. I don't know what value it's going to have right away, but it's a big step on the stages that we really started maybe 5 years ago of improving the way partitioning works, improving the way partitioning and particularly foreign data wrappers work, to allow for this parallelism now really starts to get Postgres into sort of a parallel server kind of capability, at least for read-only type of queries. So I think this is really interesting. I'm excited to see where it goes. That there's still a little more work to do, but I'm super excited. And this was done, I believe, mostly by the Japanese. I know Asan Hadi did a lot of sort of coordination with it, but a lot of it I think was Japanese team who did most of this work, and very impressive, very impressive. So that does conclude what I wanted to talk about. Again, I only picked 8 topics. There are 220 or 215 more in the release notes, and I'm sure you'll find something there to be excited about. But I just wanted to give you the things that I was excited about, so you kind of have a feeling of some of the stuff you might miss and why I think they're important. Great, thank you.
Okay, great. Thank you, Bruce. We're just waiting for Ilya.
Yeah, thank you. Thank you, Bruce.
Okay.
That was exciting as usual. And we have a couple of questions, actually. So one of the questions is very traditional. Are there any features in this version which almost done to the release, which you're excited about, but which didn't? So is there something you are missing in this version?
Yeah, there was one. I'm trying to remember what it was though. Yeah, there was one I was kind of bugging Heikki about. I was hoping he'd pick it up, and he didn't. And I hate to even mention it because I'm gonna probably embarrass somebody if I do. I probably embarrassed Heikki by even saying I bugged him about it. But yeah, there was one feature, but I can't remember what it was. I guess it wasn't. It must not have been that significant if I'm not like super upset about it. But Yeah, the one that I really wanted was the query ID, because that one for me had been laying around like forever. It just couldn't get. I think it went back to 2018 or 2000. It was at least 2 years old. Julian had been playing with this thing, and we just couldn't get it kind of over the finish line. And it just bothered me that it was so close. So fortunately, we got that one in. I don't remember what the other one was, but if I remember, I'll let you know. I don't remember what exactly, but it was one that Heikki had worked on.
Yeah, thank you. And we have another question, which is like very laconic. How about absurd?
Right. So I know that they're trying to get merge back into the code. Merge is a SQL standard. It isn't as useful as the on conflict clause, but I think merge has a good possibility of getting it, because there are some advantages to merge, and I think we did have some people working on that, but I haven't actually seen I haven't seen any work in the past couple months, and hopefully in 15. But upsert itself is a word I don't think is going to go anywhere, because I don't think there's a lot of value to that over having the two. If we have merge and on conflict, that's probably all we need.
Yeah, thank you. Another question, which I don't know, it's deleted now. I don't know if I need to ask that again, but yeah, the question was like, do we need to refresh materialized view in 14th? But I don't know if it's like.
Yeah, so that's a good one. That patch is still being worked on. The refresh materialized view. Well, we have refresh materialized view, but unfortunately, it rebuilds the whole thing, right? So it rebuilds it.
The person who asked that corrected the question actually.
Right. So they want more granular, granular refresh, and I think the Japanese had a patch for that, but it didn't get into 14. I remember seeing it, and I hoped it would get in. But for some reason it didn't, and I was kind of disappointed by that. That's one I was disappointed by. I thought that was kind of cool if they could do that. But it's still out there. The patch is still out there. It's still getting. What I actually ended up doing, because I'm not traveling as much, I ended up literally going out and looking at the commit fest and looking at what commit fest entries have been out there forever, and that's how I got on query ID. I was like, oh, this thing has somebody else before it 7 years ago, right? And B, we got a patch, but we just can't get it, because every time somebody tried to play with it, they would get stuck with, oh, well, what's the syntax, and how do we make it auto work with pgstat statements, and pgstat statements people don't want to do anything more. And it wasn't a technical problem. It was just a confusion problem, I guess, or I don't know what it was. But eventually everyone was happy. So I thought that was good.
Yeah, and at the same time, many external tools already have their own sort of query ID, which is like even synchronized between some of them. So basically, it's like very ridiculous that Postgres itself doesn't have query ID.
Yeah, and then some people are saying, well, they don't like the way Postgres does it, so like they want to do it some other way, and I'm like, okay, but let's just decide. Like, let's just, I don't care what we decide. Let's just decide something, right? So that was kind of my sort of way of looking at it. Let's just decide something and get something in the code. We already have something that works, so let's use that.
Yeah. Great. So, do we have any more questions? If someone's just typing, like wave me that I'm typing. Otherwise, oh, Yeah, that's just not a question. It's just thank you for the great presentation.
Great.
Great. So then we are always done. We will invite Bruce to the Slack channel with Q&A, just in case if someone forget to ask something. Thank you, Bruce. That's a great talk to finish the great thing.
Thank you.
Our elephant is just 25 years old yesterday, and
That's right.
yeah, that's right. And it would be actually quite better if we could celebrate this in person in St. Petersburg like 5 years ago.
Exactly what I was thinking. Yeah, somebody
Yeah.
yesterday reminded me. They said, didn't you do the 20th last, 5 years ago? I'm like, yes, I did, in St. Petersburg. Absolutely. Yep.
Yeah.
With the big cake, I remember.
Yeah, but hopefully next year we
That was
will
fun.
do
Yeah.
this. Great. Anyway, thank you, Bruce, and thanks for coming. Thanks for great talk. And
Yeah.
we'll
Thank you very much.
move to the closing ceremony.
My pleasure. Thank you,
Yeah.
folks. Bye-bye.
Thank you. So that's almost the end. Thank you, everyone, for
Yeah,
attending.
pretty much. Yeah, it was nice to be with you, with every one of you, for these 2 days. It was pretty intense.
So
Yeah, I'm not on the air. I know.
Bruce,
I'm
just
Okay,
remember it. What was that feature
No,
about?
Yeah, it was removing negative
Yeah,
cache
Bruce.
entries. Yeah.
Cache entry.
Yeah.
Yeah.
What happens is that right now when you have a negative cache entry, it just stays there forever. So I've been bugging Heikki to get that in, and hopefully we'll get in 15. But that's the one I missed. That's the one I was looking for.
Great, thank you.
Sure.
Yeah, now we're closing finally again. So
Right.
as we told, like it was really a pleasant surprise that so many people were actually attending the talks online. I was expecting like many people would just watching that later, but not that was not the case. Actually, many people were with us. We will make all the videos online soon. I would like to say thank you to all the team for those who make this technically possible.
There are
And thank you, Roman.
There are quite many people actually working. Yeah. Ilya is right to make a shout out to our team, because there are plenty of people working behind the scenes to like smooth all the edges while we're just basically sitting and talking here with Ilya. It is they who are doing the most of heavy lifting. So kudos to all of our team members for the help and making this happen. And yeah, likewise, thank you, Ilya, for co-hosting this wonderful event. As I've mentioned already many times, I hope we will meet again soon offline for next speech day, or even earlier if the situation allows for this to happen. And I guess this is time to say goodbye to everyone.
Yeah.
And yeah, see you next time.
See you next time. Thank you.